Okay, guys, good morning. Sorry for the slightly delayed start time. I thought we'd give people maximum time to come in. I'm Paul. I'm going to be running the admin today. So this is half an hour slots. Same thing as always. If you want to speak, please press and hold the button on your microphone. If you want to the recording continue. And with that, over to Matthew.
Thanks everyone for showing up at 9 a.m. on the last day of the conference. Really excited to get some feedback, and I've enjoyed watching all the presentations so far. So today we're going to talk about targeting aid after a natural disaster, which unfortunately is quite relevant again right now, given recent events in Morocco. In the development economics literature, there's a lot of work on how to target anti-poverty aid. People compare different technologies for targeting. You have proxy means testing, community-based targeting, some new papers using machine learning techniques and cell phone data and things like that. And the nice thing about that setting is you have a reasonably intuitive way of assessing whether the technology you're testing did a good job, which is, did it get those transfers to the poorest households in your region? When we think about disaster aid, our goal is not always to get the aid to the poorest households. You know, there's some notion of getting households back to the state that they were in before the disaster. So this paper has really got two components to it. The first is thinking deeply about what should our objective function be after a natural disaster. It's like a normative component to the paper. I'm going to show you a few different ones and how those influence the way we should do targeting. And then once we have a normative function, we can assess how well it does, meet how well different technologies for targeting do it, meeting that normative criteria. So, two main things that we might want to think about in terms of how we should target aid are households are going to differ in their exposure to the shock. So this picture on the left shows a landslide that happened after the 2015 Nepal earthquake that kind of destroyed half of this village while leaving the other half pretty much untouched. So that's obviously one relevant dimension of heterogeneity there. But households are also going to differ a lot in their ability to recover after the shock for a variety of reasons, including their pre-existing assets, access to credit and capital, and things like that. And we might want to take those differences into account as well if we want aid to do the most good possible. When it comes to disaster aid across the world, we almost exclusively target based on the former criteria, the direct property damages themselves. If anything, these percentages I've put up on the board here kind of underassess the fraction of aid in these disasters that was targeted explicitly at property damages, because the rest of the aid went to things like rebuilding government infrastructure and aid to firms and things like that. So in a lot of cases, including in the US with FEMA, you have to prove that you've experienced some physical property damages in the disaster in order to even be eligible for aid in the first place. What I'm going to argue in this paper is that this is a really bad way to allocate aid for a variety of reasons. So just a brief little roadmap, what I'm going to do. First, I'm going to talk a little bit about a measure of demand for reconstruction aid. This is what I'm going to use to assess welfare in my kind of main specifications. And the way you can think about this measure of demand is how much would households be willing to borrow from themselves in the future in order to have a little bit of extra liquidity in the present that can help them rebuild their house, meet their immediate consumption needs, basically smooth utility through the disaster. And I show in the paper that this measure of demand is equivalent to a social planner whose goal is not to redistribute wealth, but only to help households smooth the shock and kind of return to their pre-shock standard of living. And the way that I'm going to measure this demand is by calibrating a structural model of borrowing constrained households. And I'm going to test that model using a spatial regression discontinuity and kind of provide some evidence that the model is a reasonable approximation to the households in Nepal after the earthquake. And then secondly, I'm going to use that structural model to assess different counterfactual targeting strategies. And what they're going to show, kind of surprisingly, is that this firm criteria of making aid conditional on property damages does no better at increasing welfare than if you had just chosen the households to give aid to completely at random. And, this is important because in Nepal, they spent 1.5 years sending engineers to every village in the country, assessing the structural damage to the homes and making sure that they got this aid allocation exactly right. And if you believe my results, those kind of extensive targeting and assessment efforts were not necessarily worthwhile. Instead, as an alternative, if they hadn't targeted aid at all and instead divided the aid budget into smaller amounts and given it to every household in the affected area, completely untargeted, that would have increased the welfare, my preferred measure of welfare, by 45% relative to the purely random allocation. And this uniform strategy, this untargeted strategy, it actually performs well, even if you look at a very different social welfare function that puts more weight on poorer households. Some other strategies are going to differ depending on what your actual goal is, but this one does pretty well in both cases. And the reason for that is because utility functions are strongly concave. So making sure that every household has just a little bit of a buffer is a much more effective strategy than trying to target larger amount of aids based on imperfect proxies for need. And the intuition for this result might sound counterintuitive at first. The thing that some people think is, okay, maybe wealthy households have more property and it's more likely to be damaged. That's not exactly right. Actually, the primary thing that determined how damaged your house became was how close you were to the epicenter of the earthquake. But there's some correlations with some measures of poverty. So poor households were a little bit more likely to have physical damage to their homes. But the real reason that the property damage allocation really gets things wrong is it makes two different types of errors. The first is an error of inclusion. So you're giving aid to households that had property damage, but they would have been able to recover anyway. They could have drawn on forms of informal insurance, like remittances, savings, things like that, and they would have been able to recover whether or not they got the aid. And then you make these errors of exclusion, which are houses that maybe didn't have much property to begin with or faced other types of shocks as a result of the economic disruption of the earthquake. They're not eligible for aid under a property damage based allocation, but they might have really high need for aid anyway. And I see this as, maybe a little surprising, but really consistent with the literature that Namrata kind of masterfully summarized on, was that Monday or Tuesday? And Steffi talked a little bit about yesterday, which is that the climate change damages literature, we find almost universally that the exposure to the temperature shock is important, but not always the most important determinant of your need or how much that shock affects your welfare. You might think that if a property damage based allocation was going to work well anywhere, it would work well in this case, because by far the primary effect of the earthquake was to destroy housing. And these are the results of the post-disaster needs assessment in Nepal. That tall bar on the left is housing and human settlements. And this is why they decided in this case to prioritize housing as the main area of disaster response. Yeah. All right. You want to go back? Okay.
So are you gonna have anything to say whether like this insurance that these households have, the savings is going to respond to whatever so that savings rate is going to respond to like whatever the aid structure is? Okay.
Yeah, we'll get there. Yeah. Okay, so yeah, you might think property damages would be a good way. All right, so first I'm going to start out with some kind of descriptive statistics to motivate my model. The data that I'm using is a 3-year panel survey of rural households in Nepal after the earthquake, conducted by the World Bank. It's got really detailed modules on income, consumption, assets, things like that. And the first regression that I estimate, this is sometimes in the development literature called the Townsend regression. Basically, we're looking at conditional on a household fixed effect. So you can think of the household's average income and the aggregate shock. The VDC is the Village Development Committee. So we have those kind of space by year shocks. How much does a household's income correlate with its consumption? So the null hypothesis is that beta 1 is 0, and you would find that if households were perfectly insured to idiosyncratic risk, right? An idiosyncratic movement of income would have no correlation with consumption because households are perfectly smoothing over time. We find that actually households do smooth consumption decently well. It's not like a 1-for-1 drop, your income drops, your consumption drops, but not perfectly. So a 10% drop in your income, households are going to cut food consumption by about 1%. But more importantly, there's a lot of heterogeneity within the sample. So the politically powerful caste in Nepal, the Newari caste, land-rich households and households that have a migrant working abroad, these all seem to be better able to smooth consumption than households in the opposite categories. And perhaps interestingly, it doesn't seem like earthquake affected households smooth any differently than households that are not earthquake affected. Yeah. Measurement error. Yeah, there's a so you would have to think that you would have measurement error in one of these variables a lot more than the other one. Yeah, so people underreport income and things like that. Is that what you're thinking of?
I'm just like to the extent that that's like the less than perfect correlation. There's more measurement error in income consumption, which I guess
There's more measurement error. What?
in income, which I
Yeah.
guess,
Right. So you might think that they're actually smoothing a little bit better than this. Yeah, which fine, I'm not like attached to the magnitude here. The important thing is that there's heterogeneity, and unless the measurement error is different across caste, which maybe you could think of reasons why that's the case, but I think of this as more descriptive than So secondly, we look at the ways in which households,
Sorry. The measurement error on the right-hand side.
Yeah.
It's gonna bias you.
Yeah, that's right. So it's going to make you think that households are more insured than they actually. Yeah, you're right. Sorry.
Right. So
Yeah.
that would be normal. So
Yeah, so they might be less insured. Yeah, that's a good point. Yep. Right. Just descriptives here. So now we're going to look at how those idiosyncratic income shocks correlate with different forms of transfer income, and this kind of tells us a little bit about what are the methods households are using in order to smooth consumption when faced with these income shocks. What we see is that if you have a positive income shock, so if you have a better than average year, your savings go up, your cash savings go up, but your remittances go down. You're less likely to have a household member migrate, and you're less likely to take out loans. Whereas if you have a bad year, you're more likely to draw on remittances, migration, and loans in order to help you smooth and meet that gap. But one interesting thing is that these strategies don't seem to be like unlimited in their supply of credit. So if you received remittances last year, or if you received a loan last year, conditional on the same income shock this year, you're going to get less of those in the current year. So this is kind of a little bit of descriptive evidence in favor of borrowing constraints, right? Like if I borrowed from my relative last year and I have another bad year this year, I might not be able to get as much as I did last year from them again. And then now conditional on the aggregate shock, the village year fixed effect, we can look at how the earthquake damages and how the transfers correlate with different household characteristics within the village. This kind of tells us about within a village, who faced the most damages, what types of households face the most damages, and also which types of households are most able to draw upon these forms of informal insurance, right? So what we find is that, these regressions are really noisy, but the earthquake damages were on average slightly lower for wealthier households, more educated households, higher caste households. But also very interestingly, that conditional on that aggregate shock, wealthy households are more able to draw upon remittances, more likely to migrate, and more likely to take out loans than poorer households. So kind of evidence that these borrowing constraints vary even within a village across different households. So I use those descriptive facts to motivate this structural model. I'm not going to put the equations up today, but happy to talk more in detail about it later. the basic idea of the model is you have risk-averse households, and they're heterogeneous amongst three dimensions. So they can be heterogeneous in their wealth, which is like savings or access to insurance or access to credit. They differ in their expected income, and they're going to vary in their housing stock. Okay. So in each period, the households receive a random draw from the income process, and they're going to make decisions about consumption, how much to invest in their housing stock, and how much to borrow or save in case of a bad shock in a future period. Importantly, the households face a borrowing constraint, so they're not fully insured against these idiosyncratic shocks. And basically the earthquake, the primary effect, as we showed in that bar graph at the beginning of the presentation, is that it's going to destroy the housing stock. And I'm going to model aid as increasing the amount of cash that households have on hand at the beginning of the period that they can then allocate to consumption, housing stock, or borrowing and savings. So, one important thing to think about in this model is that the income is exogenous, which is like a reasonably common assumption in rural agricultural models of where you can think about these idiosyncratic shocks as like weather shocks or something like that. Later, we can discuss what would happen if you relax that assumption a bit. So I calibrate this model using the survey data and the generalized method of moments, where we have, we observe how much households are consuming in food and how much they're investing in their housing stock in the data. We also observe the value of their housing stock, and we estimate their expected income using a vector of characteristics that are exogenous to the earthquake, like family size, pre-earthquake migration history, size of their land holdings, things like that. And then in terms of the wealth variable, which is really important because this is going to be how well insured the households are, we're going to add up basically everything that households use to smooth these shocks, which is going to include the cash savings and things on and cash on hand and bank assets and things like that, but also access to loans and informal credit, remittances, and jewelry, which is also sometimes suggested to be an important savings vehicle in this setting. Yep.
So you didn't mention migration, you mentioned remittances, but not migration.
Yeah.
Do you think it's the same? Like remittances?
Yeah.
Just like reduce migration.
Yeah, right.
This migration, like people are actually.
Yeah, so the model, like this, it's not explicit in the model, but the way I'm kind of categorizing those variables is like there's a permanent migration, which is your relative is in the UAE for years before the earthquake, and they're sending remittances back, and that would be kind of access to wealth. And then if you send a family member to Kathmandu for like temporary migration to kind of make up this gap, that would go into your expected income. So that's just the way that I kind of partition. It would be nice to have a more explicit migration component to the model, but yeah, it's a beast to calibrate as it is. So. All right, so the reason that we have this model is so that we can measure this notion of demand for reconstruction aid that I teased at the beginning of the presentation. So thinking about this measure of demand, I want to talk about some of the alternative measures that you could think about in this setting that might also be relevant. So first of all, the utilitarian social welfare function that's common in the anti-poverty literature. This is going to put the most weight on the poorest households in the sample, right? Which, might be fine. That might actually be your social welfare function. But if it is, then there's not going to be any reason to try to target households based on earthquake damages. You want to target based on poverty, which may or may not correlate with earthquake damages. So, I'm going to show the results to the utilitarian social welfare function, but wanted to think of some alternatives as well. The other most common measure of welfare that we use is willingness to pay, but that's hard to think about in terms of what's your willingness to pay for cash aid. Willingness to pay for $10 is $10 usually. Though Banerjee has the paper showing when it's not. But yeah, that makes it a bit difficult. So instead, you can think of this measure of demand as kind of like a measure of demand for liquidity. how much would I be willing, like what sort of tax would I be willing to pay on my future income, or what kind of interest rate would I be willing to pay on a loan in order to have a little bit of liquidity that can help me smooth through this disaster. And the interesting thing is that in expectation, these households could eventually repay these loans, but because of the market failures, nobody's willing to make a loan even at a very high interest rate. For those integrated assessment modelers in the room, it's very interesting. This social welfare function is going to choose households that have the highest elasticity of substitution between aid and their expected income, which this looks very much like the Negishi weighted social welfare function. So the Negishi weighted social welfare function, the only difference would be that in the denominator you have delta V over delta Y, and here you have delta V over delta EY. So it's, you know, not your elasticity with respect to income, but your elasticity with respect to expected income. Yes, Effie.
How we think about aid or providing credit?
Yeah, and
Nothing motivating aid.
so I'm thinking of aid as like, it's like a credit facility that you don't have to pay back, right? So your demand for aid is, in this model, is like your demand for credit, basically. But, you know, it's aid, so you don't ever have to pay that loan back. But it, you know, it is suggestive that if you believe this, then like, you know, better financial markets will help people cope with disasters better, which there are plenty of papers showing that exact thing, right? That in markets where access to credit is much smoother and less constrained, that people are able to cope a little bit better. So is this like a reasonable way to think about demand for disaster aid? So one way to think about it is that this would be the market allocation of aid if you were able to solve the market failure, right? If you removed that borrowing constraint, the households with the highest willingness to pay for aid are the ones that would get liquidity. But because of the market failure, it kind of separates your willingness to pay for something from your ability to pay for something. You might be willing to pay 20% on a loan, but nobody's going to give you that loan. There's no lender that's willing to make it. You know, it's intertemporal Calder-Hicks efficient, which means that, you know, if you could make transfers from future households to present households, then you could make everyone better off. But it is regressive in the same way that Negishi weights are regressive, in that you're basically weighting households by their earning power. So it's not going to be redistributive. You're going to freeze the distribution of expected lifetime wealth in the area. The other key thing to think about is that it's not explicit in any sense about the importance of the disaster versus other types of hardship. So if a household in my sample has high willingness to pay for aid, I'm not going to be able to exactly say that that is because of the earthquake. They might have, you know, faced a loss of cattle or a harvest failure or something like that, and have high willingness to pay for aid for that reason. So I think one way to interpret this the results with that in mind is that this is kind of thinking about, you know, how much of a component of the hardship that the households in this area face is due to the earthquake, in some sense. Yeah. Mhm.
The idea of the policy is really just to overcome this liquidity constraint,
Yeah.
not any redistribution and contract, right?
Yeah.
You could also imagine a policymaker who has the idea, no, I really want to restore exactly the state that we had before.
Yeah.
And what I used aid for.
Yeah.
So I'm not wondering whether you can use the model and to invert aid that you see in the data to
Inform some weights.
To welfare function that the policymaker has in mind.
That's
Is
yeah.
really just overcoming the liquidity constraint, or are there some
I can tell you exactly what the social welfare function that they have in mind is. It's a social welfare function where it's 1 if the household faced property damages and 0 if they did not. So basically, you know, if you take that social welfare function as a given, then obviously targeting based on property damages is the right thing to do. I think the question is like, what other notions of welfare does that sort of targeting accomplish? And what I'm trying to show is that it really doesn't. Yeah.
Just because you value to the social protection.
Yeah,
That's so in many social programs you have targeting that's done locally, so you've got a big budget that's going to the local community. They have to be distributed.
Mhm.
Then you see social welfare ways that are interesting and different. So
Yeah.
that can be interesting. Fine, maybe that program, maybe that centralized.
Yeah, it was. Yeah.
But I think exploring like other possibilities.
Yeah, I think it would be really interesting to think about whether community-based targeting or something like that could have done a better job, but I don't. Yeah, that's right. But I don't really have, you would have to have a very different model to assess that question. Yeah. Okay, 5 minutes. All right. Oh, boy. All right. So the structural model makes a couple of testable predictions, right? It suggests that aid should basically increase households' consumption and housing investment, but possibly by less than the full amount of aid if households are partially smoothing. We can also look and see whether the insurance mechanisms that households are using are the ones that I've tried to capture in the model. Also, an important characteristic of this program is that households were supposed to use the aid for rebuilding housing, but the model predicts a certain degree of fungibility and that households will increase consumption as well, not just use the aid for investment in housing. And then the exogenous income assumption that I talked a little bit about earlier. So I can test some of these using a spatial regression discontinuity approach. Basically, the idea here is that the aid program was prioritized for the red and orange districts on the map, which were deemed to be the most hard hit districts by the earthquake. And households inside those districts received more aid and received aid more quickly than households outside those districts. So by comparing households very close to the border of those district boundaries, you can look at households that experience similar effects from the earthquake, but had different probabilities of receiving aid. And the first stage is quite strong. You can see that, being on this side of the border made you about 40 to 50 percentage points more likely to receive aid. There's a good amount of noise and curvature near the border, so we add some controls to the regressions and it increases our power a little bit, and the results basically hold with a bit more precision. And sorry, bin scatter, yeah. So of course, in order to properly identify the effects of aid, we have to assume that nothing else is changing at the border, nothing geographic, demographic, political, or anything like that. So I try to show some evidence from a variety of placebo tests that is in fact the case. So we don't see a big difference in earthquake intensity on either side of the border. When you just look at the discontinuity, obviously as you get further away from the epicenter, the damages go down, but right at the border, there doesn't appear to be any real discontinuity. In terms of, you might be worried about selection biases, whether households out migrate or something like that. But in terms of the fraction of households that always lived in the district and the number of household members, this is actually including the migrant roster, which is important because, households might send one of their members to migrate as a response to the earthquake or getting aid or not. But including migrants, the size of the households is pretty continuous at the border. And the aid doesn't really seem to substitute for other public transfers. There's not really a robust social safety net in Nepal. So it's not like it was substituting for other public programs. The number of households that received NGO aid in the sample is really small, but there's no discontinuity there at the border either. And as kind of a proxy for public service provision, I look at the travel time to the nearest health clinic and the nearest market. And these are a bit noisy, but no obvious discontinuities at the border. This is after. Would you expect not discontinuously? Yeah. Okay. All right. So we do see really quickly, increase in housing investment as a result of getting aid. We do see positive effects on food consumption as a result of getting aid. Effects on income are noisy, sometimes significant, sometimes not, depending on the specification, but not really strong evidence either way. And total savings also doesn't really change that much at the border. we do see a big drop in remittances. So households that got aid were less likely to receive remittances or received less remittances than households that didn't. And in some specifications, they were less likely to send a migrant member as well, giving some evidence that these are indeed the mechanisms that households are using to smooth consumption. When I compare the regression discontinuity estimates in the top row to the model predictions, like you can simulate in the model what the effects of aid would be, it's interesting. They're reasonably close. In particular, the effect that I observe on remittances is almost identical to the effect on borrowing and savings that the model would predict. The kind of relative effects on food consumption and housing investment are pretty similar, although the model predicts a slightly more muted effect than I find in the RD estimates. So I think of this as just kind of giving a little bit of evidence that the basic structure of the model is capturing something real about the way that households are valuing these relative components. Okay, and then I'll just wrap up with the counterfactuals really quickly. So we can simulate, the willingness to pay in the model for households to receive aid. You find that the damage-based allocation is about 5 percentage points better than if you completely just chose the households at random. The actual allocation, they did a pretty good job of targeting damages. It's pretty much the same. It's not really corruption as being a big deal here. The higher bar, the light blue bar here, is relative consumption. So this is your consumption relative to your expected income. So these are households that have low consumption relative to what we think they should be able to consume based on their income. So they're households that are kind of facing an immediate shortfall. They might be wealthy in the future, but they're not wealthy now. So they have low consumption now, and they have high willingness to pay for aid. So it's kind of a measure of acute deprivation, you can think about it. But if you instead didn't try to target at all, because that obvious acute shortfall is a really hard thing to observe and target aid towards, and instead you just divided aid up and gave it to all of the households in the affected area, you get almost all the way to the optimal allocation. Okay, that's the end. And happy to talk more about it afterwards. Thank you.
Great. Hi, everyone. Thanks for coming. My name is Abby Ostriker. I'm really pleased to be here today to present this project. It's joint work with my former classmate at MIT, Anna Russo. She is on the job market this year. And the project is about the effects of floodplain regulation on housing markets. So to motivate the project, I want to start by noting that flooding is a major source of damages across the world. And unfortunately, every time I give this talk, it's very easy to update with another picture of the most recent flooding. I think there's been particularly devastating flooding this week in Libya, so this is a picture of that. But there have been estimates that global flood losses might reach $1 trillion per year by 2050 if additional kind of adaptation to global warming and addressing kind of population growth isn't implemented. So this is, hopefully I've convinced you, a very big deal. And this problem is made worse because home buyers might not necessarily be choosing their locations optimally or their levels of adaptation optimally. So there's a lot of evidence that there are market frictions that introduce a wedge between what consumers are willing to pay to avoid flood risk and the actual cost of the risk itself. So issues such as moral hazard from the government's obligation to provide disaster aid and internalities like information frictions have been documented in a number of settings. And I'm not going to go into all of this evidence today, but one striking statistic is that in the US, which is going to be the focus of this project, the take-up of highly subsidized flood insurance, even in very high-risk areas, is only 50%. And so it's easy to imagine that demand for other forms of adaptation, like elevating your house or moving to a safer location, could be too low as well. So in the US, the historical policy response to these issues has been a policy of a threshold form. So the government will designate particularly high-risk zones as special flood hazard areas, SFHAs, I'll call these flood zones. And in these flood zones, new buildings are required to be more flood resistant, and risk is signaled to home buyers in various ways. And so the first goal of this project is to ask whether this policy is effective in reducing flood risk. And to be comprehensive, we're going to look at its impacts both on the margin of kind of elevation, the adaptation in the risky areas, which has been looked at in a couple of recent papers as well. But also, we're going to look at the effect on the location margin, so the extensive margin of where a house is built. And this has been less well studied, although shout out to Alan, who was here earlier this week. He's looking at this in Jakarta as well. But we think that the actual physical location of where a building is a very important driver of risk. And so quantifying this margin is important. Then for the second part of the project, we're going to look at how the policies how the policy might introduce costs to home developers and to home buyers that could erode any benefits of the policy itself. And so specifically, we're going to benchmark the policy's impacts on welfare to the maximum possible gains from regulation, theoretically, which we think of as coming from a location-specific tax that's equal to the uninternalized damages in each spot. Okay, so to answer these questions, we're going to take a two-pronged approach. In the first part, we're going to show you some evidence on the causal impacts of the policy on both of these margins. So for the extensive margin of location, we're going to compare land use across a historical flood zone boundary. And then for the intensive margin of the policy's effect on adaptation, we're going to compare elevation and damages inside the risky area, but before and after this policy is introduced. And so what we're going to find is that the policy actually strongly shifts behavior on both margins in the risk reducing direction, but we also find evidence that it's going to introduce costs to the developers and the consumers. But then we're going to embed these estimates into a model of the housing market that's going to allow us to account for how risk and amenities vary across space. And so how welfare is going to change once you incorporate those changing implications. And it's also going to allow us to quantify the overall welfare impacts of the policy. So the first thing it's going to let us do is estimate the direct costs of regulation of the policy to developers and to home buyers. So inside the flood zone, how the supply and demand curves shift as a result of being regulated. And it's also going to allow us to get at the indirect amenity costs and risk benefits of shifting the locations of where housing is built. And so the key parameters for this model are going to be these direct costs of the regulation inside the flood zones. And we're going to estimate those by matching our model to the reduced form spatial regression discontinuity estimates from the first part. And then we're going to use that model to evaluate some positive and normative outcomes for the current policy and the optimal tax relative to an unregulated benchmark. And we're going to find that the current policy actually does a pretty good job at reducing damages. It does so by about the same amount as the optimal tax, but it introduces much greater costs, and that's because the policy is, as we have it today, is less well checked. So with that introduction done, you're welcome to jump in with questions, but just as a roadmap, I'll talk about the setting and data and then discuss the marginal estimates, the model, and what we learned. Okay. So the policy that we're studying here is embedded in the National Flood Insurance Program, which is a policy introduced at the federal level in 1968. For communities that participate in this program, the government will draw maps that identify these flood zones and apply certain regulations. So inside the flood zone, annual flood insurance premiums are at least twice as large, and many homeowners have to buy flood insurance. And on the supply side, the main thing is that houses have to be elevated to a certain level. So we're going to focus this specifically on the state of Florida because it's both populous and highly flood prone. It has 35% of the nation's flood insurance policy. Then we're going to bring in a lot of data. So we need, first of all, the boundaries of the flood zones. And to satisfy our kind of identifying assumptions, we're going to bring in these boundaries for the first flood maps that were ever drawn in Florida. And this happened when the maps were first drawn in the late 1970s, early 1980s. And to get these, we digitized archival maps for 11 counties. We're then going to bring in some spatially granular data on land use. Importantly, we have this both from the time that the original maps were drawn, and we have them, of course, for the modern day. We're going to pair this with granular data on sales prices from the Florida Property Tax Assessor's Office. We're also going to use insurance policies and claims. These are publicly available from the National Flood Insurance Program. For the welfare analysis, we're going to have spatially granular data on flood risk, which we take to be kind of the ground truth. And this is from the the First Street Foundation, which is a nonprofit devoted to quantifying and communicating flood risk. Okay. So the first part of the analysis, as I mentioned, is going to be looking at this extensive margin of building location. So we want to estimate the effect of being designated as a flood zone on how many new houses are built. And of course, we have the problem, which is that flood risk and local amenities are likely correlated with both flood zone status and development. And so to get around this, we're going to leverage the boundaries of the flood zones. And specifically, we're going to use the historical flood zones with the understanding that at the time that the maps were drawn, the flood mapping technology was sufficiently coarse that the exact location of the boundary was as good as random within a small window. And so the flood risk and local amenity at that time were going to be smoothed through this boundary. And the only difference is going to be the flood zone status. And so here, to back up this assumption, I'm showing you a graph of the development at the time that the map was drawn. That's on the y-axis. The x-axis is distance to the original flood zone boundary. The right-hand side is going to be inside the flood zone, and these dots are bin scatter dots. They're averages within these bins overlaid on a 4th degree polynomial that's separately estimated on either side of the boundary. So here you can see, even though there is less development far inside the flood zone, the average is smooth through the boundary. And when we estimate the classic specification with a level shift at the boundary, we're going to find a pretty tight null estimate. So we find that we take this to be very strong evidence supporting the identifying assumptions of this strategy. And so then when we look at share of land that's developed as of 2016, now we find that there's a really big jump at the boundary. Yes.
Oh, not to interrupt, but can we think of the flood maps as like exogenous in the sense of there was no local bargaining about don't put me in the zone?
Yeah, so the original maps were kind of produced by basically engineers, and then later on, as they have been updated, it's become kind of more contentious. And so we think that many of these updates to the flood maps could be, specific to many factors. So that was another reason that we wanted to go back to the first ones that were ever drawn. Yeah, thanks. Yes. We're going to get into that. Yeah. So the point estimate here is a reduction of about 4 percentage points in the share of land that's developed. That's about 9% of the outside flood zone share of land developed, and it's a reduction in new construction of about 18%. And so we take this to indicate that this flood zone designation is really shifting new construction from inside the flood zone to outside. And of course, this could be reducing risk a lot, hopefully, if they, if the maps are at all accurate. But It can also be moving consumers from their revealed more preferred locations inside the flood zone to less preferred locations. And so that's kind of a cost benefit trade-off that we don't know exactly like on which side of that trade-off that we're living on. Okay.
Should we think of some of the messiness around the border as because the flood zone has changed designation over time?
So the flood zone has changed designation over time, but I think that this is actually quite a sharp change at this boundary. I think
I guess my first thought was that
Mhm.
the boundary change is like massively underestimating the real sort of effect here, like the gap between the left-hand side and the right-hand side.
yes, this could be a bit of an underestimate. Yeah.
I mean, developers say like, hey, if we in a marginal location, we need market like very close to the boundary, and as well, we want to develop to the side outside of Donaldson, but if we really infra marginal, we really people that the platform, so hey, it's something new.
So you're saying if you are that like basically the effect could change as you're going deeper in.
There's a clear, sharp disconsistency. I'm just wondering how, if it's like a really local treatment effect, it's just kind of around the boundary, and it's probably going to be hard to say anything about it.
No, this is completely fair. We are really only estimating a kind of local average treatment effect. What I will say is that when we get to the structural model, we're going to estimate this. We're going to kind of create zones that are very close to the boundary, estimate in there, and then we're going to kind of basically just have to assume that this effect is like equal everywhere. Is basically the best we can do. But yeah, thank you for pointing that out. Okay, so we've talked already about the trade-off on the extensive margin between risk and amenities. There's also going to be evidence of trade-off on the intensive margin of elevation. I think for reasons of time, I'm not going to get into all of this today, but we do have some evidence that we take to interpret that the building code is increasing supply costs inside the flood zone because we find that housing prices are also 6% higher right on the inside part of the regression discontinuity. And we're also going to find that it does introduce some benefits. So when we look at the event study, we find that houses that were built just after the policy was introduced are 30 percentage points more likely to be elevated, and damages overall are lower by about $400 per house per year. So we have kind of trade-offs on both of these margins, but we still don't know the overall impact of the policy for a couple of reasons. So first of all, we know that the policy is shifting housing from inside the flood zone to outside. We don't know whether that's being shifted to equally risky or much safer areas. Similarly, we also don't know how the amenities compare across these areas. People could be moving to almost equally pleasant or much lower amenities. And finally, we have some kind of suggestive evidence on the costs, but we don't know yet how large these direct costs of regulation are to either supply or demand. And so this is going to motivate our model of the housing. So just a kind of quick intuition for how this model is going to work. Basically, we're just going to model the policy as shifting the supply and demand inside the flood zone. We're going to be able to kind of break that effect that I showed you down into an impact on supply and on demand by making some assumptions about the demand and supply effectively elasticity. So given an assumption about the shape of the demand and the supply curves, observing the equilibrium house price and quantity on either side of the boundary is going to allow us to back up the shift.
Should I consider this policy is trying to correct the market?
Yes. So like moral hazard from people expecting the government to provide aid, even if they're in a risky area, or simply, information processing, internalities, either of those could motivate this intervention. Yeah. Yes.
Maybe I can.
Okay. Okay. Great. Okay. So we're going to have a pretty simple model for demand. This is just going to be a kind of low chip specification. Consumers are going to be choosing between housing, which is located in locations that are differentiated by the census tract J and flood zone Z. So their utility for a place will be a function of the price of housing in this location, whether it is designated as a flood zone, and there's going to be a term on that fee, which is going to be the cost of the policy, the cost of the regulation to demand. And this is going to capture both financial and non-financial costs of the policy, like anxiety of living in a flood zone or hassle costs, plus maybe a debiasing effect, which we think of as not actually affecting, welfare, but could affect the decision to live in a place. So that will come up more later. We're going to allow for there to be an unobserved amenity for each place that can be correlated with the flood zone status. And of course, an idiosyncratic preference shock. On the supply side, we're going to, for simplicity, model land or housing as being supplied statically in 2 time periods, before and after the policy introduction. To capture the fact that it becomes more expensive to build housing as more housing is built, we're going to model the supply of housing as normal CBF, where the share of land that's developed, Q, is a function again of the price of housing, an indicator E for that whether the house has to be elevated because of the regulation. That's got a term C or psi on it, which is the cost of doing this elevation. Mu and sigma are going to parameterize the shape of the supply curve in each tract, and eta will be unobserved construction cost, which we will also allow to be correlated with the flood zone status. So of course, the classic problem is that we have these unobserved terms that can be correlated with the flood zone status, and will complicate our estimation of the terms that we're interested in, the supply and demand shifts. So to actually identify these, we're going to leverage our assumption from the first part of the work and say that in a small window around the flood zone boundary, the modeled cross-border price and quantity differences are going to exactly equal our reduced form regression discontinuity estimates. The demand elasticity alpha will just be calibrated to a value from a recent paper. Supply parameters also are going to be matched to some recent estimates. So when we do this, what do we find? In words, we find that the consumer and producer costs of being regulated are quite high. So relative to an otherwise identical house outside the flood zone, a house inside the flood zone would have to be 23% cheaper to achieve equivalent demand and 25% more expensive for a supplier to want to build it. But to think about these numbers in terms of kind of real world outcomes, we're going to look at some counterfactuals. So as I foreshadowed, the counterfactuals we'll be thinking about will be, first of all, a no regulation benchmark. So in this, we just kill the policy term, step n equals to 0. You can think of this as a setting in which there's no elevation requirement, no insurance mandate, so no risk signals to consumers, basically no regulation. The current policy is, of course, the status quo. And then the corrective tax will be a setting in which we also kill these policy cost parameters, but we replace them with a tax, which varies with both location and elevation status. It's equal to the uninternalized costs of flooding, and we'll assume that houses, for simplicity, houses are elevated if the cost of doing so is less than the benefit of doing so. And so that's going to set the tax. Okay. So the first thing we wanted to use this month, yes. So we are not taking a stance on like how much of the distortion is like moral hazard versus internality. But it is saying that like the correction is like 23% of the value of the house, but it could be, people could be overcorrecting. People could be like, the policy could be introducing additional kind of costs because of that. Like I mentioned, the kind of anxiety cost of just like knowing you're in a flood zone. I would say like, the ideal thing, right, would be for the cost to be exactly equaling whatever that size of the uninternalized damages is, right? And so that's what we're trying to recreate in the corrective tax. The 23% is like not necessarily equal to it's not a measurement of the like more the wedge between the willingness to pay and the access. Okay, yes.
Do we worry, or does it matter if the people who are just outside the boundary, they sort of have an additional amenity value because there's like less construction in front between them and the ocean, effectively.
Yeah.
Matter for the estimate?
That would probably be another reason that the local treatment effect is not going to match the it might not be the same kind of as we move away from the boundary. Unfortunately, I don't think we're able to say very much about that. But so basically whatever, yeah, I think that's unfortunately the case.
So we might worry that there's a value, that's an additional value of being like outside the flood zone, outside of it.
Yeah, so that would cause us basically to be underestimating the cost that we estimate here, because there will be like a true cost, and then that's kind of bumped down if there's any additional. Yes.
That's
Okay.
my question, because it's related to a few comments geez, so you have this like of the boundary, but then you're doing as if the estimate was just the cost for the zone that's inside. But obviously there are benefits to those that are outside. So just thinking of the supply shifting. So you're saying the prices are 6% higher inside than outside. Could be because prices have decreased outside. So it's a related effect.
Yes. So that's also why we kind of estimate the cost in this whole model to account for the fact that like prices on either side might be adjusting as demand is kind of shifting.
But you're not taking, it's not an equilibrium, it's not a spatial equilibrium model.
Yes, it is.
Sorry.
Yes, it is. Sorry, I wasn't clear about that. Yes, it's a spatial equilibrium model. People are choosing between different locations within a county. And so
The supply.
Oh, the supply but the supply is responding to demand that does change across space.
But you see
You don't like that?
Okay.
Okay, thank you.
Yes, no, but I think it's going to matter a lot because you're going to be very unfair to the policy.
Okay. Can I catch up with more with you afterwards? Thank you. Yeah, thanks. Okay, 5 minutes, great. Okay, so the first thing that we wanted to use the model to do was to evaluate the impacts of the policy on damages. And so this table is showing the impacts for the current policy and the corrective tax relative to the unregulated benchmark. So this first line is going to be the present discounted value per house of damages that are reduced. And you can see that the current policy reduces a large amount of damages, about $7,500 per house, which is about a 60% reduction relative to the baseline. And about 1/4 of this is attributable to relocation. And these are about the same as what we see in the right-hand side for the corrective tax. So this policy is actually achieving almost exactly the same benefits of the corrective tax. Although this last line is going to show us it's maybe doing it in a slightly roundabout way, which is that so the current policy achieves these risk reductions in part via a reduction of new construction on land designated as risky, so in the flood zone of about 15.5%, whereas the corrective tax only reduces new housing in this area by about half that amount. So we can think of this as saying that the current policy is more distortionary than the corrective tax. To quantify the impact of this on welfare, we're going to define social welfare as consumer and producer surplus minus the uninternalized flood damages.
And we're going to kind of add up all of those components. So again, I have here the outcomes for the kind of welfare relevant outcomes for the current policy and the corrective tax, again, relative to the unregulated benchmark. The current policy column is going to be the best case scenario for this policy, where we think that the corrective term, like the cost to consumers, is entirely debiasing, so not actually impacting their welfare other than through their decision of where to locate. So the damages is the first line. We already talked about this. They're very similar for both of these two policies. The damages are offset by some relatively small reductions in producer surplus, and they have really large reductions in consumer surplus, even when we add back any revenue that might happen kind of through either of these programs. And so it turns out that when you add everything up, the welfare benefit to the current policy is, even in this best case scenario, only about 1/10 of the maximum possible gains from regulation. And again, as I alluded to at the beginning, this is because this policy is kind of a binary threshold format. And so we're going to be overcorrecting the moderately risky areas and undercorrecting.
I'm going to be with the tax and
Same thing. Yeah. Okay. So just to wrap up, I think that I want to say that Anna and I started this project because, as you know, global warming is increasing the occurrence and damages of natural disasters. We're hearing more and more this question of whether we are living in the right places, you know, whether people, you know that kind of Florida is a very risky area, or whether they don't know and need to be kind of corrected. And so I think there's a lot of evidence that this policy, that there is a role for policy here. And what we've shown is that the design of the policy really matters. So you can have a second best policy, which is achieving actually the same amount of damage reduction as the first best, but these benefits are being offset by costs of the policy. And so as a result, we could, by better targeting this policy, still achieve the gains of policy regulation, of correcting these kind of issues, but more cheaply balance out the natural beauty of Florida with its disaster risk. Okay, thank you.
Hi everyone, thank you very much for being around on the last day of the conference. I'm Ruozi Song, and I'm very glad to be here. So today I'm going to talk about the project, how we think about firm heterogeneity and design environmental regulations, especially their multidimensional firm heterogeneity, and whether and how we can incorporate that into the design of the policy. So to be more specific, from the literature, we do know that there exists a substantial firm heterogeneity, even within narrowly defined industries. For example, firms are very different in their productivity. They can also be different in their emission intensity as well as market power. So in the US, in the manufacturer industry in the US, if we think about the firms at 90th percentile in terms of their productivity, TFP, they are 150% more than firms that are located at the 10th percentile in terms of the TFP measure. But if we think about emission productivity or like emission intensity, the difference is even larger. So for firms who are located at 90th percentile, their emission productivity is 500% more than firms located in the 10th percentile of the emission intensity. So given that firms are even more heterogeneous on their emission productivity, whether we should care about this when we design the environmental regulations. So just to step back a little bit, why do we care about firm heterogeneity when we design the emission taxation or Gueyon taxation? So let's come back to the Econ 101. In an ideal case, we want to equalize marginal cost with tax rate with marginal social benefit. But in the real world, normally we have very spatially uniform emissions taxation. For example, we have provincial level or even national level emissions taxation. But the benefits, the marginal social benefits of pollution abatement is going to be very low. So it varies a lot across locations, depends on like population density or income level or many other factors. So in this case, in this kind of world, how we design the tax rate, how we design the emission taxation, whether it's going to be just the average of marginal social benefit, or there's something more into this design of the optimal taxation. So this is the research question of the project, which is trying to incorporating this spatial firm heterogeneity and to see whether this can create first order welfare effects of the emission taxation. So the context of the paper is going to be the Chinese cement industry. So cement industry sounds like a kind of cliche when we study like from IO perspective, but there are some nice features of cement industry. So for example, they have, due to this high transportation cost, we have this spatial competition among cement firms, and also firms are scattered across space. That means firm heterogeneity can be mapped into this spatial heterogeneity. And second, I'm going to make use of this the policy variation here to get a sense of how firms are different and how much difference they show and whether this matters. So the policy here is basically this the emissions taxation. It has both spatial variation as well as time variation. So the tax rate changes over time, and they are very different at different locations. So let me just give you a little bit preview of the project. First, I do show that firms show substantial heterogeneity in terms of their size, and then the prices they're going to charge, which is related to market power, as well as their emission intensity. So through reduced form analysis, we can see there are certain patterns of this firm's abatement behavior. So first of all, there's a trade-off between output of firms and how green the technology is. So for firms who are more likely to decrease their output in order to comply with the taxation, their emission intensity is not going to reduce that more. So in other words, if we think about firms who face relatively lower cost to reduce pollution, then they would rather reduce their emission intensity than reducing their output. So this is the first trade-off. And another channel, which is also very interesting or very important in this kind of concentrated industry, is the price change. So for firms with relatively higher market power, they are also able to change their price to comply with the taxation. So if firms, we also show that if firms have relatively higher market power, so I will define the market power here a little bit later, but for firms with higher market power, they're able to increase their price if high. So this is also a kind of channel that is very important in the polluting industry. So after we show the firm heterogeneity here, then why this should matter for policy design? That's why I construct this partial equilibrium model with heterogeneity of firms in terms of their cost structure or market power. So cost structure and market power are basically equivalent here. And then from the model, I show that the optimal taxation depends on three factors. The first one is a very conventional average benefit. That's the first factor. And second is also studied by Foley and al. In 2016 JPE paper, where market power also matters for the optimal taxation. So this intuition is that when there's already a distortion in the market, when firms are already having market power in the polluting industry, we do not want to have a super high tax here to further exacerbate the market distortion here. That's the second factor. And the third factor, which I show here, is basically the correlation between cost and benefit. The reason why we have this correlation is because the firm's abatement cost can be very local, or they can be very different across different locations. And the benefit of pollution abatement is also can be different across locations. So we have this correlation term. So think about when the correlation is negative, meaning that when firms have relatively lower costs to reduce their pollution, but at the same time, the benefits are higher. If this is the case, we want to design a relatively more stringent emission taxation. That's why the third term shows up here as well. So once we know the the optimal taxation formula under this multidimensional firm heterogeneity kind of situation, then how important it is to capture, especially the last term correlation between cost and benefit, how important it is to incorporate that into the design of the taxation. That requires us to understand to recover the cost structures of firms so that we can estimate how big the last term is and to understand how important it is to incorporate this firm heterogeneity when we design the policy. So in the welfare analysis, one of the counterfactual I do shows that just simply incorporating the last term from the estimated cost and benefits, we can increase the welfare by around 3.4%, which equals to $490 million just in the cement industry. I also show some other counterfactual in the paper, but due to time limitation, I will just focus on this one point. Just to build on the literature. So there's a extensive literature trying to understand how productivity heterogeneity creates misallocation. So, but that's part of the heterogeneity is trying to focus on the original production of firms. But if you think about emission, it's actually a byproduct of the firm's production. And then the emission intensity is basically another kind of product productivity here. So how this emission heterogeneity in emission intensity is going to create welfare implications, that's going to be the focus of this paper. And this paper is also extending another literature which is on the cost of environmental regulation. So there is the extensive literature trying to understand what is the engineering cost of the of a firm's abatement technology, and also what is the economic cost of environmental regulations. For example, if we incorporate output reduction, it's also part of the cost of environmental regulation. And here in this paper, I'm going to have incorporate like a comprehensive list of channels where firms can use to comply with regulations. And that's how I can also incorporate a comprehensive list of factors that can affect the cost of environmental regulation. So which includes here, not only the investment in greener technology, but also the reduction in output, but also the price channel here. So how they can make use of the market power to make a difference in the cost of the regulations firms face. A little bit more background about cement industry. So one of the reasons I want to study this, especially in terms of pollution here, is that still around 95% of cement plants still relied on coal. So that still generate a substantial amount of pollution here. And second, as you can see from the map, those dots are cement plants here. And you can see the cement plants are scattered across all over the nation. Part of the reason is because of this spatial competition or because of the high transportation costs. You cannot really afford to transport cement from the eastern part of China to the western part of China. This creates a bunch of local markets in the cement industry. And in each different local markets, firms may have different costs. And this creates the firm heterogeneity in cost, but also like a spatial heterogeneity in cost. Another important factor I'm going to use in the cement industry is the so-called factory gate price versus market price. So the market price here is the price consumers are paying to buy the cement at the construction site. And the factory gate price is the price the factory is charging when they are trying before they ship the product. So if you take the ratio between the factory gate price and the market price, it's sort of the measure of how much market power a firm has. So for example, if the factory is super close to the construction site, then they are able to charge a relatively higher factory gate price compared to other firms who are further away from the construction site. So I'm going to use the ratio between the factory gate price and market price as a measure for the firm level market power.
Do the consumers in the same market pay different prices, like there are sort of concrete companies that have like wholesale agreements to buy cement at lower prices?
So you're saying like even for the market price firm can have very different prices here.
I'm
I see. Yeah. Exactly. So Yes, it's possible to have different market price. It's not going to be exactly the same even in the same market, but the heterogeneity in market price is going to be much smaller than the heterogeneity of the factory gate price. So again, this can be a rough measure for the market power at the firm level. And then this is about cement production and the possible emission abatement firms can do. So in terms of production process to produce cement, it's quite standard. So you mainly have these two kind of process. One is heating, and after you heat the limestone into very like around 1200 Celsius temperature, then you grind it into to produce cement. So the production process is fairly standard, but the emission abatement technology can vary a lot across firms. That's because there are multiple channels firms can use to reduce their emission intensity. So for example, they can re-optimize the production process by switching to cleaner fuel, or just to like re-optimize, let's say, the speed at which they send the air into the kiln so that they can make the combustion more efficient. So there are different kind of steps firms can use to re-optimize their production process so that they can reduce their emission. They can also do end-of-pipe abatement so that they can reduce their emission intensity. So the reason why I'm showing this is that later on in the analysis where we estimate the production cost versus abatement cost, we can see the heterogeneity in the marginal production cost is much lower than the heterogeneity in the marginal abatement cost. So this is consistent with the background knowledge here that the production process is more standard compared to the emission abatement technology. So the data we're going to use, as you can see, when we are talking about firm level heterogeneity, we need a lot of firm level or even plant level data. We also need market level data to understand the demand and the price. So the plant level data, we have this mostly from the Chinese Environmental Statistical Database from 2011, 2018. So we have this output data includes production data inputs and then abatement investment data, and also the annual emissions. And one important data we incorporate here is basically this monthly price data from Cement Association. So remember I said, other than output and then emission intensity, price channel is also another important channel for firms to comply with the taxation policy. So that's why it's important to collect this cement price data so that we understand how they are using this price channel to comply with the tax. So we also get this firm level factory door price and the market level price for the cement product. So again, market level price is basically the price consumers are paying at the construction site. So now I'm going to show you a bunch of descriptive stats just to show how different firms are. So in terms of size, this is the production distribution of cement plants in 2018. We can see, and then the red line here is the median production, and then the gray dotted lines here are the one standard deviation production. And we can see the distribution is fairly spread, and we can see both large firms and small firms exist in the market at the same time. This can be because, so for example, for small firms, they exist because they are located in a very small market or very far away area, so they can still survive even though their size is quite small. So again, this is showing that the cement industry is quite segregated. And second is about the price and market power. Again, the market power here I'm defining as the ratio between the factory gate price and market price. So the right-hand side panel is showing you the distribution of this ratio. Again, this is trying to show you this kind of firm level market power heterogeneity here. We also see this, the red line and the gray lines are the same definition as before. We can also see that in terms of firm level market power, there also is a fair amount of heterogeneity here. Lastly, emission intensity. So over time, we do see this drop in average emission intensity. So this is showing that it's actually important to incorporate this technological change into the analysis because firms do reduce their emission intensity over time. And on the right hand side, this shows the distribution of emission intensity across firm. We also see a substantial amount of heterogeneity here. Right, so we do see this very different responses to or very different features of firms. Then how these different firms are different in their behavior in reaction to emissions taxation. This is what the reduced form is going to do. We just want to have some reduced form evidence showing that what firms are using which channels to comply with the policy. So here, Y variable are the three channels firms can use to comply with the policy. The first one is the output. They can choose to reduce their output, or they can choose to reduce their emission intensity, or they can choose to increase their price. And on the right-hand side, we have the tau as the tax rate. Again, remember in the background part, we talked about there is a time variation, spatial variation in the tax rate. This is the variation we are going to use in the analysis. And then we interact the tax rate with the group. The group is going to be like different categories of firms. So we categorize firms based on their output, ownership, and then their emission. And then we control for some other like a GDP, local GDP, and other factors that can affect the demand in the market. And lastly, this region year fixed effect is trying to control other coexisting environmental regulations at the same time. That's one challenge to study environmental issues in China because there are so many coexisting policies. Yeah.
Yeah, I have a question about your definition of market power. So you're using gate price over market price. But I mean, so the gate price could depend on firm cost. Have you considered like more of a classic measure of market power, like price over market cost?
Exactly. So that's why like this is more like a comprehensive measure of market power, or you can call it reduced form measure. So in the model, you can see the market power can come from both costs, like they are able to produce demand at lower marginal cost, or the location. So because they are closer to their consumers, they are able to charge a higher. So this is basically a measure for both of them.
Well, I think you're capturing heterogeneity in cost and market power there, not
Yeah.
just.
Exactly, yeah. Okay. Here are the results, like how different firms are reacting differently. So let me just focus on the first column and the fourth column to show the trade-off here, as we mentioned at the previous part. So in the first column, I categorize firms based on their ownership. So this is the special feature for firms in China. We have private firms. We also have state-owned enterprises. And then the way to read the magnitude here is basically those numbers are elasticity. So if we increase tax by 1%, this is saying that the private-owned firms is going to reduce their output by 0.025%. And to interpret this elasticity into the absolute level, if we look at over the study period from 2011 to 2018, overall, due to the tax rate change, the private firms reduced their output by around 10%. So these are the output choice by those private firms. What about state-owned enterprises? If you see state-owned enterprises, they actually increase their output substantially compared to the private-owned firms. And now let's look at their emission intensity choice, still for the private-owned firms and state-owned enterprises. So both of them reduce their emission intensity significantly, and this shows that emissions taxation did work. But the state-owned enterprises actually reduce their emission intensity even more. So across the table, you can see the sign is the opposite between the left-hand side table and the right-hand side table. And this shows that there's a trade-off here. So when firms are choosing reducing more output, they're reducing less on their emission intensity. So also it's true the other way around. For firms who are able to reduce their emission intensity more, they can keep their output slightly higher than compared to other firms. So this is a trade-off between the output and then how clean the technology is. Yeah.
So market power here is going to be, a part of function of demand. And we make it about the last 1,000 years, we should we be concerned about these coefficients and interacting with
I see. So you're saying market power here is more endogenous to demand? So
yeah.
exactly, yeah. So first of all, this is like the ratio. First of all, from the data, the ratio here is quite stable over time. And then I would imagine this market power here, like more like a feature than like endogenous reaction, because the market power here includes both cost, marginal cost, which I'm going to assume that does not change too much over the 8-year time period. And also this market power can also come from spatial location, which also I'm assuming, and also from the data, they don't really change that much over time period. So here I'm going to treat market power here more like a feature than endogenous reaction. Right, and then the third channel firms can use is to comply with the taxation is through the price. And not surprisingly, as we can see, both private firms and state-owned enterprises increase their price. But the state-owned enterprises are able to increase their price even more compared to private firms. This can also be suggestive evidence showing that state-owned enterprises relatively have more market power compared to private-owned firms. Yeah, so I just showed you a bunch of reduced forms showing that how different firms are having different reactions to emissions taxation. And then why this matters for the taxation design. So that's why I'm going to have this model structure here, trying to understand when this heterogeneous response matters for the design of the policy. So in the model, firms are going to be different in their both market power here, like from spatial competition and from the cost structure. And firms are going to compete in a congruent fashion. They are going to choose their output and emission intensity, and the price is going to be decided from the model. And I'm having this very standard constant price elasticity of demand. And more importantly, in the model, I'm going to have a welfare maximizing environmental regulator. And from this regulator's problem, we're going to see how this firm heterogeneity actually enters the design of the policy. So I'm going to skip the firm model part for the time consideration, but let's just focus on the regulator's problem. So here, also in a very standard way, regulators are going to care about consumer surplus, producer surplus, the tax revenue minus the environmental damage. And the difference here is that if you look at the environmental damage, the phi I here, phi I is the marginal social benefit of pollution reduction at the location. At a location, you can think about the location as a city level and the regulator as the province level. So the marginal social benefit of pollution reduction is going to be different across locations. That's a benefit differentiation also in the model. So before we talked about cost differentiation from firms, but even from the benefit side, we have the heterogeneity here. Yeah. Okay. And then in the optimal taxation formula, we can see that the tax rate is going to depend on first the average benefit of pollution reduction. And the second wedge is going to be related to market power, which is also standard in the literature. The higher the market power, you want the taxation to be relatively lower because there's already distortion in the market. And lastly, there is another term, which is a correlation between this local cost and the local benefit of firms, of pollution reduction. And that's basically how this whole firm heterogeneity enters the design of the taxation. But now the question is how important the last term is, and how much contribution it can create to the overall social welfare benefits. Then that's why we want to estimate this cost structure of firms and the abatement cost so that we can have a measure or have an estimate on the last term here. So the logic of the estimation here is that first we estimate the demand function using the supply side shifter as IV, like coal price and other factor cost here as IV. And then from the firm side, the logic is that we observed the firm's choice in terms of their output, emission intensity, and the price under different tax rate. So firms were switching between different equilibrium. And then if we assume the underlying cost function is the same across firms, we observe this realization of these different dots, and then we can at least have an estimate on the local, like a linear approximation of the cost function of them. And here is the estimated marginal cost of production versus the marginal cost of pollution abatement. On the left-hand side, this is the marginal production cost. And you can see the abatement cost has relatively higher heterogeneity compared to the marginal production cost. This is again consistent with the background where the production process is more standard, but the emission abatement technologies can vary a lot by different firms. So this is the cost side of firms. Now we'll talk about the benefit of the pollution abatement. Remember, we want to calibrate, or we want to estimate the correlation between cost and benefit so that we understand how important it is to incorporate this level of firm heterogeneity. And then I just use a very simple method to monetize this social benefit of pollution abatement. I use this Ito and Tang paper. In their estimates. They estimate that per household, the willingness to pay to reduce PM10 is $1.34. So I'm going to multiply this number by the population density in each city, and to get this social benefit of pollution abatement at city level. So after we match the city level cost of firms and city level benefits, we can calculate if we design the optimal taxation in a way that we incorporate this correlation term, how much welfare gain we have. So this is the counterfactual result. If we do incorporate the correlation between cost and benefits at the local level, we increase the overall social welfare by around 3.3%, which is equivalent to around $490 million. Yeah, so that's the only counterfactual I showed here, but I do have some others in the paper. But just in conclusion, what I show here is that firms heterogeneity here in their abatement costs can have implications for the environmental regulation. So when we design the policy, it's also important to incorporate this kind of spatial heterogeneity in both cost side and then benefit side in the design of the policy. And empirically, I document that there's the differential impacts of taxation on the cement industry in China, and recover the firm level cost of compliance that incorporates comprehensive channels through which firm can comply with the policy. Not only just the engineer estimates, but also like economic costs through output reduction or price increase. And lastly, the policy implications. So I emphasize the importance to include this heterogeneous costs and benefits into design of the policy, even though we can only have a spatially uniform taxation policy. And later on in the paper, I also try to have more counterfactual analysis, trying to say if we can recycle the tax revenues through other type of subsidies or other type of instruments, how we can further address the distortion from like market power and other factors. And of course, I'm going to improve the paper a little bit more. For example, in the model part, we have a static model, but this can be reasonable if you only study a short time period. But if we are studying a longer time period, we need to think about dynamic here. And also in terms of the capturing the marginal benefits of pollution abatement, I'm only using willingness to pay here, but there can be more comprehensive like the dispersion model to capture the marginal benefits of pollution abatement. For example, if you have a pollution abatement in this city, it can also create spillover in other cities. So this can further capture this emission leakage. And lastly, I only talked about pollution reduction here in the paper, but there's the co-benefits of pollution reduction. For example, if firms do choose to comply with the tax policies through output reduction, this will also reduce their carbon emissions here. So how we can incorporate this co-benefit or co-pollutant here into the model is going to be the next step. Yeah, thank you very much. And then please feel free to contact me if you have further questions and comments.
Thank you. Okay, so we have an hour of 15-minute talks. In the 15-minute talks, same rules as throughout the rest of the week. No questions unless the speaker specifically invites questions. They're very tight on time, so please let them proceed. Yeah, over to our first speaker. Yeah, 15 minutes.
Okay.
So thank you so much for including me in the program. My name is Gueyon Kim from UC Santa Cruz. And today I'm going to talk about trade policy uncertainty, offshoring, and the environment evidence in U.S. manufacturing establishments. This is joint work with Jerem Choi, Jae Han, and Zio Park. So one of the notable recent patterns in global environmental outcomes is the great divergence in pollution emissions between the high versus low and middle income countries. Cross-sectionally, we observe the stark differences in emissions, where emissions tend to concentrate in low and middle income countries. Over time, growth in emissions tend to be driven by these countries where China and India particularly play a significant role. Contemporaneously, there has been this remarkable growth in international trade, largely due to the entry of China into the world market. This had broadly two important effects to the developed countries. One, it meant increase in competition in the final goods market. Two, it meant easier access to imported intermediate goods and better offshoring opportunities. So the pollution haven hypothesis, or the pollution offshoring hypothesis, seems to provide a compelling explanation for the two global trends in trade and the environment. Namely, trade causes a relocation of high polluting activities from the developed to developing countries with laxer environmental regulations. Despite this plausibility in the mechanism or its importance in the policy debate, there has been thus far very limited causal evidence on this end. We're going to argue that understanding the investment nature of offshoring is necessary to really causally test for pollution haven hypothesis or the pollution offshoring hypothesis. After all, offshoring is an investment decision, which can be largely affected by institutional factors, including the trading relationship between the host and the sending country. And any possible cost advantage, such as factor price, tax, or abatement cost that the firms might enjoy through offshoring becomes ambiguous in the presence of uncertainty in trading relationships, or in other words, trade policy uncertainty. Therefore, we're going to argue that a shock, an exogenous shock that creates variation in the trade policy uncertainty, in addition to understanding the other factors that affect offshoring, is going to be necessary to really causally test for this hypothesis. So in this paper, we're going to study the long-run environmental consequences of trade liberalization in the US manufacturing sector and explore mechanisms through which firms adjust. Using arguably one of the most important change in trade policy with China, that is the granting of permanent normal trade relations in 2001 as a shock, we find significant and persistent within establishment declines in pollution emissions, where the effects seem to be more pronounced for establishments that face tough environmental regulations and therefore facing a high abatement cost, those that operate in upstream industries, and those that have within firm global sourcing networks. So all of these together collectively suggest pollution haven hypothesis as a compelling or a possible mechanism. So we're going to go ahead and directly test for it. And we actually find evidence supporting this hypothesis, where there is a significant increase in US establishments, relocation of high polluting tasks or high polluting production to China. And then we go beyond our establishment and firm level sample and ask whether these patterns are going to be preserved at the aggregate level. So we use the product level data to see whether US actually ends up importing more of the high polluting products from China. And we do find some evidence supporting that. In the interest of time, let me skip the literature review and get right into the data. So our main data relies on the Toxic Release Inventory, TRI in short. TRI is a program that was initiated in 1986 after disastrous toxic chemical leaks in Bopia, India, and West Virginia, US. So US facilities are now required to report detailed information about their production waste, as well as the measures and efforts that they take to reduce pollutants at the source. Basically go through extensive checks on the institutional changes over 20 years of time to identify a set of chemicals that are continuously covered by the program, facing constant reporting criteria during our sample period of 1997 through 2017. And then for these set of chemicals, we're going to map to a pollutant category called particulate matter 10. So we're going to be working with data that is available at the establishment, pollutant, year level. And we're going to merge this data with the National Establishment Time Series using the establishment identifiers. So our baseline sample is essentially going to be a TRI nets matched establishments and manufacturing from 1997 through 2017. We supplement our data with the Wharton Research Data Services as well as data on international trade. So I have a couple of stylized facts that I would have gone over if I had 30 minutes of time, but I'm going to skip in the interest of due to limited time here. Let's get right into the identification strategy. So the identification is going to build on the canonical work of Pearson Shaw 2016 AR paper. Just to give you a background a bit. So the United States granted permanent normal trade relations to China in 2001, which essentially meant that China gained access to low tariff rates. The NTR rates applied to WTO members with certainty. Before the policy change, the United States used to apply high tariff rates or non-NTR rates to non-market economies, including China. However, China did gain access to low tariff rates based on annual reviews and annual reviews, which also required the congressional approval of the US, which meant that the outcome of these negotiations were contingent on the political tensions between the two countries. So there was a great deal of uncertainty in the level of tariffs Chinese firms and US firms face in their trading relationships. So the policy change itself removed this uncertainty component in the tariff level. And therefore, our definition of the shock is going to be defined as this NTR gap, which is going to be the difference between the non-NTR rate and the NTR rate. So establishments that are associated with industries that are facing a high NTR gap essentially went through a shock that's greater in magnitude, meaning that they were facing greater input competition from China. But at the same time, they were having easier access to purchasing Chinese intermediate goods. Note that the variation in our shock measure is mainly driven by the rates that were set back in 1930 through the Smoot-Hawley Act, so which mitigates indigeneity concerns. Okay, so our design is going to be difference in differences, where essentially we're comparing establishments in high versus low NTR gap industries before and after the policy change. And our baseline specification is going to be, so the unit of analysis is going to be establishment year. We are regressing log of emissions from establishment P in industry I and in year T on our shock measure of NTR gap, interacted with a post dummy, which is set equal to 1 on 4 years on and after 2001. We're including a host of controls on industry-specific time invariant, as well as time varying characteristics, which also includes changes in the trade policy from China and their import tariffs or production subsidies. We are including establishment fixed effects, and more importantly, county by year fixed effects to control for unobserved local labor market supply or demand shocks. But more importantly, changes in the region-specific regulatory standards that the establishment are facing, namely due to the Clean Air Act of 1990. So our estimate of beta 1 is going to be of coefficient of interest, which is capturing the within establishment effect of the policy change in terms of its emissions over time. And our identifying assumption is going to be that establishments or industries do not show differential trends in emissions based on the NTR gap at the pre-shock period. So let me now go over the results. As you can see here in the table, across all different specifications, we see that the policy change, or the PNTR, actually caused a within establishment decrease in pollution emissions. To give you a sense of the magnitude, using our coefficient estimate in column 4, comparing establishments that belong to the 90th to 10th percentile in terms of the NTR gap, the high exposed establishments are essentially reducing emissions by 0.34 log points more, which corresponds to about 17,000 pounds additional reductions. We Now we're going to augment our baseline specification to a dynamic setting. And plotting the year-specific estimates, we can see that the impact is persistent and increasingly negative. And also, we don't see any evidence of pre-existing trends. Now we conduct a host of exercises to ensure the robustness of our estimates, which I won't go into detail today. So instead, let me say that the within establishment adjustment that we're seeing in emissions is primarily driven by a decline in pollution emission intensities. One might wonder that the competitive pressure from China might mechanically driving this result through causing establishments to exit or reduce their production scale. It does not turn out to be this case. Our results are mainly through a decline in pollution emission intensity, which we define as the emission amount over the production scale, Okay. So finally, we ask whether there are any differential responses by establishment type. And here we're going to implement a triple difference in differences. And as you can see here, PNTR is causing a within establishment decrease in pollution emissions, which tend to be stronger for those who are those with global sourcing networks, those who are facing tougher environmental regulations, and those that operate in upstream industries. So these evidence collectively suggest again that it might be that firms are adjusting by relocating the high polluting production to China. So we're going to go ahead and directly test for this hypothesis. So let me note that it's incredibly challenging to construct a comprehensive measure of offshoring, let alone come up with a measure of offshoring dirty production. Given the data that we have, we're going to take two approaches. So to measure relocation of tasks, we're going to take two approaches. One is to make use of the establishment level import data to capture firms sourcing task outputs from China, and then to use the firm level subsidiary information to capture firms performing tasks through subsidiaries in China. And we're going to infer dirtiness of a task from the pre-shock pollution intensities of establishment or industries. So here are the results. Starting from the sourcing measurement, we see that PNTR essentially caused a within establishment increase in import activities, which is not surprising given the vast literature on the China shock. However, these effects are essentially larger for those establishments that were initially engaged in dirty production. We find a qualitatively similar results looking into the subsidiaries. The number of subsidiaries operating in China essentially increased as a response to this policy change. And the effects are stronger for those who were engaged in dirty production earlier. Now, as a final exercise, I'm going to ask, okay, going beyond our sample of establishments or firms, let's take a look at whether we see consistent patterns at the aggregate level. So we got to go ahead and use the product level data and ask whether PNTR is causing an increase in imports of high polluting production from China. And here we're going to be using triple difference in differences again, but the unit of analysis here is going to be product year. So again, PNTR is causing an increase in the share of imports from China, and the impact is actually larger for those who in products that are associated with high pollution intensities. So let me now conclude. Our project is studying the long-run environmental consequences of trade shocks in U.S. manufacturing, and we're exploring mechanisms through which firms adjust. We essentially find this significant and persistent decrease in pollution emissions within establishments, and we find evidence supporting the pollution hypothesis. As we conclude, let me briefly talk about the implications of our work. So as many of you know, there's active ongoing discussions on how to coordinate and devise trade and environmental policies across borders, such as CBAM, particularly to prevent carbon leakage. And in a more decentralized manner, we're finding more and more evidence on multinational firms implementing ESG policies to their own firm subsidiaries and going beyond their sourcing partners. So we can see that this can be many, good efforts in which we can actually gap pollution emissions between the developing and developing countries. which would be nice. It would be a nice collective goal to reach as a global economy, as a global community. However, at the same time, this could also discourage offshoring activity altogether and impede some important positive spillovers that the multinationals or offshoring activities could have through the integration of global production networks. So thank you so much for listening, and I look forward to your thoughts, comments, and feedback. Thank you.
Okay, good morning. Thanks for giving me a slot. This is about knowledge spillovers. Once more, many of you have seen this perhaps already, but we have a slightly different twist, I think, as of late. And since I have only 15 minutes, I was thinking of summarizing everything in 2 slides. So this doesn't work very well for starters. It's worked with Dennis, who many of you know, I think. There you go. So we have a bunch of questions that we're trying to answer here. First of all, can targeted industrial policy lead to both more growth and cleaner growth? Or in other words, can we somehow trick Tinbergen here? Do we have a chance? If that's the case, do countries have sufficient incentives to do this kind of stuff? And more specifically, you know, clean technologies, as we already seen in this conference, can be many different things. Which technologies in particular might be suitable for that? And that's basically also the genesis of this paper that we were asked by the UK government. Okay, we kind of want to support this. There was something a couple of years ago which was called the Clean Innovation Fund, where they really said, okay, we want to give a couple of billions to companies for R&D on clean technologies. But now we have somebody, you know, doing wind turbines, we have somebody doing solar panels. Who should we give the million? That was kind of the exercise question. So that's how this came about. And more lately, I mean, of course, the big new kid on the block is the IRA, not the one in Ireland, the one in the US. And there's a lot of concern that this is bad for Europe or the UK. We have to somehow react in some kind of way. But we're showing there that the concerns about business stealing effects, which these mainly are, have to be balanced potentially with spillover flows. So we show, when I show you later, that there are a lot of spillover flows coming over from the US, and actually in clean technologies more so than in other technologies. So I guess we should be not so worried is the answer. And then we have a little bit of a section where we also look into another concern that people have, you know, these days, a lot of inequality. Will this sort of reinforce existing inequalities? And we show that actually there could be a potential here to, you know, what is for the UK audience called leveling up, to help more disadvantaged regions. Actually, I already previewed some of my answers. So the answer is yes, there is potentially an avenue, a strategy for this sort of tricking Tinbergen thing. And it's coming from knowledge spillovers, where knowledge spillovers from a lot of clean technologies are actually above average relative to other things, at least the way we measure it. But we also find that countries, not all countries, have necessarily incentives to implement this on their own, because spillovers spill over, right? And there's spillover not only of individual firms, but also out of countries. Most spillovers go abroad. So if you are a national government, maybe you not always have the right incentives to do the right thing. And then, you know, in terms of the clean areas which you should support, well, what we show, it varies a lot from country to country. So it's very specific. In the UK, we consistently seem to be finding that tidal and offshore stuff ranks very high, but this could be very different in other countries. And I already told you about the IRA. We find a lot of spillovers, especially from the US into Europe, and they are stronger, especially for clean technologies. And yeah, we see this, you know, sometimes I call it clean spillovers, or clean technologies are progressive. There is a, you know, a lot of the activity happens away from the usual suspects. I mean, we talk in the UK often about the golden triangle. You know, basically there's London, Oxford, and Cambridge, and everything else is basically looks quite poorly sometimes. But we find that proportionally, so in comparative terms, there are a lot of innovating people in clean that are away from these areas. And so that means if you support clean, that also automatically disproportionately benefits those lagging areas. So these are the answers, and well, let me see how far I get, and if you must, you can interrupt me maybe. But the methods, we basically standing on the shoulders of hidden giants, which is this other paper we recently wrote, and what we sort of introduced there is a sort of a newish approach to measure innovation spillovers from patent data. And the key difference relative to what maybe other people have been doing there is that we allow for both direct and indirect spillovers. We're tracing the whole network of spillovers via citations, and we make our best effort to allow for value differences between different technologies. And also we have a new method of figuring out the inventor response to subsidies, which, you know, quite plausibly might vary a lot from, you know, solar panels to wind turbines or space technologies. So how do we do that? Well, the basic, it starts with, you know, maybe a not very controversial formula that the social value of an innovation must be somehow the private value plus some kind of fraction of the social value of all the people that somehow, you know, benefit from you or cite you, right? So that's what this formula says. And the whole thing is kind of inspired by how Google ranked web pages once upon a time. I don't know how much they're still doing that this way, but so it's called patent rank or prank because we are inspired by Google's page rank. So while, you know, in principle that formula might not be all too controversial, the key is, of course, how we, you know, implement this and how we do things. For instance, how we figure out what the private value exactly is of a particular innovation, and how we sort of work out the fraction of, you know, what is my contribution, you know, or if I cite John, what is his contribution in my paper from this citation that I do of his paper. What we're doing at the moment is admittedly, you know, it's a strong assumption, but I you know, I argue in a second that it's at least a big improvement, and this is very much inspired by how Google does it. We take 1 over the backward citations. We have a little bit of a scale factor there, which controls how much of what you do is down to yourself and your efforts, and down to spillover flows. And you know, what does this imply? Well, it basically implies that if I cite 10 people, the value I assign to all of these 10 papers that I'm citing, or these 10 patents, if it's a patent, I assign the same value to all of them, which is a bit strong, but at least we are assigning something. And the private values, where do we get the private values from? Well, you know, we're basing it on extrapolating, and I don't have the time to tell you everything about it, but we're extrapolating from using this recent approach by Kogan and co-authors who infer value of innovation from stock market reactions of patenting firms. And we use this to infer, you know, the rough value of a technology area, where it's very clear that if an innovative step in pharmaceuticals is very different from an innovative step in computer science. And to get these sort of rough differences right, that's what we use it for. Now, I totally accept that we're making very strong assumptions here, but basically my basic message is, okay, I think it's a lot better than what is sort of the most common approach in this sort of area, where people often just say, okay, we accept one innovation is very different, the economic value of one innovation is very different from another. And so to address this, well, let's count citations. Yeah. And I think this is a bit schizophrenic, because in a way you say on the left-hand side, yes, or, you know, innovations have a different value. Then on the right-hand side, every citation you get, you count with exactly the same value, just count one. Yeah. So if you have already decided there is differential value, you should at least account for it on both on the left-hand side. So my basic message is this is some kind of approach that makes at least what you're doing coherent. Yeah. And I mean, I think a lot of that we can change. And if you think that assigning the same value to all is a bad idea, and you have a good strategy of how we can weaken that, nothing in what we're doing really depends crucially on that. So that is the message. And then the next step, let me check the time. The next step is that we fit a little model here of the innovation process. where we're saying, well, innovation, it's you get ideas, and then some of these ideas you implement. And there's a certain threshold. Only the better ideas, we have an expectation that it's probably something more valuable, that you will sort of put some research in. And again, this is an uncertain process, but at least that's what inventors roughly are doing. And if this is the case, we sort of claim that we can use the distribution of private values that we observe from, for instance, the work of Kogan. We can use this to basically calibrate a little model that gives us very specific parameters of cost and also of probability mass, because it's just below the cost threshold in different innovative fields. Yeah? So these are the two things we allow to vary. 5 minutes, fantastic. And then a final thing, which is relatively important, is that we want to look at these sort of flows, sometimes between or within countries. So this is a rough sort of visual representation of what we're doing, that we look at an innovation A, and we look at this whole direct and indirect network, and we take account of the values. Now, if we are interested only in Belgium, if you're the Belgian government, for instance, then we might not want to take into account the values that have nothing to do with Belgium. So in that sense, we can look what is sort of internalized within Belgium. And we can use the same approach to look, for instance, okay, how much is the UK helping Belgium? By simply looking at UK innovations and running this sort of program, this I just described, using only the Belgian values. Okay, so some of our results. First result is we find in almost all countries that clean innovations generate. So what we can do with this, I haven't stressed this enough, we can calculate returns to innovation subsidies in different areas. That's what we get out of there. And then we look in various countries, okay, where is the return to what you call clean, but for instance, we can use various measures of what is clean, but we use the OECD measure in this case, who some of you might know have done a lot of work in classifying innovations as clean, and we show there that clean innovations tend to create above average returns. If we compare it to all innovations that happen in a particular country, we get in almost all countries, and sometimes quite substantial above average returns from $1 of R&D subsidy money invested by the government. And however, this is on the left-hand side, we see the global figures for spillovers that arise to subsequently any inventor globally. Whereas on the right-hand side, you see, you see the bars are the national figures, the stuff that the value that is sort of internalized within a country, and the dotted, you see the global from the left-hand side. And you see in all the countries below the line, which is just about half of the countries, we see that the global clean gap is higher than the national clean gap, which would sort of suggest that if governments are actually doing this and pursuing this in a sort of national optimal way, then they would sort of underinvest in clean on their own account. And in the paper, we do a lot of work in sort of working out what is sort of the advantage of various regional groupings, such as, say, the EU or the G7 or the OECD, by sort of coordinating the stuff a little bit. Where you say, okay, we invest in this and you invest in this, or we sort of, no, I mean, that's what's happening at the EU level, for instance, that the EU just decides where does the money go, right? And the governments just pay the money in. So benefits of coordination, and the reason for that you see briefly here, that we just look at what share of spillovers are retained, and in literally all countries it's less than 50%, and in some countries substantially less than 50%. Of course, a bit of a function of the size of the country. If you're a bigger country, you're likely to internalize more, but not only. As you can see, Korea is very much on the top in terms of they somehow manage to internalize more, and it could be a sign of very deliberate, very good maybe, or national industrial policy. Okay, finally, what exactly should you support? Well, it varies a lot, but as I promised you, in the UK, you always find a tidal stream. I can talk to you exactly what tidal stream is. So tidal energy and offshore wind, these are the technologies which generate the highest return nationally, and even higher than things like artificial intelligence. Of course, if you look globally, this is very different, because a lot of the artificial intelligence stuff, if you do it in the UK, it benefits inventors that might be in Silicon Valley and not in Sheffield or Newcastle. This is here about the IRA. So it's not my best slide, but what we try to calculate there, if the US spends $1 of R&D money, how do we value the spillover flow that comes out of this? First of all, for the US, so it's $1.47, so more than doubling, you know. In Europe, it's $1.26 for clean, I should say, and relative to all, it's $1.18. So basically, if the US goes from subsidizing anything, what they typically subsidize, to subsidizing more clean innovation, we're bound to have an increase in the spillover flows we get from the US in Europe. And also generally, I mean, you know, most of the value, the net value of what Europe gets out of the US is actually higher than the net value in the US, because the US, of course, also has to pay for it, whereas in Europe, we don't have to pay for it. I'm out of time. Fantastic. Okay, this is just, I don't have time to explain all of this, but let me show you this. This is on the right-hand side, you see, on the left, you see, you know, where you have economic value or innovation in the UK. And you see London, Oxford, and Cambridge, basically. On the right-hand side, you see that the relative share. So in those regions, there's not much innovation, but if there's innovation, you know, it tends to be more in clean. That's what the right sort of map shows you. And actually, what I'm finding is that it's also, you know, true of not all, but of many developing countries. So I think there could be an interesting story here of how clean technologies are a chance, not only to relocate, to level up the UK, but maybe also the world. Okay, let me conclude. I think targeted support for specific technologies can lead to, you know, more clean innovation, but also more growth potentially. There is, you know, a lot of scope to do have coordination, and you know, maybe we shouldn't be so concerned about the IRA. At least, you know, we should balance any concerns about business dealing by these sort of spillover flows, and there's maybe potential for the clean position to help with leveling up. And potentially we have a win-win-win-win situation here. But it's, of course, not automatic. So clean, inequality reducing, energy security increasing, and more economic growth. Thanks.
I got rid of it. Yeah.
Great, thanks everyone for being here. So I'll be presenting my paper on how human capital helps facilitate adaptation to climate change. And in that sense, it's quite complementary to Trin's presentation earlier in this week as well. So the big picture question I'm looking at asking is, can the world's poor adapt to climate change in time? We know that climate change disproportionately impacts those in agriculture, which is the occupation of the majority of the world's poor. One way for the poor to reduce these impacts might be by changing occupations, leaving agriculture, going to manufacturing, or by changing locations, moving away from an exposed place to a slightly less exposed location. However, in the development literature, we know very well that the poor face many barriers to this type of mobility. And what I'll be arguing in this paper is that I see human capital as an asset, something you can take with you, which enhances your mobility to engage in occupational change or enhances your ability to migrate. And in that sense, human capital can be seen as an investment into your own resilience, and in some ways is something which the weather can never erode from you. If you take this argument to heart, you could say that now there's this bit of this race between accumulating human capital, getting these skills that allow you to be mobile, and the onset of climate change. And that's really the kind of race that I'm thinking about in my story. So the policy takeaway from all this might be that policies which help enhance human capital accumulation might actually lessen the impact of the climate crisis over time. What I'll be presenting today is really just the reduced form part of a wider structural paper, but I'll be exploiting a discontinuity in the district eligibility for a large-scale schooling expansion program in India to examine how the districts that received more human capital were able to respond more to climate change. And so I'll be creating measures of climate change using growing and killing degree dates, which I'll show you how I calculate. And then my outcome data will be quite granular, looking at occupations, the like at the granular postal code or village level. And I have identification only at the district level that assigns whether you get this program or not. But to try to go down deeper, I adjust for treatment intensity using the observed school construction data that I have. And just to preview the results, I find that in response to climate change, to really think about this interaction of getting these schools and observing climate change, I find three main things. I find that the areas that had these schools or this injection of human capital saw greater declines of labor and agriculture in response to climate change. This labor leaves agriculture and goes more into manufacturing and services. And there's also a sense that there's a reduction in population. Population is the key word. I don't have migration yet, but I'll talk about that momentarily. And overall, I don't have precision on this estimate, but it seems like this is not negatively impacting consumption. So they are adapting in some sense. They're not worse off by making these changes. I'll start just briefly by a few motivational facts, and I'll go into the reduced form. And Paul, be ruthless on time. I would love to have a slide on just the structural part of my paper, but we'll see if we get there. So the first fact is that India is already experiencing climate change. So on the y-axis, this is killing degree days. I'll define that momentarily. As you might expect, killing degree days are bad. The more there are, the worse your agricultural production is. You have wheat on the left, rice on the right. This is a time series starting from before 1960 up until the present day. So we see about a 10% increase already in the number of these killing degree days in two of the major crops in India. At the same time, that's a second descriptive fact for India between this period of say 1990 and 2010, we see widespread structural transformation. Everywhere except those in the deepest red have seen a decline in the share of labor in agriculture. And some of these areas have seen quite substantial movements out of agriculture. So the blue areas have seen about a 20% percentage point reduction in the share of labor in agriculture, for instance. And the third fact to kind of close my story of what's happening in India at this time is that there's an enormous expansion in access to schooling and human capital. So these deepest green areas have seen about a 30% increase in the number of schools per 1,000 children between 1990 and 2010. And it's these areas, and I don't know if you can see it well, but the pink areas will be my treatment areas, but it's these areas where you're seeing a lot of human capital, which is probably helping structural transformation. And what I want to answer is how is that helping those areas also adapt to these changes in climate that we've discussed. So to summarize what I'm doing, the mechanism is really, does human capital help mobility across sectors and locations? And if you're happy to define that mobility as adaptation, we're going to look at how human capital helps adaptation to climate change. And that gives you this empirical test. Are these areas that have more human capital, more mobile in response to climate change, yes or no? And a motivating regression specification might be like this, where you have an outcome like share of labor in agriculture. I'm very interested in that beta coefficient, that interactive term between human capital, H, and our measure of climate change, omega. Now, depending on our outcome, the literature has often looked at the effect of climate change directly on the share of labor in agriculture. Depending on whether income or substitution effects dominate, we might see that there's a positive increase. So labor is pushed back into agriculture following a negative shock. What I'm interested here is in the areas that had these schools, is there a negative coefficient? So do they actually, instead of being pushed into agriculture, are they able to leave? And that's not something that areas without human capital might be able to do. So I'll define that more in the next few minutes. So the data, just briefly, that I'll be using is quite widespread. On the climate side, I'll be using the global meteorological forcing data set. Economic outcomes for this presentation will just be based on the population economic census data between 1991 and 2013 for India. And I supplement this with the recent shrug data to help harmonize the boundaries. Then I also have very detailed data on all schools, primary schools that were constructed in this period in India. And that helps me, again, identify which areas might have received a bit more of an intense treatment, if you will, than others. And then, of course, I have quite detailed data on kind of the crop cultivation and production as well. I won't be able to go into much detail, but for those that aren't familiar about how I'm constructing these climate change variables, I'll go into a brief breakdown here. So these killing and growing degree days really just measure the accumulation of heat in a crop over the growing season. So heat is energy, which is good up to a point, at which point it starts damaging the crop's potential. And I'd look at this for each of the 5 major crops in India. And what I do is I use the kind of cultivation shares, which I hold fixed at the start of the time period, for each of these major crops, and then calculate these growing or killing degree days for all those crops, and then do a weighted average to get a grid cell level of basically how productive or destructive climate change was for agriculture in that point in time. And so I'll be fitting these sine waves over the observed temperatures in that day. And I'll be using the crop-specific kind of upper and lower bounds from the Climate Impact Lab. What you find here on the left is the growing degree days. So just to try to help interpret the magnitudes, you have a mean of about 1,100. The red areas in the south of India see a reduction of just about 10% or so. So these are quintiles, but the bottom quintile will see about a reduction of 10% in these growing degree days. Not quite the analog, but if you look at the killing degree days, so these really highest temperatures, kind of above 30 degrees for rice, you see that equally there's about an increase of about 10% or just under for these most damaging days. And so that's really what's going to be affecting agricultural incomes in my story. So I'm really on time. Far better than I've ever done. Anyway, so the district primary education programs I'll be using as my primary instrument for getting variation in human capital at the local level. Briefly, this was rolled out in the mid-1990s. It was a quite holistic, wide-ranging program. It involved school construction, training teachers, local funding for schools as well. But really, it represented one of India's first kind of wide-scale efforts to improve access to education in the country. Notably, there's an eligibility threshold for a district to participate in this program, and that is based on its historical 1991 female literacy rate. And I'll show some graphs on that in a moment. But you can see here the treated, so the pink areas are districts which benefited from this program. The teal areas are the other districts. So I should say in the end, it covered around just under half of the districts in India. But we see here as this period, when it began in the mid-1990s, you see a large increase in the number of schools. And that's the variation that I'll be using to generate for my results. So the first stage, so this will be on the y-axis, the probability that you received or were part of this program. On the x-axis is the demeaned female literacy rate. So it's a fuzzy regression discontinuity in the sense that not everybody who is eligible received the program. And unfortunately, there are defiers as well, where you have quite a few just to the right of the threshold that did also get the program. But what we do take away from this is that there's a quite sharp drop to the right of the threshold in the probability that a district in India is eligible for this program and receives this funding for the schools. So I'll be using that to generate the first stage variation on human capital in my model. 5 minutes, thank you. The second stage will be the following specification. So I'm running this at the postal code level in India. So my outcome, for instance, might be the share of labor in agriculture. I'll be doing long differences. So I'll be comparing the share of labor in agriculture in 2011 compared to that in 1991. The instrument for human capital, I'll be using the discontinuity based on the female literacy rate, as well as the observed number of schools constructed in that postal code. As I've mentioned, I'm using growing degree days and killing degree days as my climate variables. I'm really looking at long-term differences here. I'm not looking at short-term weather variation. And then I do control for a host of other controls. Very explicit comments on identification here. So to identify climate change, I basically have to rely on this long differences approach, which means that conditional on state fixed effects on my controls effectively is parallel trends. That is not a soft assumption. I think that's the trade-off you need to make if you want to try to think about long-term impacts like climate change instead of just short-term responses to weather variation. But of course, I also do look at the more conventional panel regression style, which looks at short-term variations in weather for identification. And then to identify the coefficients on human capital, you need the standard discontinuity assumptions on continuity and outcomes and no pre-treatment manipulation. So to get to the results in the last 2-3 minutes, first, I find that human capital does help you leave agriculture in response to climate change. So the outcome variable here, again, you have to think about changes in shares and percentages. This is the change in the share of labor in agriculture. And this is the climate change variable KDD is in log terms, so you can interpret this as percentages. So what this is saying is that for a postal code with an average amount of these killing degree days, they had about a 13% higher share in agriculture compared to an area that did not. So again, this is a 13% higher change in the share of agriculture. So most areas are declining. These areas that experience more climate change are declining less quickly. However, that is offset by this interaction term. So the areas that receive this program see a much greater outflow of labor from agriculture. So this is saying that these areas with human capital are responding and are leaving agriculture, as we might expect from the substitution effect. They're only able to do so if you have this human capital. Where does that labor go? It goes into non-agriculture. These don't add up to one because this does not include things like unemployment or the extensive margin changes. But we see that just like there's a negative coefficient on climate change on the share of labor in agriculture, non-agriculture, we see that for those that have this human capital, they're able to move more into these sectors that we might argue are less exposed to climate change. To bring in the other dimension of mobility, I'm only looking here at net population changes. Anyone knows how to shake down the World Bank or the Census Commission of India to get migration data, please let me know. But what I'm looking at here, and there's less precision, probably because it's just population, is that the program itself actually keeps people there, which is intuitive. Schools might create a sense of agglomeration in a small way. But if we look at the interaction term again at the bottom, when there's climate change, the areas that have more human capital seem to be losing more population, which might suggest that the areas that had greater human capital allows those individuals, when they enter the labor market in the future, to migrate. And the last point I'll make on the outcome side is, it seems like, or at least there's not evidence that there's any strong negative effect on consumption. So the concern might be, I'm leaving labor, I'm leaving agriculture, but I might be doing a second best job. I might be out of agriculture, but I'm actually worse off overall. And this is just cross-sectional. So I have, this is kind of comparing one static point in time. I don't have evidence to suggest that this adaptive response is making you worse off in terms of your consumption. This is per household. So in the last minute, so this to summarize these results, it's I think quite intuitive that human capital is helping you adapt, whether that's through changing occupations or being mobile. The last thing I want to say, which is kind of previewing the structural part of my work, is that I really want to unpack, who is able to adapt and how is your opportunity to adapt dependent on where you are. So ultimately, labor will compete in markets for human capital. These markets for human capital might be close by, or they might be far away, or you might not be able to access them. So I might have human capital, but if the occupations that need my human capital are not near me, that does not help me adapt. Furthermore, what matters is relative human capital. I might be getting a few more years of education, but if someone else is getting even a few more above me, they might outcompete me. And so that is important to think about, who and where are you able to adapt to climate change. And I'll just end by saying I develop a rich spatial structural model that incorporates this climate change, incorporates an initial human capital accumulation stage, and just looks at how in these models, human capital helps some areas that have greater market access adapt more quickly to climate change in areas that have a bit less. So, thanks very much.
Thank you. Hi, everyone. I'm the second author here. I'm the last person standing between you and lunch, so I'll try to be quick, but don't forget to reward me in ample feedback at the break, please. So this is a very preliminary work. So I'm very, very glad we, the organizers included our work in the program. This is about deforestation and structural transformation in Sub-Saharan Africa. Joint work with Kenneth Undeji, Sam Marshall, Gina Wolfsberger, and Guillaume Lewis. So I don't think with this audience, I need to motivate why deforestation is important. I even learned yesterday that having more trees change the climate. So here we go. So obviously, there's been a lot of work being done on Brazil and Indonesia. They've been doing the headlines, but Sub-Saharan Africa is actually the region that is experiencing currently the fastest increase in deforestation over the last 20 years. And we were interested in that context because subsistence farming is likely to play an important role in deforestation in Sub-Saharan Africa, maybe unlike Brazil and Indonesia, where export-driven agriculture is a major culprit. So I guess we were interested in seeing whether, it might, in this context, might be good news that if you have structural transformation, then subsistence farming is probably going to be on the decline. And we've seen this in the last 20 years in many countries across the continent. So our main question is, how does structural transformation impact deforestation in Sub-Saharan Africa? So as we sat down to think about this, we realized that this was obviously a very complicated problem. I had a very simple idea in mind when we started, which is migration. Just like, people go to the city, they leave the forest alone, and yeah, all is well. Obviously, those people who leave to the city, they actually also need to eat. Structural transformation also increases income, so they might, consume more of the agricultural goods. So you probably want to take seriously both migration and trade, and so we developed a model to explore those effects. Then we wanted to provide direct evidence of these channels. And so we use data, we use the outcomes, basically, data countries where we could have 2 censuses. So that's 70, it's growing maybe to 21 Sub-Saharan African countries. And we'll be looking at administrative units. And what we'll be thinking of initially is to have on the left-hand side deforestation and changes in agricultural land at origin, and regress this on 2 shift chair instruments. So you would usually have migration papers that have, the shift is change in non-agricultural employment in a given destination, okay? We'll be taking it as exogenous and then instrumenting it. So that's the shift. If something is happening somewhere, the structural change happening somewhere else in the country. Then the question is, how does that affect migration, deforestation locally? We're thinking about it going through migration. So we have a migration matrix, but we're also thinking about trade. So we don't have trade flow. So we'll be thinking about a matrix of just inverse distance between the two. And I don't know of any, there's not a lot of papers that do this, basically. I think maybe the Bustos et al. Paper, just considering, the transmission of a shock via different networks at the same time. It's quite unusual. So we're thinking of it as also potentially a contribution. And then we quantify the spatial equilibrium model, and that allows us to account for indirect effects. So the sort of reduced form, or the simple empirical strategy we have, connects one origin to one destination. But obviously, that structural change in one destination will affect migration from many other origins and trade between one given origin and other. So, right. So that's the how much time do I have? 10 minutes? Okay. So so I'll skip the literature that's been reviewed recently by Balboniet. So we're thinking that this direct sort of link between structural transformation and deforestation, especially in the context of Sub-Saharan Africa, with this quantitative approach is a contribution to the current literature. So I'll describe very quickly the model. So currently, we don't have international trade, so we'll do it soon. But anyway, you can think later how it changes our result. But basically, with a simple closed economy, with many locations, And then in every plot can be used for agriculture or left in the forest. And then the agricultural sector is going to be using land and labor to produce agricultural goods with as per costs. And then there's this decision of whether to clear the land or not, depending on the profitability of agricultural goods, which depends on both prices and wages. And then there's a non-agricultural sector which only uses labor to produce goods that are freely traded. And so workers, they decide their location based on wages and migration costs. So with this simple setup, we can think about what's happening when you have an increase in non-agricultural productivity or non-agricultural labor share in a given destination. This will increase, obviously, employment and local wages. This will attract migrants from a given origin O, and that should reduce deforestation in that origin, just because less people are consuming and wages are going up, so it's less profitable. It's agricultural, it's less profitable. So that's what we call the migration channel, or the direct migration channel. As more people are in D, they're richer, they'll be demanding more agricultural goods from O potentially, and so that's more deforestation. So we call that the trade channel. Obviously, as I just mentioned, lots of other things are going on. People from other origins are going to D. So that will reduce agricultural imports from O and might reduce deforestation in O, and we call that the indirect channel. So the net effect is ambiguous. It depends on, of course, trade and migration costs, but much more importantly, it depends on the distribution of agricultural productivity and forest cover across space, and where non-agricultural employment is increasing, where structural transformation is taking. So I'll go quickly through the empirical strategy, or especially through the data part. So it's a lot of satellite data. We're trying to use a couple because it's measurement is an issue. We're using censuses from IPMS. And so estimating equation is going to be on the left-hand side, either deforestation or land use. On the right-hand side, two Bartik shocks, or in one we'll call the trade shift shares, which is a weighted sum of non-agricultural employment change in all those different destinations, divided just by total active population across the country, weighted by an inverse distance. So that's we call that we think might capture the effect of trade, when we put it together with a migration shift share, which is the same, but the weights of the migration shares between every origin and destination. We are controlling for the local shifts because we're that, things might be correlated over space. And then, we're controlling for things that we should be controlling given the recent development in shift share literature. I think one thing I wanted to mention briefly is that there's been this recent paper by Boris et al. That suggests you can reverse everything. You can just think about what the effect of non-agricultural employment growth in one destination, what's the effect on deforestation across the country via those two shares. So I don't think it's been done before. So we were struggling a bit with this, but turns out we can do it even if we have two different matrices. We can do this. We just have to have separate equations, which is what I'm showing here. But importantly, this makes it clear that then, non-agricultural employment from the point of view of the destination might be endogenous. So we can then use different instruments. We're working on including mining, which might be more obviously maybe that all of those, but that's currently we're using broadband and other things. So phone and electricity. So the empirical results are that we find some evidence that the migration Bartik is indeed reducing the share of area being deforested, or in another data set, increasing the share of area being forested and decreasing the share of area being built. So that's sort of what we're hoping for. And then there's, I won't have time to go into the details, but there's evidence of an increase in the share of cropland and a decrease in the share forested from the trade Bartik, but it's not that the results aren't lining up perfectly, as you see. So we inverse at the level of destination, then we instrument, and we find that most of the results hold. So this is work in progress. I wanted to, do I have 5? Oh, okay. Okay, good. Well, no, I promised that I would finish early. So I'll just say we're working on this. We find some evidence of those two opposite effects of a change in non-agricultural employment in a place on deforestation and agriculture in other places via those two migration and trade channel, which we proxy by interstice, by proxy, geographical proximity. If you then we quantify the model. That part is also work in progress. So we fit in land use allocation at baseline. We take key parameters from the literature. Our counterfactual exercise is going to be very simple. It's just introducing structural change, introducing this change in non-agricultural labor as we see it in the data, and to block alternatively movements either of workers or agricultural goods. So either shutting down trade or migration. So the current results are these ones. They're like 1 week old. So you see that there's large negative effects of structural change on deforestation. This is one way to interpret it is a 1% reduction in total land that's being cleared. It's hard to get. There's going to be 1% of total land that has more forests because of structural change. So that seems too large. So we're working on this. What we thought was interesting is that if you do no trade adjustments, let me start with the migration. Migration one is quite easy. You've got nobody moves. You've got non-agricultural employment growth in one place. You get deforestation. So that has to be. Then the other part is you do no agricultural trade adjustment. So the trade flows as they were at baseline, but people are still moving around. Okay. And because of that, we do see a decrease in deforestation. However, the massive effect that we document here is driven by all the other things. That is, you can think about it as the interaction of migration and trade. Just the fact that there's other nearby places that are usually traded with me that are now, the people are migrating to the city, and that also reduces deforestation for me. So those multiplier effects that are only captured by the model, we think might be important. Maybe in 1 minute. Okay. Okay. Well. So maybe in 1 minute, what we think is really interesting, of course, we have to delve more into this, is the heterogeneity across countries that we document. Maybe the one simple example, think of Tanzania, okay? Think about coastal cities or clusters of non-agricultural employment. Those are the ones that are growing with structural transformation. Where are the forests? They're quite far away. Okay, so as people move out of those places that have forests and agriculture and join those non-agricultural centers, you have a decrease in deforestation. So these relatively large countries that have concentrated urban locations around the coast and the forests more remote, they would have those strong effects, negative effects on deforestation. By contrast, you have smaller or no effects in countries that are either small or landlocked, in a way that means that the cities are basically in the middle. Okay, so they would, anyway, so basically, as people move to the cities and they demand more agricultural goods, the demand for these agricultural goods is going to include clearing land in those places around. Okay, if that makes sense. At least that makes sense to us. So that's my conclusion. So starting to think about structural transformation and deforestation via those two channels of migration and trade. With a net effect and total effect captured by the quantitative spatial model that we think is providing evidence that structural transformation is on net reducing deforestation in this context. I'll stop here.
Okay, so I think we'll get the afternoon masterclass started. So I'm delighted. My name is John Van der Renen. I'm the director of Boyd and a professor here at LSE, and I'm delighted to have the session on green industrial policy, green in square brackets, according to Dave's first slide. So the way we're going to run the session is that we have a 2-hour slot overall. For the first hour, it's going to be 3 academics presenting the overview of the area of green industrial policy. We have, I hope I get the order right here. We have Dave Donaldson from MIT, using LSE this year. Isabela Manelici, who's one of our star assistant professors, who's here, and Dave Atkin, who's from MIT as well. So they're going to have 20 minutes each to present an overview of the academic work. Then everybody's going to come forward, and we have 2 policymakers that I'm very pleased to be able to join here. Dr. Arkebe Oqubay, I hope, is that your how to pronounce it? Thank you, who's advisor to the Ethiopian Prime Minister. And Dr. Enilde Sarmento, who's National Director of Economic Policy and Development in the Ministry of Economy and Finance in Mozambique. So they will both have up to 15 minutes to make their remarks, reactions to the academics. Then we'll have an open discussion for the rest of the session. So hold your questions until then. And without further ado, I think we'll get started. So over to you, Dave.
Great. Can you hear me if I stand here? Yeah, okay. Yeah, so obviously, thank you so much for the chance to talk here. This is not an area of expertise. I feel silly this being titled something to do with master, but I'm going to start by talking about something that I've enjoyed thinking about a little bit, which is the theory side of industrial policy. Think about that as kind of, in theory, when is industrial policy justified? And if so, like, what should it look like? How would we know that it's being done well just by looking at it? Isabela will then take over and focus on the first part of empirical work, which in the space, which I've sort of called, how much does a given sort of type of policy tend, based on evidence that we have, to help targeted sectors to grow? Think about that almost as like a first stage, if you like. It's just like, does it actually sort of do what it says on the tin? And then David Atkin will take over with a second half of empirical work, which is more asking a harder question, was sort of like, did it target kind of good sectors in some sense of good that I'll try to explain? And hence, was it overall good? Okay, so what is industrial policy? So we didn't agree on a definition, and we agreed we all have different definitions, so that might be indicative of this space. But I'm going to work with this very loose definition that it's kind of a deliberate attempt to shape to shape the composition of an economy. So it's inherently about targeting certain activities. Those could be firms, they could be sectors like manufacturing sectors, but also, of course, non-industrial sectors like a services sector, and regions. So think about those as kind of broadly as activities. And then by stressing the word shape, I want to sort of highlight the second big bullet here, which is that really the spirit of this is we're moving inputs around. Okay, so I can't stress that enough when one thinks about this policy area. We have a budget constraint on inputs in an economy. We have a certain number of units of labor, a certain number of units of capital. Of course, capital is potentially endogenous, so is human capital, but I don't think of that as industrial policy. So let's imagine we're holding the aggregate amount of such inputs fixed, and all we can do is move them around, right? So all we can do is shape the composition, not the overall magnitude. But of course, there could be good ways to shape the composition and bad ways, and that's the spirit of what I'll be talking about. But so examples would be, we want less coal mining and more battery factors used with our workers. But of course, we could think about human capital being used in more R&D like activities, and we can think even about R&D activities. We can think about putting those things into R&D today versus R&D tomorrow, and that I'll think more broadly about the notion of targeting. Okay, so of course, why bother? Classic two reasons, equity and efficiency. The equity one, the redistributional angle, I'm not going to say anything about today. That's of course interesting, super context specific, and this might be a good way to affect, to favor one group over another. That's not what I'll talk about, but instead I'll focus on the efficiency angle, which of course I'll just label kind of raising aggregate welfare. So, of course, the simple answer about how this would work, as we all know as economists, is that there has to be some market failure. Why do we know that? Because, of course, the first welfare theorem tells us that that if there were no market failures, then everything is just kind of perfect, perfect in a Pareto efficient sense, not necessarily the right redistributive outcome, but again, we're not talking about redistribution. So everything is Pareto efficient in that hypothetical absence of market failure. So another way of saying this is as it says on the slide here, kind of the VMPX. What is that? Value marginal product of some input that I'm calling X. Okay, so X could be capital, X could be labor, X could be anything you want. But there is an X, and again, it's sort of fixed, and we're moving it around. And of course, we know we can do better with the aggregates if the value marginal product of that input is higher in some activity, like number 1 here, than in some other activity, like number 2 here. So this, might sound tautological, but of course, it's sort of profound because the first welfare theorem actually says, well, no, you'll never find this. VMPX is already equalized everywhere. Don't touch a thing. The optimal policy is no policy at all. And it's if and only if we have this VMPX differentials across 2 activities that we could have the hope, of doing better. And another thing I want to stress here is what it says in the blue box there, that the V there, of course, needs to be very broad and inclusive. So in other words, don't just think if we're talking about sector one being like a firm, of course, they in some sense might make two things. They might make they're good, you know, the hamburgers they sell or something, but they might also make something else like an environmental externality. You can think about that external pollution or whatever as a second good that they make. And the V there needs to sum over both those activities, both those goods that the firm is making. Another classic example would be a literal knowledge spill activity where what this firm is making is not just hamburgers, but also like knowledge about how to make hamburgers that maybe spills over. And so the V again, in that context, would have to include both of those things. Okay, but otherwise it's your standard textbook definition of VMPX. All right, so, you know, of course, a provocative way of saying this is the way that Boskin put it, that if you don't believe there are market failures, then you have to believe in this statement, that it doesn't matter whether my country makes potato chips or computer chips, microchips, as long as we're talking about the same dollar of each, it doesn't matter, right? Everything's already optimized. On the margin, of course, you know, that first unit of water, that first unit of potato chips is very valuable, but on the margin, we think they're equally valuable absent market failures. Okay, so why might we expect market failures? Again, this is textbook, but I think it's worth rehashing. So classic top of the list example that I think is very relevant probably in a lot of settings would be knowledge flow externalities. So, you know, I think those are likely to be especially true in things that are new. You know, we probably don't expect as large knowledge flow externalities in the pencil making sector because that has just been done for a long time in a lot of corners of the world. Whereas in the solar panel industry, we might expect it to be a lot larger just because it's new. Of course, the notion of new can vary by context, but in that example, I was giving a global one. You know, however, I think we do need to be careful about such knowledge flow externalities. I think a lot of knowledge flows are being paid for. You know, somebody is buying the lessons. They might be buying it in kind via, you know, the fact that they pay a higher price for buying a physical input, for example, from a supplier who's teaching them something along the way. But in principle, those knowledge flows probably very important to exist. Why? Because, you know, of course, ideas are non-rival. So there, you know, there's sort of something inherently in the air about those things that makes them different from normal goods. This, of course, bullet would capture all the classic things that can be both static. We often call those external economies of scale, but also dynamic ones like learning by doing, but of course, of an external form. Okay, the second one, of course, classic environmental externalities. Third, public security. That's how I personally think about a thing like national security. Fourth would be, you know, kind of classic incomplete markets, credit and insurance markets. I think about this, maybe I'm wrong here, but I think about that very kind of colloquially as just saying that the people making the decisions about an investment, the entrepreneurs, don't have the right incentives to be risk averse if we lack insurance markets. You know, if they're assuming they're undiversified. They might also have the wrong incentives to be farsighted because they sort of can't get the capital today. So they're implicitly acting like they're too short-sighted. So if, you know, whenever I hear policymakers sort of thinking about the private sector undervaluing, you're not taking enough risk or not taking enough, you know, moonshots, I guess that's what they have in mind, something like that. We can talk about market power as well. And then, of course, finally, internalities. We, you know, have lots of reasons to suspect that firms inside them, even if they're as rational as all hell, they still face internal political agency problems. Okay, so how plausible are these things? Well, I don't know. I mean, I personally, when I wake up as an economist and read in The Guardian that all of these are cataclysmic failures, you know, I start to wonder, well, how do we know? Do we know these things are all really big? However, I think there's a lot of reasons to expect market failures in any economy we look at. What I find much more challenging is where are they relatively worse? So remember, let's go back to this VMPX thing. Of course, you know, you could have externalities that make that V very big and another externality that makes that V very big. If both these sectors have tons of knowledge spillovers, both of those Vs will be enormous. However, what would, of course, we need is a differential VMPX to justify industrial policy. So knowledge spillovers per se are not a justification. Environmental externalities per se are not a justification. It's the differentials across the activities that are the justification. And I think that's the hard part about knowing how to do this well. Okay, so green, I've circled the things here in green that remind me of green industrial policy. Obviously, environmental externalities gets a green circle. Obviously, new innovative activities gets a green circle, I think. And obviously, I think of environmental you know, challenges as involving a lot of risk and involving a lot of forward-sightedness. And so that also gets an extra green circle. That's the last thing that's green that you'll see today in my talk, with apologies. So what is not market failures? So here's, you know, kind of a if this was Econ 101, this is maybe Econ 102. Coordination failures, no, it's only when it's only because of positive externalities that we might have multiple equilibria, and hence that are rankable, and hence there might be a role for coordination. Absent externalities, there's no such thing as coordination failures. Same thing with input-output linkages. Input-output linkages, the fact that the solar sector needs certain mined goods is not an externality, right? It works through prices, we tend to think, and so the presence of networks of complementarities are not at all an externality. Internal returns to scale, not at all an externality. The firm fully internalize it. One caveat, though, obviously, is we don't think internal returns to scale is consistent with perfect competition. So, the primitive problem is market power, not increasing returns to scale. Inside the firm, I tend to think. Finally, or almost finally, screwing foreigners. You can think about lots of things as just like, I'm going to help my country at the expense of foreign citizens. So I'm going to try to attract global capital, from other countries. I'm going to try to affect my terms of trade. These things are obviously global zero sum, and they also invite retaliation. I think we now increasingly know that that's true, that the unilaterally, recent countries have tried to experiment with this, have tried to change their terms of trade with a unilateral WTO rule-breaking increase in tariffs, and immediately get slapped with retaliatory tariffs that, according to standard estimates in literature at the moment, look roughly like they've harmed the initiator of such a sort of trade war. Okay, so I don't think that's not a market failure, number 4, and neither is number 5. Whenever I hear or talk of jobs in this kind of space, I usually think that this is kind of nonsense. The coming at this from a perspective where, to a good first approximation, I think in many domains, the sort of stock of employment is roughly constant. And so what we're talking about is moving it around. So we will create some jobs in some places, but that will inevitably destroy jobs in other places. That's a fantastic thing. And it's only because they destroyed some jobs that we get the benefits of industrial policy by moving employment from one activity to another. All right. So what would a good industrial policy look like against that framework? Well, here's the rule of life, according to Pigou, that in optimal Pigouvian policies in general, not just industrial policy, of course, you've probably seen this before, but it bears repeating, that the optimal subsidy on, let's say, activity number 1 for input X, that's got a star in it because it's optimal, that's the left side of this equation, has got to equal, if you know you're doing things right, the market failure wedge caused by the externality that was bigger in 1 than 2. So, for example, if we think that that the elasticity of the activity number 1's output with respect to industrial pollution, forms of environmental pollution, is 0.2, then this, of course, classic Pigouvian formula tells us that a 20% subsidy is optimal. That's what this is saying. So obviously that targeting could be across kind of different types of inputs, as I've stressed, different types of activities, but also different points in time. You could imagine that now is the time, in a world of credit constraints, of course, now is the time to subsidize capital, not in the future. And so you'd have to index everything here by time, but that's fine. Okay, so obviously the real world, we don't always have subsidies, just a classic kind of, if you install capital, I'll pay you extra. That, of course, does exist. It often works through tax breaks, but we can think more generally about forms of trade policy, biased procurement, eased facilitation of getting around everyday regulations of government life, maybe even eased, reduced corruption, risk of expropriation. All of those things will implicitly move this thing I'm calling X from sector 2 to sector 1, and that will be a good form of industrial policy as well. It might not be the first best. We tend to think from a targeting principle that a targeted subsidy is first best, but there could be others that are approximately the same. Final thing to mention, nothing in Pigou's formula would solve coordination failures. It's going to get kind of prices right on the margin, but might not get the right prices right. Recent work by a student I know, I'm sure this is a wider point, but it's a point that was brought to my attention by the work of John Sturm, highlights a sort of sense of super Pigouvian policies and what they would look like if they not only get the prices right, but also move to the good equilibrium over bad equilibrium. And they do that by not just posting right subsidies, but also sort of doing other things that affect off equilibrium beliefs. Okay, so what would a good industrial policy not look like? This maybe is worth remembering, because you'll see
statements to the contrary here, even in recent survey articles on industrial policy. But it looks like this. That's the optimal one. So notice it has nothing to do with any of the following attributes of the industries, right? So it has nothing to do with whether the industry is central in the input-output network, right? Or upstream or downstream or extremely central vis-a-vis distortions or anything like that. It has nothing to do with that. It has nothing to do with the industry's TFP, its size, its location, its high-tech status, its low-tech status. None of that matters. It's all about this market failure wedge per se. Of course, many of these things might affect that wedge, but it's the wedge that's what matters, not any of these other attributes. Trade, nothing to do with it per se. We can talk about an export-oriented industry, an import competing one, a comparative disadvantage, advantage sector. Again, nothing per se. It's all about the wedge up there. Same thing for growing and shrinking industries. So to me, the sort of phrase good industrial policy picks winners, and that's the challenge. I find that a very misleading statement. Maybe it isn't to you, but you need to define winners as ones that cause big externalities, right? I mean, if we do that, we're fine. My problem is I look at examples like Solyndra, the classic example of the sort of the solar firm in the United States that got $500 million of Obama funding and then went bankrupt. Everybody says that's your canonical industrial policy failure. It might be a fantastic success if they were fantastic at generating externalities along the way. In fact, whether the targeted activity itself grew or shrank is not per se the most salient thing to think about. It's whether the externalities you thought they were going to be creating and hence justified the industrial policy, existed or not. That's what we should be asking about Solyndra, I think. Okay, so finally, I'll talk about from this theoretical background that I've tried to provide, some little hints or some guidance on what this might imply for evaluations of industrial policy, which is what Isabela and David will turn to next. So just want to stress two non-standard econometric problems for the econometricians in the room that are at the heart of industrial policy, as I've defined it. One is like SUTVA violations, SUTVA stable unit treatment value assumption. In other words, the assumption that there are no treatment spillovers. So this is concerning the responses of X, the input, right? So if we're running sort of like a first stage and we're interested in asking, did X move around? We have to acknowledge that regression is 100% contaminated by spillovers. It's at the heart of why we're doing industrial policy, because we're moving X from say 2 to 1. And so there will always be those SUTVA violations, which means we have to think harder than usual about interpreting estimated treatment effects. The second thing is a different treatment effect. That's the effects of X on value, on this thing I call V. The essence of that is that there are heterogeneous treatment effects. If you didn't think there were heterogeneous effects of X on V, you wouldn't be doing industrial policy in the first place. So it's kind of got these two non-standard features. Like so many of the regressions I run, both ignore spillovers and don't look at heterogeneous treatment effects. This sort of tells me like those statements are both exactly wrong if we're really thinking hard about industrial policy. Second would be, I'm not sure why per se we would expect the TFP. Obviously, TFP growth usually looks good. It's like manna from heaven if we've done it right. But I don't know why we'd expect TFP in like the targeted. Say we're targeting a firm. I don't know why we'd expect their TFP to rise. The hope is that they cause knowledge spillovers and make other people's TFP rises. Now, of course, you might expect there's reverberating effects. You're treating an entire industry, so you see both this firm's TFP rise because of the effective growth of others and vice versa. But it's inherently indirect if it exists at all. The third point I'd make is that this is sort of follows exactly from the same logic of the Pigou, that this is the first order gain from moving a little bit of X. So I think it's got a very robust intuition behind it. Which is, you calculate the amount that you're moving, the amount of that X that you're moving, and you multiply it by the pre-existing VMPX gap. Of course, if that gap was 0, you'd get no benefit from moving. And if you don't move anything, you'd get no benefit from industrial policy. So that, of course, kind of splits up the gains from industrial policy into like, how much are we getting to move and what was the initial gap? That's sort of a guide for empirical work. Of course, you'd expect larger gains as economists. We'd expect a given subsidy to have larger effects on delta X under standard conditions that we're used to thinking about. Think of kind of, Hicks-Marshall kind of conditions. If, for example, the sector 1 is highly tradable, that means the demand for it is probably super elastic, which kind of means you can subsidize capital in that industry and expect that industry to grow massively because it's not sliding down some demand curve. It can just sell to the world. So, this kind of intuition justifies larger gains from industrial policy in tradable activities. It doesn't change the formula. Remember, the formula still remains this. It has nothing to do with trade. I'm talking here about the gains from such policies, which would be larger in tradable sectors, all else equal. Finally,
asking the question of whether it was optimal, just to reiterate, that has nothing to do with whether the delta X moved or moved a lot or moved a little. It's instead all about those VMPXs. Remember, if there was no gap to begin with, no externalities to begin with, you wouldn't be doing it in the first place. So, what I feel would be a boon to future work in this area, empirical work in this area would be, and from theorists, would be more guidance on sort of how can we learn all about the externalities. And with that, I'll stop a minute early. Well, yes, occasionally that happens.
Okay, wonderful. Thank you very much for the opportunity to be here and to follow Dave and precede David. Very exciting. So without further ado, let me start. Very quick meal overview. I'm going to propose my definition, or not propose my, but sort of put forward what I think the latest definition of IP is, that is agreed to by the prominent names in the profession. Then I'm going to define what I mean by the effectiveness of industrial policy. So IP here is not intellectual property, is industrial policy. And then I'm going to do a very selective review of the evidence on the effectiveness of IP, and an even more selective review on the evidence on the effectiveness of green IP. So let me start with that. There are different vintages of what industrial policy is and how it is defined, but I will use the latest vintage, which is coming from Juhat, Lane, and Roderick. They have a new forthcoming annual review of economics article. And I needed to start from a definition to know what are the limits of the literature review that I should introduce you to. And basically, a lot of things can fall under industrial policy. So anything that is explicitly targeting the transformation of the structure of an economy in pursuit of some goal, it could be innovation, it could be productivity, it could be economic growth, it could be the green transition, that would be industrial policy in the eyes of these authors. It could include the support for services and R&D. It could overlap with regional policies, place-based policies, innovation policies, and in developing countries, many times industrial policies are often called productive development policies or structural transformation policies. So as you see, not an easy task with which to start a 20 minutes lit review. So what is green industrial policy? There's not as much, there are not as many review articles on what green industrial policy might be. So here you have my own categorization. It should be a humble one because this is not my field of study, but here it goes. So the way I thought about it is, on the one hand, you could have ex ante or explicit green industrial policies. They could fall under two categories. One could think about, let's say, to simplify, that we're keeping the same mix of traditional industries. So let's say we still want the automotive industry to remain 10% of our GDP, but let's make them green. And how do we could make them green through the inputs that they use, through the processes that they use in production, but they could also be made green through the output itself. So we're switching from what used to be a car to new electric cars. So that's one way of doing green industrial policy. Another way is to try to tilt the industry mix towards industries that produce green technology. So you could think about biofuels, solar panels, wind turbines, etc. So this would be, for me, again, with humble humility, these are ex ante or explicit green industrial policies. But you could also think that there are exposed or implicit, green industrial policies that, for instance, support mechanically green industries, such as services, that attract firms known to be greener, such as multinationals. And if these multinationals have responsible sourcing policies in place, then also their value chain might be made greener. We could be reducing trade barriers, which would have several benefits, but among those, it allows us to access cheaper green technologies. And in general, any industrial policy that encourages firm level upgrading, in the end, might have greener outcomes than not. So given the limited time that I have, when I go into the lit review part, I will only focus on the ex ante or explicit green industrial policies, though I don't think those are the only ones our attention should be focused on. So first, what is the effectiveness of industrial policy in my view? So basically, it's the answer to the question, did the policy attain its narrowly defined scope, which is encourage a certain industry, a certain group of firms, or a certain region to grow relative to its counterfactual. Some among policymakers and academics have very strong positive priors on what the answer to this question might be. Namely, they think, of course it should. If we encourage through subsidies, through tax breaks, industries, firms, and regions, then they should be growing relative to their counterfactual. Of course, there are several caveats when we go to the trying to find causal evidence. First, the growth might have been inevitable. So if we're picking winners, sorry to use that misleading terminology, but if we are picking inevitable winners that will win regardless of any policy, then we would be a bit too generous in attributing causality to that industrial policy. So here it's really important when we do reduced form empirical analysis to find a credible counterfactual. And second, and this is a thought that came to me as I was going through the lit review, is do we care about effectiveness during the policy term, or do we care about effectiveness in the long run after the policy is being discontinued? Because what I've noticed as I was going through the lit review is that if you do short run analysis, typically, yes, we find good things happening, but in many longer term analyses, actually the moment the policy is discontinued, the targeted sectors, firms, regions revert back to their trend. So of course, growth is not always self-sustaining, and it's given that our publication for academics incentives are to publish, we want to be able to rule out confounders, and of course, that's easier done in short run analysis. Some have very strong negative priors on whether even the effectiveness of industrial policy will be achieved. So for instance, some think that governments are ill-placed to pick winners. They don't have the right capabilities, the right incentives. So think about, again, the example that Dave gave on Obama picking Solyndra and Solyndra going bankrupt a year and a half later. Some are concerned that IPs are targeting sunset industries that are already doomed, and as much money as we pump into them, it's impossible to resurrect them, or industries or firms, and the government could also be at risk of capture and rent seeking from vested interests that lobby with them. Another type of argument that is being used by those who are against industrial policies, even from the effectiveness perspective, is that there are all sorts of, the devil is always in the details. Even if you have good intentions, you might have poor policy design, poor implementation, particularly in states with weak government. So even if the intention is good, the implementation is terrible. So for instance, Danny Roderick has an interesting article in which he underlines the fact that in East Asia, the policy support was mainly contingent on performance. And he attributes the success of the East Asian policies to these conditions, whereas in Latin America, there were no mechanisms to weed out the non-performing beneficiaries. Maybe they were encouraging entry, but entry on the margin was done by less and less productive firms, so on and so forth. There's a very interesting forthcoming re-study by Warwick, Al-Sidi, and Zahur that thinks about the case of China, the shipbuilding industry, and really goes in a very structural way. I know this is more about the empirics, my session, but just to say that that is an interesting paper that looks at the different ways in which we could implement policies that have the same effectiveness outcomes. And last, given that we have an audience that is coming more from low and middle income countries, assuming that there is some growth that we measure of the industry region set of firms, is it genuine? So what I mean is if you have weak institutions, they might not be able to prevent or detect abuses, manipulation, so on and so forth. There's a fun paper in AER from 2021 by Chen et al., in which they show that in China, tax cuts to firms with R&D investment, yes, they led to higher R&D expenses, but a non-negligible quarter of that were actually relabeled expenses. This was not genuine R&D. Okay, so given that, let's go through some evidence. Recall that, as we say in Romanian, the garden of God is very generous when we think about industrial policy, so it's hard to do a thorough lit review. So I'm going to go through two place-based industrial policies. The Cruz et al. Paper is the first one that I'm going to mention. Of course, there's Ralf, there's John in the room, so sorry you're in the et al. Let me just, very quickly tell you a couple of things about the paper that I think are worthwhile remembering or food for thought. So what was it about? You had an investment subsidy to firms in areas in the UK that were seemed to be otherwise, so those areas would otherwise have performed badly. So the subsidies, the effects of these subsidies, if I read well the data section of the paper, is looking at a change in the eligibility of different areas in the year 2000, and it's using data from 97 and 2004. Please correct me if I misunderstood. So what do they find? They find that areas eligible for higher subsidies, they increased employment, particularly in manufacturing, and the effectiveness result, the fact that they did find growth in employment, was entirely driven by the smaller firms in their sample. And basically, they showed that the money that was given to the larger firms was basically lost, had a zero effect. And what could explain the zero effect on the larger firms? Well, even in the context of the UK, why not try to game the system? So large multi-plant firms might have been able to game the system, especially shifting workers around plants. And also, if we're in a world with financial constraints, and if those were faced by only the smaller firms, that's another explanation for why we don't have an effectiveness result on the larger firms. Just very quickly to emphasize on this paper before moving on is the fact that the time window is quite short. So it would be interesting to have a follow-up of this paper to see once such subsidies are removed, whether we still find consistent, persistent effects on the smaller firms. Okay, a second paper that I want to just quickly point out to you, of course, the work of Klein Moretti. There are several papers on place-based policy, but the TVA paper, the Tennessee Valley Authority paper, is an interesting one. So there you had a big push policy focusing on the state of Tennessee and the area of Tennessee Valley. The controls there were authorities that were proposed to receive a similar package of place-based policies, but were never approved by Congress. And what do they find? They find that the TVA generated gains during the period of the policy in both agricultural and manufacturing employment. But the moment, so this is an advantage of having this long run type of analysis, the moment the TVA transfers lapsed, basically the gains in agricultural industry were completely reversed. And it's only the gains in the manufacturing employment that continued to intensify. And it's forbidden territory for me to go into externalities, optimality, things like that. But, this is food for thought, going towards what Dave said and what David will say. Now, focusing on what is typically the bread and butter of industrial policy, namely industry-specific IPs, I'm going to refer to two papers, and these two papers, both of them make a big deal, both of finding direct effectiveness effects, and indirect effects. And I'm happy that Dave sort of clarified for all of us that why do we care about the input output structure? Why do we care that downstream industries are growing? Unless we're emphasizing what the externality issues are, this is not sufficient to show. But anyway, nice that we could show it still. So the first paper is Nathan Lane, forthcoming or conditionally accepted at the QJE. He's looking at a historical episode, South Korea's heavy and chemical industry drive. It was, so one interesting feature there is that it was introduced in 73 and it was discontinued in 79 when President Park, the president of South Korea at the time, was assassinated. And not great for him. What does Nathan find? He finds evidence of positive effects of the entire package going into the HCI drive on targeted industries relative to non-targeted industries within South Korea. And also he finds positive downstream effects on industries that are, from the perspective of the input-output table, more reliant on inputs from the targeted industries. So, you know, this is interesting evidence, and so I will stop here. I'm just on effectiveness, but yeah, so this is not sufficient, but it's necessary evidence towards making a broader case for industrial policy. So just very quickly on the effectiveness point, two things that I want to emphasize. And Nathan Lane has a very interesting trade talks episode that goes into the depth of it. A lot of the effectiveness of this policy is reliant on political circumstances. The Nixon doctrine, there are a lot of interesting things happening at that time. And of course, we can all ask ourselves how replicable those political circumstances are. On the positive side, something that is optimistic coming out of this paper and a bit in line with the manufacturing results from the TVA paper of Klein and Moretti is that even when the HCI drive ends in 1979, the effects, both direct and indirect, persist. And, you know, okay, great. On industrial policy, another paper that is a paper of mine that I just wanted to emphasize self-promotion, but also because I think it has some interesting features. So very quickly, what is it? Romanian income tax break to workers in software creation. So that's what we wanted to do, software creation. It happened in 2001. It's still in place, noteworthy. And we show, similar to what Nathan does, is that we find direct effects, so growth of the software creation industry, and indirect effects in downstream industries that are more reliant on software creation inputs. Small differences methodologically. I know there are a lot of grad students in the room. It would be interesting to use synthetic diff and diff methods in this kind of case, because you don't only want to control, you don't want to just compare with respect to the same industries in your own country, but you also want to think about a counterfactual country that did not have that policy in place. So in terms of what we learn about the effectiveness, and we kind of make a big deal of this in the paper, is that the net of conditions that had to be met by both workers and firms in order to be eligible for the tax break was so ridiculous that it was very hard to game the system. So the Romanian government knew, haha, we know you're going to try it. We're going to impose such strict conditions, and so many of them, that we really want genuine software creation. So in terms of how to create how to design effective industrial policies, this is something to keep in mind. On the negative side, what we learned from this policy, well, it's still in place, not great news. And what policymakers say, well, now was retaliation. Other countries are also focusing on the IT industry, giving a lot of subsidies to this industry. So basically, we have a tax race to the bottom, and also the kind of workers that are employed in this industry are very footloose. And this kind of relates to the point of Dave on, well, screw the foreigners. Well, they screw us too. Okay, and very quick, so I think I have only 3 minutes left, so I will sort of fly through the remaining slides. There are also other interesting papers looking at unintended industrial policies. So the paper of Reka Juhas is an interesting example. It's thinking about the Napoleonic blockade and what that meant for the mechanization of cotton spinning in France. I will not go through the details. I will just sort of focus on the last two bullets. It's an optimistic paper in the sense that it finds evidence on capacity increases in mechanized cotton spinning, both in the short and the long run, much after the Napoleonic blockade stopped. However, something that helped towards publishing an AR is that it's a historical episode that deals with the political economy of industrial policy. For the policymakers in the room is, okay, what have we learned about it? Because in the real world, of course, you have political economy, you don't have Napoleonic blockades. So in that sense, it's harder to read from that. I will conclude in the last 2 minutes on the effectiveness of green industrial policies. So the 2 bullets that I mentioned on the explicit green industrial policy. So a first example is keep the industry mix fixed, but try to make it green. Duflo and co-authors have a series of papers, I'm just flagging one, in which they're looking at how a state in India, Gujarat, tried to increase the greenness of its most polluting plants. They show that the status quo is one that has a very corrupted system of plant level inspections and third-party environmental audits. So if you're even if you're trying with sticks to greenify your plants, if you are in a state with in a state of status quo that is with green with weak state, then basically it's hard to enforce environmental regulations. So this is a challenge that is not unique to low and middle income countries. You might all remember the Dieselgate, Volkswagen emission scandal in which they were cheating on emission measurements. But of course, this challenge is also exacerbated in countries where regulators lack resources. So they had there an intervention to incentivize accurate reporting, but that was effective. But if you read carefully their conclusion, they say that they're not definitive on the cost benefit ratio of that intervention. And I will finish with this last slide. So here it's more about evidence on policies that try to encourage green industries per se. So the solar photovoltaic panels industry. There's a series of papers, some older, Groban Kao, Huang et al., and of course, interesting work in progress by several in the room. And basically, what is the case study that they're having there is the Chinese solar photovoltaic industry that went from basically being non-existent in China from being a global leader, 45% of the market, 10 years later. And the different papers are trying to assign causality to the industrial policies that were undertaken by China during that time period. Sort of 2 reflections that I have, and some of these papers are also emphasizing, is that it's really tricky to disentangle the exact contribution of industrial policies relative to other important developments in the success of China. One being China's joining of the WTO and all the increased incentives to boost this industry that came from it, and the simultaneous support for renewable energy that was happening in the US and Europe. For those of you familiar, Spain is in a lot of trouble, is being sued by investors left and right, because they first came with some very generous feed-in tariffs. A lot of investors came to develop the solar industry, and in Spain, they realized they're going to go bankrupt. They reduced the tariffs, and now they're being sued. So interesting story for China, but words of caution, and also India's failure is another word of caution. I'm going to close by saying there are some interesting review articles, and I'm going to be killed. So I need to go. Thank you.
Very much, Isabela, and David, the final speaker in the academic session.
Great. So thank you so much to Dave and Isabela, who have queued us up queued me up very nicely. So kind of the big picture, we've covered the basic theory that Dave laid out, as well as the evidence for what Isabela was calling effectiveness. Are you able to shift resources between sectors and see sectors disproportionately grow as a result of it? And now what I'm going to talk about is if we're able to pick the right products and sectors to support, and given Dave's note on terminology, I'm calling this picking winners, and I mean, are we able to kind of pick these high externality sectors, etc. Okay, so I'll kind of talk about this in kind of 3 steps. What do we know about the effectiveness of picking winners policies? How might we kind of pick winners better? And how might green industrial policy differ from more standard industrial? Okay, so the evidence which Isabela laid out quite nicely was this idea that industrial policies that we've seen in the past, either actual policies or shocks that mimic those policies, can indeed induce changes in industrial structure. And then there's sometimes evidence that these are temporary policies and they're kind of persistent changes in industrial structure, which is kind of really pointing to these dynamic external economies, learning by doing, as Dave mentioned, for example, although obviously there'd still be grounds for industrial policy if there were of a non-dynamic nature, even if we didn't see this persistence. Okay, so we think we can shift resources towards sectors we want to help. And so that's reassuring and encouraging if we want to attempt to shift resources towards greener products and technologies. And as Isabela said, that's not immediately obvious. Lots of critics of industrial policy would have said, no, actually, it's very difficult to do that because of rent seeking and corruption, etc. So I think the evidence is now suggesting that maybe those problems aren't as severe as people might have thought. Some people might have feared, and we can indeed do that. So now I'm going to turn to this kind of second question, which we know much less about. And even though I, call myself someone who thinks there's, big benefits to industrial policy, we have to be humble and ask, do we actually know that these policies benefit society? What's the evidence base for this? And here, I think the evidence base is really quite limited, and I'll kind of try and lay that out. Okay, so why is it limited? Well, in the examples we've been talking about, it's very easy to come up with kind of cases where we see the industry that you've targeted grow relative to industries you didn't target, yet the economy shrinks as a result of this industrial policy. Okay, so you're finding the results that Isabela laid out, but you've actually shrunk the economy through doing these policies. Okay, and why might that happen? So just kind of 3 examples. One is if there are these dynamic economies of scale, some may be large in some industries and small in other industries, and whichever one you help, you will see that industry grow relative to the industry you took resources out of, and that will be persistent if these are dynamic, but you've done exactly the wrong thing in that case. You've kind of dragged resources out of high externality industry, put it into low externality. Similarly, maybe you actually put the resources into the right industry, but it's so expensive to kind of get the resources out of an industry because of the way you tax it or however you're doing that, that it's just not worth doing so, and that depends on exactly the instruments you're using. And a third reason, if you really think this is all about dynamic externalities, it's often quite hard to tease out what is kind of slow depreciation of capital or sticky factors such as entrepreneurship from what's actually a dynamic externality. So kind of for all these reasons, we struggle from comparing targeted to untargeted sectors to answer this big question of, did this policy mix benefit society? And central here is this issue of where would those government resources and maybe private resources that follow it or private resources alone have gone in the absence of this policy or gone otherwise? And is a place where those resources are de facto being taken from, did those places have larger externalities, maybe with bigger coordination failures as well, or larger distortions more generally? And, just to emphasize this point, what we really want is not a kind of natural experiment comparing an industry who got a favorable policy versus one that wasn't targeted. What we really want is kind of a comparison between a country that tried to implement industrial policy and a country that didn't try to implement industrial policy, or across time periods where there was industrial policy versus not. And I'm not aware of a very convincing natural experiment that people have done, which actually gives us that comparison, which is kind of the reduced form way to answer this question. Okay, so, because of that, what we kind of rely on is, as Dave kind of highlighted, is good measurement of those value marginal products. and kind of a model structure potentially to kind of give us the other parameters we need in order to kind of calculate the impacts in Dave's formulation to calculate that kind of change in X with the particular policy instrument you're bringing about. Okay, so I'll talk now very briefly about what we do know from those types of studies, and here kind of a leading paper here is by Dave himself, and he already kind of mentioned some of the theory behind it. And what they're going to do is they're going to try and kind of estimate a particular type of externality, which is going to be external economies of scale, whether or not when an industry gets larger, the productivity goes up in a way that's kind of external to the firm. And they're going to do so for kind of 15 broad two-digit manufacturing sectors. And the way they're going to be identifying those external economies of scale is through this idea that what we should see is if productivity is improving, prices go down, and that's going to show up in kind of larger exports to other countries. And we'll see how much productivity goes down when the country itself has a larger domestic market for plausibly exogenous reasons based on country size or taste shocks. Okay, so when we do that, we get actually quite a large external economies of scale that differ quite a lot across sectors. So in those formulas Dave wrote down, it seems like there's a lot of scope for optimal industrial policy to really boost welfare by moving resources from sectors which have low external economies of scale to sectors that have high external economies of scale. But when they crunch the numbers, despite these kind of large differences in externalities, actually the gains from industrial policy are at least to my mind, quite small. This is optimal industrial policy, kind of the best case scenario. They're about 1% of GDP on average. They go up a little bit more if you complement it with trade policy. So why are they quite small? Well, some of it is because if you are moving resources into a sector, the outputs are going up, that's going to tend to reduce their price. And so you'll have a kind of negative terms of trade effects. But most of the reason why those numbers are small is because demand's inelastic. Essentially, it's very hard for, you want to pull resources out of these sectors with low external economies of scale. But when you do that, then there's very few substitutes for those products produced with those inputs, and people don't want to do that substitution, so you can't pull so much labor out. Okay, so that's a somewhat kind of pessimistic result, which says, there's not huge gains we're leaving on the table, at least if you kind of take all of these kind of estimates as truth. Now, there's some caveats. I mean, this is a reasonably structural exercise in places, and so there's always issues there. But at least in my mind, one big caveat here is, a lot of the discussion around green industrial policy, think about the solar panels, etc., is about these new technologies, which we're not talking about a whole manufacturing sector, we're talking about a particular technology. And there, kind of the learning curves may look very different to these external economies of scale at the national level for a large sector. And so, this exercise isn't set up to try and see whether or not you might want to subsidize a kind of very small particular technology. There's a related paper by Ahmad Lashkaripour, and he's going to present a related paper in the next session as well. And they do a related analysis, focusing on a kind of a more specific scale elasticity coming from larval variety, and estimate that from Colombian export data. And there, the kind of the highlighted force, which is also in the Batalny et al. Paper, but these kind of terms of trade effects. And in fact, what they find is kind of at these narrower product levels that they're using, there's kind of an inverse correlation between the goods which kind of you want to subsidize most because they have these large scale elasticities, and the goods that are going to hurt your terms of trade the most, or where terms of trade are going to decline the most when you increase quantities. And actually what that means is you get this kind of severe immiserizing growth, where actually if I unilaterally put in place industrial policy, I'm actually going to be worse off because of the reduction in price of my trade bundle. And so this kind of pushes towards international coordination. Now, this is kind of quite different from some of these kind of beggar thy neighbor type ideas we may have in mind, where here what you want is everyone to put in place kind of subsidies on solar at the same time to essentially stop these kind of tons of trade effects. And so that's at least what this paper suggests we should be doing. So, I'd argue that, already, these are difficult exercises and they're kind of first steps in us attempting to kind of learn more about how effective these policies are or whether or not they actually do increase aggregate welfare. And even then, despite all the assumptions that have to be made, there's still only a focus on a single externality. And in reality, particularly in developing countries that many of us here are interested in, there's kind of a myriad of potentially overlapping distortions, things such as the environmental externalities that are central to what we're talking about today, but also contracting frictions, credit constraints, markups, labor regulations, cross-industry knowledge spillovers, etc. And in that case, it's going to be true that if you put in place IP designed for kind of one kind of narrow distortion, then it may worsen the misallocation of factors on other dimensions, as is well known. And we just need to kind of be careful to kind of avoid those types of situations. So, it's difficult just to measure a single set of externalities, let alone many of these. In a recent handbook chapter, me and Dave gave it a go at least. And using the World Bank Enterprise Survey, we've kind of estimated 9 different categories of distortions by firm type separately for the 142 countries covered by the World Bank Enterprise Survey. And this allows us to do exercises such as asking, if we increase trade openness, how does that move factors around? Does it push them in or out of more distorted activities or potentially change the size of the distortions themselves? And I think when we're thinking about kind of green industrial policy, given that we're often operating in these developing countries where there's many other policies in place attempting to deal with certain distortions, we want to make sure that the green industrial policies are kind of complements to kind of the existing policies in place to relieve misallocation rather than kind of competing with those other policies. We're getting increasingly better at ways to do that, thanks to some theoretical insights of Bakai and Fari, as well as attempts to kind of bring that to the data. Okay, so no title here. Okay, so while I think it's difficult to estimate all the relevant externalities, market failures, etc. And so, I don't think tomorrow we're going to have a really great answer to, yes, industrial policy as done by countries today is definitely increasing aggregate welfare or is not, or by how much. People like Danny Roderick, as Isabella laid out, would make the argument that, listen, the policymakers are doing a lot of industrial policy anyway, and we're going to be hearing from some of this shortly. And so the question is not really, should we be doing it or not, but how can we do it better? Okay, and Roderick has some nice work, not only on industrial policy, but also on green industrial policy, and he suggests kind of 3 design features which are kind of relevant here. Okay, so the kind of 3 features he talks about are embeddedness, discipline, and accountability. So what's embeddedness? That's kind of involving the industry in the design of these policies, both because they have a lot of information that's extremely valuable. It allows you to be more agile and maybe kind of change path as new developments occur in those sectors, as well as potentially solve coordination failures between the private sector and the public sector by having everyone sit together. Now, obviously, you would worry by involving industry that maybe you're even more prone to capture and such like. And so the kind of the second pillar here is discipline to kind of push back against that risk, which is having clear objectives, targets, make sure you're trying your best to evaluate and monitor. And coming back to the Solyndra example, maybe Solyndra was a company that should have been subsidized because there were big spillovers, but you quickly want to let go when you realize that this particular money is being wasted. So here there is a little work. It's probably the only kind of area on how to do industrial policy better, where work is starting to come out, where people are looking at whether or not there are other ways to avoid some of these capture issues, maybe leverage machine learning methods in order to help better pick kind of sectors or firms or algorithmic approaches. I have a project in the field trying to compare the use of kind of industry experts who are well-informed but potentially biased to kind of bureaucrats who are less biased but have less information, and the trade-offs between those two. Then Roderick also talks about accountability and to make sure that the policymakers themselves are accountable to make sure that these programs are working and there are democratic checks and balances. And here that can take various forms, one of which is something which John, Robin, and others have been looking at with the solar power example, the solar panel example that Isabela mentioned, whereby you might want to have kind of policymakers compete with each other across regions as kind of a method to make them more. Okay, so, I would kind of echo that nice review that Isabela mentioned by Juhas, Lane, and Roderick, which, really says, listen, there should be a lot of work. There's a huge policymaker demand for this, and there should be a lot more work in economics trying to understand how to do this policy better, given that these policies are being put in place, and there might be quite large gains, conditional policy being enacted anyway, to improving how it's done. Okay, so let me spend the last couple of minutes just thinking a little bit about green industrial policy and how it might differ from industrial policy more generally. Okay, so the first reason why I think green industrial policy might differ is because, in some sense, we might think that actually estimating environmental externalities is a lot easier than it is to estimate some of these external economies of scale or knowledge spillovers, for example. And why is that? Well, it's quite easy for us to try and estimate the carbon content of a particular production. I'm not saying it's trivial, but it's maybe a lot easier than estimating some of these more complex interactions. Now, that kind of puts me in two minds, which is, if all we care about, say, is the carbon content of production, then we already kind of know what is kind of the optimal solution to that, which is something like a carbon tax, which kind of most directly gets to kind of that particular issue. It may still induce directed technical change, which may lead to innovation outcomes. But I think most of us in this room wouldn't think of just a carbon tax to address our environmental externalities as particularly industrial policy. Meanwhile, if we're thinking about kind of green industrial policy focused on developing novel products and technologies like the solar panel industry, then we're kind of back to these kind of same problems. Where are the bigger knowledge externalities? Where are the external economies of scale? Maybe across kind of green technologies or between green technologies and non-green technologies. So here I think there is a difference in a positive way, but there are real questions on whether we just want to stick in place a carbon tax. But what I would say here is that if there isn't a carbon tax in place, then there's even more reason to put in place the green industrial policy. And maybe in the next session, as well as this evening, we'll hear more maybe about the relative political constraints vis-a-vis a carbon tax versus kind of subsidies, which seem kind of less objectionable in some sense to green technology. Okay, so a second way that green industrial policy differs is there's this kind of interesting interaction with the global commons problem of carbon emissions. With regular industrial policy, one worry you often hear about is kind of a risk of some wasteful subsidy race. Now, coming back to Dave's definition, maybe this isn't actually good industrial policy in the sense that if we just have mercantilist goals of this industrial policy in order to kind of shift rents to my country rather than the other country, then maybe it's not industrial policy we would be advocating, but it's certainly high in the minds of politicians when they think about battery subsidies, solar panel subsidies, etc. And in that case, maybe we get this kind of subsidy race. Every country's pumping a lot in. It's a winner-takes-all market, and there's a bunch of money wasted. But maybe in the case of a green technology, that's not such a bad thing, since it's kind of a countervailing force against this kind of tendency to free ride on other people's reductions in emissions. And so here you're kind of allowing this kind of subsidy race to move in the other direction. And then, very quickly, a couple of other reasons how green industrial policy differs. often, as Isabella laid out, we may want to not just develop a particular product, but change the way that product's made. And so, we may think that we need policies that are more fine-grained than typical industrial policies that may require even more embeddedness, even more industry knowledge, and even more discipline as a result of that. We may also require faster timelines than typical industrial policy if we worry about tipping points. These changes have to happen faster than maybe in traditional policies. And then finally, there's many the features of many green technologies that require particular coordination across sectors. For example, developing new energy sources naturally may require new distribution systems for energy sources, kind of backup provisions, for example, for solar power at nighttime. And so, it's not just one sector, it's multiple sectors that may need interventions. Okay, so that's all I have. And so thank you very much for joining us for the master lecture. And we're excited to hear what the policymakers have to say on the practice of these things.
Thanks very much. So that was fantastic from an academic perspective. I would like Enilde to go first in terms of the policymakers, really to the policy making, etc. And just to segue a little bit and picking up on some of the things. The reason that we call the day in green industrial policy relates to some of the things the academics have been saying. In many ways, economists, we think the kind of best policy, the first best policy of climate change is a carbon tax, a global carbon tax. It both reduces the usage of activity with jurisdictions and also gives incentive to innovate in saving carbon. But the political reality is that nowhere in the world has the level of the carbon tax we like, and in some countries like the United States, outside a couple of states, there's no carbon tax at all. So in the face of that, politically, industrial policies or targeted industrial policies are in many countries the only game we have. And you think of the Inflation Reduction Act of Joe Biden, that precisely does that. $400 billion, probably likely to be much more than that, specifically going towards things like electric vehicles, solar power renewables. So, that's the kind of political reality. In some sense, it's really important to think about when we think about the right policies that we do to do. So with that, I'll hand over to you. You want to come up front or?
Hello? Okay. Yes, I think so. Good afternoon, everyone. First, I would like to congratulate the presenters. Very good information and papers that they share with us today. Too much information to process, and we have a lot here to discuss, to see, to continue studying. Very good, very good. Congratulations. First comments. Very interesting issue that they bring related with the issue related with the externality and best policy. Sometimes it's not enough. It's important to see if the market is responding. Very interesting, because in the political issue, when we came to the policy, we see that sometimes the policy that we have in place, it's not enough to respond in what we are trying to improve when it comes to industrial policy. So we think that we still need to look and to make the necessary checks and balance to make sure that the gains in terms of policy, externalities, subsidies will take the economy for the right place that we need. Because in some countries, like in our context, in Africa, in Mozambique, the issue related with the incentives and some subsidies sometimes brings not the results that we expect in terms of pushing the sector, the industrialization, but it take us for a way that we lose, let's say, a little bit of our fiscal space. And this is a challenge that we are facing, and we have to decide in terms of policy if we design some incentives, some subsidy, or if we maintain the fiscal space that we need to invest in specific sectors, social and economic sectors. So this continues to be a challenge when it comes to reality in terms of policy. So very interesting to hear that we still need to start and understanding this. Other question that it's very interesting if the policy can benefit the society. This is very interesting because when we invest or we design some incentives for the small enterprise or the big ones, specific when we look to the big ones, we see that the results of this process of industrialization not always bring some gains to the society. And this is a question that we use to discuss always: how can we invest, bring some incentive for the big ones, at the same time we see the results for the society. That's why some policies are designed, but not in way, because of the high fiscal cost, not in way that directly benefit the high and the big enterprises, but trying to benefit the small ones, because we agreed that these ones will help more in terms of job creation. And on this way, with this channel, it can bring a little bit more benefit to the society. We think that, again, the subsidy and tax incentives has to be used careful. My question is, how can we combine, how can we push for the industrial policy, at the same times bring incentives to the society, while we are taking care about the high fiscal cost when it comes to the incentives or subsidy. Other important issue that I would like to bring here is related with the approach. I think that the approach needs to be flexible and context specific. We need to look to the specific economy. We need to look to the social and environmental circumstance of each country and each region, because the policy that we can design for one country or one region not always works in the same way, bringing the same gains for specific one or different one countries or region. So I think that we have to start discussing a little bit about the flexibility of the policy, looking to the specific context of the economic and social and environmental circumstance for each country. We have to look for the economic structure considering the weakness or other issue of the specific sector, or of the potential of growing and job creation for the specific country or region. Not just look or design some policy, incentive policy or related with tax, but we have to combine all these issues. And other important issue that I think that in terms when it comes to the policy is to see in terms of countries' natural resource and comparative advantage for each countries. I think that this is very important so that we can have a good results when it comes to industrial policy and much when it comes to green industrial policy, because it's other context and it needs more enforcement in terms of policy. When we look for different issues that we see in the presentation, the question that can arise is how can we build a potential consensus, a political consensus with all these policies and with all these issues that we hear now. Probably we still need to think. We have this challenge in our countries, in our regions. We know that the way that we will achieve a better economic growth, creating more jobs and a green environment and sustainable growth is related with industrial policy, but we still have a challenge to see how can we do this properly. We know that we have all these concerns that we see here, all these studies. We still see discussing if the issue is related with the regulatory framework or is related with the capacity building. It's something that I would like to hear a little bit here. We know and we hear in the presentation that the coordination, the leadership from the politician, it's very important to avoid some conflict policy and to bring some consensus. But sometimes it's difficult in the context of the market and the globalization. So this continue to be the challenge. We have the challenge related with technology. This is something that continuing to be a challenge in when we look to the industrialization policy. And more specific, when we look to the green industrial policy, we still have a challenge related with the technology. So probably we have to combine and to discuss a little bit more about all that we hear in the presentation. We have to combine different approach if it is necessary, and we think that it's necessary to achieve the results that we are looking for in terms of green industrial policy. Probably we have to discuss a little bit more about the regulation, that it's flexible for the specific target and so on. I would like to hear a little bit from the presenters about the protectionism, because I think that if we are not design careful our industrialization policy, it can bring some distortion to domestic markets, especially when we are trying to connect it with international trade. And we have some cases in our region, in our countries, related with some inefficiency in the domestic supply when we bring some of these measures to push for the industrialization. So it will be interesting to hear a little bit more on domestic, when it comes to green industry, how can we lead with the inefficiency and higher costs that can come with all these policies that we put in place, trying to push to the industrialization process as quickly or as in the consistent way as we think that it's very important. I will stop here for now.
Thank you very, very much. So next speaker is Arkebe. You have a presentation. Okay.
Is it okay if we stand at that side just because of we've switched the camera?
What do you prefer?
You.
Offset.
I can sit here.
I prefer to be here, if you don't mind.
Yes. Quick, switch the camera on Zoom. Give me 1 second.
Let's go to the end.
You just want the last?
What you saying?
No. Not the last? No. Oh, I see.
Yeah, it's internal.
Hey, my name is Arkebe. I'm a global British Academy global professor located at SOAS this time since 2023. And I have been a practitioner and a policymaker for about 30 years on economic affairs, on industrial policy. My PhD was on industrial policy, and all my publications and co-authored books, co-edited books have focused on industrial policy, economic catch-up, and structural transformation. If I remember correctly, in this hall, we had a discussion on how nations catch up, how nations learn, and Robert Wade was I think, the moderator. This was 2019 before COVID. So if I may, first I have to express the excellent presentations made by professors here and also my sister Minster. And what I'm going to bring in is to add some flavor, to relate it with the reality and practicality, particularly many of you are students, and it will be difficult to understand for you what is even industrial policy. If you have never seen an elephant, how can you draw an elephant? If you have not been able to experience something, it's difficult, it's too abstract. So what I try to bring is to relax you so that you can relate it with the practical elements. So I would bring you to the last slide. This is prepared for another one, but I thought we can look at this. Yeah, currently with the British Academy project, I'm mainly working on researching the greening of African economic development. It's entirely on green industrial policy for Africa. It's funded by British Academy for 4 years, and it's going to involve a lot of field work. The Oxford Handbook on the Greening of Economic Development is an edited book we are working on green transformation, green industrial policy, with Emeritus Professor John Matthews of Sydney, Australia. And we are assembling 50 leading thinkers on green industrial policy to work on this project. It will be released in 2025. Among these books, one is the Oxford Handbook of Industrial Policy, which we edited together with Hajun Chang and other colleagues. And the other one is the Oxford Handbook of Industrial Hubs and Economic Development, because earlier it was mentioned, place-based industrial policy or industrial ecosystem, which we co-edited with Justin Yefulin, the former chief economist of the World Bank. And we assembled over 82 scholars, international thinkers on the subject. So having said this, I want to give you a flavor what industrial policy is. Yeah, so this is Hawassa Industrial Park, which was built in 2015. And this is an industrial park specialized to accommodate, to host apparel and textile firms, leading Asian manufacturers and also leading brands like PVH, which owns brands like Calvin Klein. And this industrial city was designed and built in 270 days, just 9 months. All the design work, all the execution work. This is a complex project. It's not road, it's not energy, it's not a specific project, it's a complex system. And this is what industrial ecosystem means. So 20 companies, leading manufacturers were attracted to invest in Ethiopia, and all was designed to meet international compliance, and all companies occupied the facilities. It was a plug and play system, and they started production in 10 months for 12,000 workers, and at its peak, it created 35,000 employees, the largest apparel and textile hub in Africa. And here, what makes it different is, this is an industrial park with using zero liquid discharge technology. It's entirely designed as eco-industrial hub. Eco-industrial hub means it's a low carbon industrial park. And all the lighting system is LED, 90% of water is recycled, and it's intended that the companies can have maximum productivity and learning from each other. And again, this is a very big one, because it was mentioned by one of the professors about economy of scale. Scale is important, and I'm going to touch about China later on, why China is making a breakthrough in many technologies. So these are some of the industrial parks. This is a pharmaceutical industrial park built in Addis Ababa with the support of the World Bank. Again, it's a specialized park. This is another park, Adama. And here you could see an industrial park and a railway system. This railway is electric powered railway line. This is the import-export. Again, green transportation, carbon neutral transportation. And here, as we could see, this is light rail system in Addis, electric powered. This is, again, the rail system. This is power from waste generated, incineration, and geothermal and solar. Ethiopia has been investing in wind farms, huge investment. And this is in the hydropower, the biggest hydropower being built in Ethiopia, 6,600 megawatt. And ending here, what I want to say is, what we are looking is about green industrial policy. Because green industrial policy is about green energy. It's about green transportation and value system, value chain. It's about end user electrification, like the transportation. And it's about green finance or green bonds. It's about resource use or recycle or this circular economy. So it's an entire array of intervention. So this is not a hypothetical issue. Green industrial policy is a reality that can be achieved in Ethiopia, even countries with low income like Ethiopia. Total of 25 industrial parks have been built in the last 10 years to accommodate manufacturing as a priority sector. I also want to highlight to you an important country that is using green industrial policy is Morocco. Morocco's industrial policy, one of the priority strategic sectors is automotive industry. And it has also been investing in industrial parks. It has been developing an ecosystem which allows maximum productivity and linkages among companies. But also Morocco has been able to invest in solar energy, probably the #1 country in Africa investing in solar, both PV and the concentrated solar system. I'm not sure if I have some pictures, but I would like to show you one picture of Morocco. This is the solar PV built in Morocco. Morocco is using both the technologies in solar. So if we may exit from this slide, I just want to say a few things about green industrial policy. Yeah, you can put it off if you wish. So coming back, the reason that I have brought this from my continent, from Africa, and concrete example is that Africa has to move in the direction of carbon neutral industrialization. The old way, growth and then cleaning the economy, is no more going to work. It's a dead end. And Africa, as a new industrializing continent, has an opportunity to build industrial capacity from scratch. It can be a significant opportunity. And they have been advocating Africa has to pursue carbon neutral industrialization. This is the key issue we need to highlight. And to pursue carbon neutral industrialization, you need green industrial policy. Then I want to say a few things about China on economy of scale. Ultimately, industrial policy is about scale, about competition. So in year 2000, China was not producing any solar energy at all and wind farms. Zero. The leading economies that were producing solar and wind were countries like Germany, on wind, Denmark, and the US. Currently, over 50% of world's solar energy is produced in China. And this is linked with what one of the professors phrased, issue of learning curve, experience curve. It's linked with scale. China is a giant country, and they have been hugely investing inside technologies. The other thing is the EVs, electrical vehicles. Electrical vehicles, China is now producing over 40% of world's EVs and battery technology. China is also now investing on public transport, especially high-speed rail system. And they have built 40,000 kilometers of this high-speed rail system. This is sophisticated technology. This is green. Without investing in public transport, you cannot reduce pollution. You cannot reduce, even if you are going to produce EVs,
it means you are wasting a lot of resources. So from China, what we learn is the importance of scale and productivity, because industrial policy is ultimately about competitiveness. A second aspect is they have been investing together with it on R&D. China now invests 2.7% of its GDP on R&D. 10 years back, it was below 1%. A country to be competitive and pursuing a very aggressive, proactive industrial policy, the priority should be innovation and technology. The country that spends the maximum amount on R&D is South Korea, which is now building one of the biggest chip manufacturing facilities in Texas, costing about 25 billion. So R&D investment is critical. Then an industrial ecosystem is absolutely important. Ecosystem, we are not looking at physical infrastructure. We are also looking at institutions, at skills. So I have to tell you with alarming figures. In China, there are 178 science and technology parks. 178. Giant parks. If we look at the Silicon Valley, which originated in the early 60s, late 50s, it was because of Stanford and also some companies that invested at that time that has become the leading technological hub. It's the biggest worldwide. China has been imitating it, and they are investing in science and technology parks. And additional, they have invested in 2,200 large-scale economical and technological development zones. At local level also, in most districts, they have 12,000 industrial parks. This is the whole ecosystem that is going to support. A few days back, I was with a South Korean friend who was here in London, who knows all the details about the Samsung plant in Texas. And he told me a very fascinating story. We have seen Samsung when they established a factory in Vietnam. They built it in 7 months, hiring 50,000 employees, and they came with their suppliers and sub-suppliers. Now in Texas, they couldn't find the right contractor who can do it on time. So it's a South Korean company building the construction. And all suppliers and suppliers have followed Samsung to Texas. And the main reason was the US, its manufacturing capability has been eroded. The economy, the ecosystem has not been there. So they had to rely by bringing new companies from abroad. So industrial ecosystem is quite important. Investment in infrastructure. Priority has to be given on energy investment, on transportation. These are all quite important things. Then the last point I would like to conclude, when we talk about green industrial policy, we primarily mean, first, industrial policy is by definition a government intervention that accelerates structural transformation and economic catch-up. And when we talk about green, we are linking 2 important aims. First, it's based on the principle that the environmental sustainability and growth can go together. They are compatible. They are not in contradiction. So you have to achieve productive transformation, but also greening the environment and ensuring that we meet the zero objective by 2050. And for this one, investment in technology, investment in industrial capacity is going to be necessary. Thank you so much.
Thank you very much.
Okay, I'd like to invite you to come and sit at the front with the professors. I will sit at the side for the discussion. Thanks everybody for really excellent set of talks.
Okay.
Very good.
Great. I'd like to just kick off the discussion of just a question to the kind of policymakers in particular. So both of you in Mozambique and Ethiopia have had first-hand experience of running industrial policies and countries doing industrial policies. Could you say something a couple of words about the challenges that you faced in doing industrial policy, and what are the difficulties that you had, and particularly, I mean, that from an economist point of view, as was hinted by some of the professors, we worry a lot about industrial policies getting captured by incumbents, and taking this money and using the money not necessarily for the things that we want to, but rather because they have political connections or other reasons. And what kinds of things did you do to kind of guard against that problem in industrial policy, and including green industrial policy? So maybe Enilde, do you want to go first on that question?
Yes, thank you. In fact, it's a challenge to industrialize the economy in our context. First, because we are working in a context of a very reduced fiscal space. And to industrialize the economy, we need to make a huge investment. As my colleagues from Ethiopia said, we have to invest in infrastructure, energy, and other very important elements to industrialize the economy. This is the first challenge that we are facing, because we are working in a very tight fiscal space. And we have this trade-off to design policies to incentive, in terms of fiscal incentives, in the same time, to make sure that we are saving to invest in social sectors like education, health, and social protection. Second challenge is in terms of human capital. We have to invest in human capital, and it's other challenge that we are facing in our countries. And all these issues needs a resource, and we need to improve more. We need to work on taxation to have more resource. And when it comes to taxation, of course, we see that we have new opportunities when it looks to a green industrialization, a new approach of climate change, environment, because we can start working in new taxes that we don't have in our countries. We think that this is an opportunity to increase the resource, but it's something that we still have to work on, to discuss, to see the trade-offs, to define the priorities. And then we need to work in the policies that can attract more investments. This is other way that we can work to industrialize as soon as quickly as we can do in our countries. And then in our context, as you may know, we have one sector that it's very important, and is one of the sectors that used to drive the economic growth, which is agriculture. And we have the challenge to combine these two sectors, because in our context, most of the jobs for the young people comes for this sector, agriculture sector. And we have to industrialize this sector because it's a very familiar agriculture, and we have to link these sectors. This is other challenge, and this needs to change the mind, the approach, to work on agriculture sectors in our context. So this is a little bit of summarize the challenge.
Okay.
At continent level, the main issue is that industrial policy is not pursued as an important strategy. And this comes from the perspective, and we all know the influence of the Washington Consensus and industrial policy was dismantled in many African countries in the 80s, 90s, and the state apparatus was dismantled. So this is one major part, which we observe in many African countries. But when we come to the execution of industrial policy, the critical issues are first in also coping with rent-seeking and cronies. A critical issue is applying reciprocity principle, linking incentives with performance. And the secret of successful industrialization, industrial policy, as we all know in East Asia, has been because of reciprocity. So in terms of reciprocity, the problem is how do you ensure that all performance are measurable, because many of the performance are not easily manageable. So one way that in Ethiopia we have tried to experiment was, or foreign investors, the two instruments have been quite useful, three instruments. One is targeting the best companies. By targeting large and more effective companies, it's highly probable these companies are going to succeed. The second target has been that they are geared on export, because it's easy to measure export earnings and export performance. The third element is creating an industrial ecosystem which makes it easy for faster learning. So reciprocity is a key point I would like to highlight. If I may add, is that industrial policy should not be narrowly understood. It's not about tariff. It's not about incentive. It's also linked with a broader intervention. Key aspect here is an investment in infrastructure. And I have to mention that countries that invest in infrastructure, it's not because they have surplus money. It's because it's a priority. The US invested on highways in the 50s because it was a key priority. So in Ethiopia, the government has been investing significant part of its budget on infrastructure, especially energy transport systems, and same thing, investment on industrial hubs. The government has used about 2.5 billion US dollars in the last 7 or 8 years for building industrial parks. The other critical element, which I hadn't mentioned earlier, is the technological aspect is about universities and technical schools. The critical issue in terms of industrial policy effectiveness, it's not primary school that is important. It's not even high school. The primary element is you have technical schools that can complement the industrialization process. You have the universities. So one of the key reforms in Ethiopia was from 85% social science and humanities-led courses to 70% technology, natural science, and engineering courses, and also expansion of universities. So linking with this is important, and also linking industrial policy with macroeconomic policy is important issue. If exchange rate is not complementary to industrial policy, if inflation is problematic, then industrial policy is less likely to succeed. So macroeconomic policies and industrial policy need to be.
That's fantastic. I particularly love the point about university expansion, because LSE that we're all about that.
Actually, if I indicate a figure, the expansion was from 3 universities, public universities, to 50 public universities that can that have a combined intake capacity of 500,000 university students.
Right. So I'm going to open it up now to the floor. You want to, if you could make some questions, make them quite brief, so we don't have much time left, so I might collect a few questions. So, do you want to ask a question, and then you? Yeah. You're out.
No.
Thanks very much for the panel. I'm great presentation and great reminder of the very rich academic tradition we have from the likes of Alice Camden at MIT, Robert Wade here at LSE. Wonderful to see the combination of policy theory. I just wanted to ask Dr. Arkebe to perhaps give a bit more insight, thinking about how the industrialization and economic transformation that's Southeast Asia, and now looking at the huge progress Ethiopia is making, and particularly your point in macro, sorry, too long, but I'm conscious that we keep hearing the message about with greening industrial policy, technical expertise to pull off huge infrastructure shifts into solar and other power and technology is really so scarce that that's the environment. I wonder if you could.
Okay, thanks very much. And yeah. Yes.
Thank you, Dr. My also question was to you, and I want to comment on especially the sustainability of the financing going on for this presentation, because the industrial park investment require debt, and if you can pay that debt, needed to be repaid, that required industrial balance to be offshoring support related issues that would link them and would force them to engage in global value chains, which means they will not be able to have sufficient linkages within the domestic economy. And some of that learning, I think, could challenge further investment, especially in African countries where such work can be very, very limited. And if you could just comment on possible sustainable ways of investment, that would be very helpful.
Right. Yeah.
So, yeah, I have a question with respect to picking winners and whether there's a role for green industrial policy to pick losers, the kind of brown and declining industries that we don't necessarily want to see, and whether that will kind of facilitate the movement of labor into these other areas that we're kind of the green industrial policy that we're picking. So.
Okay, so let's pick up on the last one on picking winners versus picking losers. Do one of the academics want to talk about how you should think about that? Atkin looks like he's ready.
Okay, I'm happy to opine. Yeah, so in general, I guess there isn't a huge difference between taking resources away from the losers and pushing resources to the winners. I guess the question here are those brown industries, do they have large externalities in other ways? If we think no, then we certainly want to move resources out of them into sectors that do. Again, this comes back to this question that John talked about afterwards is, we think something like a carbon tax will naturally go and discourage these brown industries, and maybe that's first best. And then, maybe we should be thinking about industrial policy in a world absent the carbon tax, in which case then making credit more expensive for these sectors or subsidizing the other sectors may indeed be the most effective way of doing that.
Any other? Okay, so I think the last questions are for you, Arkebe. So Southeast Asia experience and Ethiopia and sustainability of financing industrial policy and that.
Yeah, if I may add a word on this issue of incentivizing losers. We actually are looking at the green transformation. Part of the losers are also joining as a process. And a good example is the petroleum companies, oil companies, are partly investing in solar, wind, and they are moving, they are shifting. So this is one way on how to dismantle vested interest in a way also to address funding shortage. On the issue of financing, for instance, sustainable waste, the best way of addressing the issue of sustainability is leveraging on private investment. And in all possibilities, for instance, energy, in power generation, private sector should widely be able to participate. That is huge investment. But industrial policy will differ from country to country as it relates to transmission and distribution. In Ethiopia, the policy has been private sector can participate in power generation, but transmission and distribution is undergarment, so that low tariff energy can be provided to manufacturing and householders. And currently we see that the financial architecture globally is changing because of the latest US dollar becoming much more expensive, the Federal Reserve increasing interest. It's becoming quite difficult commercial loans as a way to use as alternative for many African countries. This is what I can comment on.
Thank you very much. I think we're unfortunately just out of time. If there's any last remarks any of the panel would like to make before the break? No? Okay, well, I'd just like to thank all 5 speakers for excellent contributions and thanks to the audience for your participation.
Okay, well, we'll begin. Thanks everyone for coming to the final academic session of Environment Week. Please let me remind you, these are the 30-minute sessions. So you are free to ask questions, but please wait until the speaker has gotten through the first few introductory slides. And if you do ask a question, please let me remind you to press on the microphone and speak through the microphone. Great, thank you. Hi, everyone. I'm Hyuk-soo Kwon from Stanford University. And thank you for inviting me to this great conference. And also thank you for remaining of my presentation. And I'm so excited about presenting my paper in front of you. And today I'm going to compare 2 widely used policy options to promote transition from conventional vehicles to electric vehicles. Around 20% of global CO2 emissions are from the transportation sector, and policymakers consider electrifying transportation as a crucial step to carbon neutrality. Therefore, subsidies for electric vehicles are widely used in the world. However, as EV sales increase rapidly, maintaining subsidies puts an excessive burden on government's budget. So some countries started either raising subsidy funds from less fuel efficient vehicles or switching to a tradable emission credit. Raising subsidy funds from less fuel efficient vehicles is called the fee-based policy because it charges a fee on gasoline vehicles and provides rebates to electric vehicles. And fee-based policy is called under different names across different countries. On the other hand, under tradable emission credit system, now EV makers can earn emission credits by selling EV. And they can sell those emission credits to gasoline vehicle makers who need to obtain credits to sell gasoline vehicles. So EV sales determines the credit supply, and gasoline vehicle sales determines the credit demand. California first introduced the tradable emission credit system into the vehicle industry, which is called the ZEV mandate policy. Currently, 12 USA states and British Columbia and Quebec in Canada adopted ZEV mandate. China also introduced the dual credit policy in 2018, gradually phasing out subsidies. Both policies are budget neutral, and in my paper, 2 policies provide equivalent outcomes without market power and uncertainty as in the previous literature. However, today, I will show that the market power in the credit market can break down this equivalence. Credit profits take a significant portion of EV makers' profit. In 2020, Tesla earned $1.6 billion by selling credits only in 11 states. And then its net profit was less than half of its total credit profit. The situation was similar in China, and BYD is one of the largest EV makers in China. And last year, BYD earned the credit profits more than twice as large as the net profit that they earned last year. The market power in the credit market comes from the market power from the vehicle market. For example, Tesla accounts for over 70% of the EV sales in the US, which implies Tesla can control for over 70% of credit supply. So Tesla's decision in the vehicle market can affect credit price. I'm using the data from Chinese vehicle industry, and Chinese market is also concentrated. top 6 EV makers account for around 70% of EV sales, making the credit supply side as the oligopoly. Also, top 6 gasoline vehicle makers account for over 80% of gasoline vehicle sales, making the credit demand side as an oligopoly. So it exhibits two-sided market power in the credit. In this paper, I'm going to answer 3 questions. First, what are the welfare consequences of the policy switch from subsidies to tradable emission credit system? There are 2 impacts. First, it removes government expenditures in the vehicle industry because it moves to the budget neutral policy. And second, it introduces a credit market subject to imperfect competition. Then how does two-sided market power in the credit market affect equilibrium outcomes? And lastly, what determines the magnitude of the market power impacts in the credit trading system? This paper separately evaluates the welfare impacts of eliminating government expenditures in the vehicle industry and also the impacts of introducing credit market subject to imperfect competition. It theoretically and empirically examines how imperfect competition in the credit market breaks down the equivalence between 2 budget neutral policies. Especially, it shows that market power in the credit market can exacerbate the market power problem in the vehicle. So I provide a structural model accounting for equilibrium product portfolios, vehicle prices, and the credit price. And it requires me to find a simultaneous equilibrium in the vehicle and the emission credit market, which is a highly complex task. My paper contributes to 3 strands of literature. First, it contributes to the vast literature on emission trading and market power. To the best of my knowledge, my paper is the first attempt to use Bertrand competition with the heterogeneous products to understand the welfare impacts of the market power in the credit trading system. And in my paper, the market power in the emission credit system is endogenously determined by firms' decisions and the demand and cost structures in the output market. So it allows me to examine how market power in the vehicle market and market power in the credit market can interact with each other. It also adds to the recent literature on electric vehicle credit trading system, but previous papers assume the credit market is perfectly competitive and they fix the credit price at the estimated level. However, fixing the credit price changes the nature of the quantity-based instrument because under quantity-based instrument, the equilibrium credit price should be able to fluctuate.
Just a clarification, are the sellers and buyers different? In other words, what happens if I manufacture both EVs and EVs?
It depends on how many EVs were produced and how many gasoline vehicles.
No, but as a firm,
I
can manufacture both electric vehicles and gasoline vehicles.
So it depends on relative ratio. Let's say government wants the target is 20% of EV sales on the vehicle on aggregate level. But there's a company who is selling gasoline vehicles and EVs and half. Then that firm will be EV firm, right? Because they will be net sellers in the credit.
So it's not per vehicle.
You're right. And then so whether a firm is the electric vehicle firms or gasoline vehicle firms also depends is determined in the mark in my model as the endogenous outcome. And also in my paper I derived the equilibrium credit price as the result of the firm's choices in the outcome market. And lastly, my paper adds to the IO literature by developing an algorithm to find the simultaneous natural equilibrium in 2 related markets using fixed point algorithm. First, let me start with a very simple theoretical model. So in a toy model, there are 2 markets and 2 firms and 4 products. Firm 1 produces gasoline vehicle 1 and electric vehicle 1. And firm 2 produces gasoline vehicle 2 and electric vehicle 2. And vehicles compete in price in the vehicle market. And government determines target EV sales ratio R star, which is equal to the sum of EV sales over the sum of gasoline vehicle sales. Under the feedback policy, the regulator determines the feedback rate fee, which is equal to the subsidy rate on electric vehicles. Then per unit tax on gasoline vehicles should be B times R star. Then by definition, this policy is body neutral. That's because it shows the target equation. And if we multiply B on both sides and move the denominator to the left-hand side, then we have tax revenue is equal to the subsidy spend. Under credit trading system, the same B now works as the credit price, and it's endogenously determined at the credit market. And EV makers can earn 1 credit for each EV sale. So each EVs can earn like a B per unit. And gasoline vehicle makers are required to purchase R star units of credits to sell 1 gasoline vehicle. So they pay B times R star per unit. And in this case, the same target equation works as the credit market clearing equation. Under both policies, the producer price P tilde is equal to the consumer price plus B for EVs. And for gasoline vehicles, the producer price is equal to consumer price minus B times R star. So you can see 2 policies share really similar structure. Even equilibrium conditions are similar. Even B, firms' pricing decisions should be mutual best responsive, and B should satisfy the target equation. So the budget neutrality condition under feedback policy and the credit market clearing condition under credit trading system. But now the equilibrium credit price under credit trading system depends on firms' choices in the outcome market. This fact changes the slope of best response curves and location of the best response curve. And the slope change comes from feedback effect, and the location change comes from the credit price manipulations. The first channel is the feedback effect. So under Bertrand competition, if 2 goods are substitutes, then we have oversloping best response curve. Because if firm 1 increases gasoline vehicle 1's price, then it will increase the residual demand for gasoline vehicle 2. So gasoline vehicle 2 also can charge higher price. But if we allow credit trading here, then the slope of best response curve becomes steeper. Because if gasoline vehicle 2's price increases, it reduces gasoline vehicle sales and the credit demand. And lower credit demand reduces equilibrium credit price, allowing firm 2 to raise the producer price further. For a similar reason, the best response curves for electric vehicles also become steep. The second channel is more important, and a single page can summarize the entire my paper. So this page should be crystal clear to everyone, and if you cannot understand any points here, please raise it. So in my paper, firms leverage their market power in the output market to manipulate the equilibrium credit price. So let's see, there's a firm who mainly produces gasoline vehicles. Then the firm wants to reduce the equilibrium credit price. How? By raising its gasoline vehicle prices or by dropping its electric vehicle price. For example, if gasoline vehicle price increases, then gasoline vehicle sales will decrease and credit demand will decrease. As a result, the credit price can be lower, which is beneficial to the gasoline vehicle firm. On the other hand, if the firm mainly produces EVs, then it wants to raise the credit price by doing the opposite choices. So it will reduce its gasoline vehicle prices and raise its electric vehicle prices. But there is a very interesting fact that a firm mainly produces EVs, gasoline vehicles raise gasoline vehicle price, and then the firm mainly producing EVs raise electric vehicle price. As a result, on average, the vehicle prices in the output market becomes higher exacerbating market power issue in the vehicle market. And it harms consumers. So, yeah.
Just one clarification. So I have a few firms producing gasoline. If I move the price of my gasoline vehicle, then demand is going to shift to those other firms. Right. So this effect on credit, demand or supply might be severely attenuated, might even be zero if all the demand moves. So everybody's selling the same price, I increase my price, and all of my competitors are selling more gasoline vehicles.
So yeah, so you mean that if firms have such incentive, then the firms will have similar the EV sales ratio at the end.
Yes.
Yeah, exactly. That's happening. That will happen in the long run, right? Okay.
I may have misunderstood. Is there a fixed number of emissions credits that's specified?
Yes, it's not. So there are two types of the emission trading. One is the cap and trade that we are most familiar with, right? Where most of us are familiar with. Under cap and trade policy, the government determines the total number of the permits, right? And there exists only one type of the product, it's dirty product. The government wants to regulate the total number of dirty products. But under credit trading system, which is called also rate-based policies or performance-based policies, under credit trading system, now there are two types of products, clean and dirty product. And government determines the ratio of the clean and dirty product instead of fixing the total number of credit. The total number of credit is fluctuating depending on how many clean products were sold, because it will determine supply of credit.
And so there's no, I guess there's no sense in which the gasoline vehicle producer might realize that its choice of price and hence on the demand credit in the future affects that ratio of the future, right? That's what my exogenous change that.
Yeah, let me go back to your point.
Just one other definition that definitely we welfare increase, right? Because it might be the case that I want to push up the price of vehicles because the emissions increase. So if I'm not setting the perfectly, then let's affect this strategic response, basically raising prices. Raising prices might increase, but
yes, that's possible because if vehicles are extremely dirty, so the vehicles are producing the marginal social cost of vehicles is higher than the social benefit, then that's possible. But in my case, what I found is consumer surplus changes in consumer surplus dominates the welfare impact from the environmental issue. So to empirically validate these theoretical findings, I used the data from 40 major cities in China from 2012 to 2018. And I also collected a comprehensive central and local subsidy policy information and the non-financial policies, and they are all composed in the demand estimation. And this is a sketch of demand model that I estimate utility parameters in the standard discrete choice model and consumer price utility for product J in market M depends on consumer price after we consider the subsidies and vehicle characteristics and brand fixed effects and market specific economic variables that includes non-financial local policy and also the demand shock and idiosyncratic preference. And I use the BLB type estimation to get those targets. Using the demand estimate, I recover the cost structure of firms. And here the per period profit of firm F is given as a sum of the marginal sum of the operating profits and minus fixed cost. And I design firms' decisions as two-stage game. And in the first stage, firms decide whether to introduce or remove the existing product. And if one firm introduces a product, then it should choose the vehicle characteristics. And in the second stage, given vehicle portfolios, now firms compete in price. I estimate both marginal cost and fixed cost as a function of vehicle characteristics. To do so, I first recover the marginal cost of the production using the second stage first order condition. And then I estimate fixed cost using the first stage equilibrium condition. So using these the demand and cost parameters, I implement three types of the counterfactual simulation. First, I evaluate the welfare impacts of removing government expenditures from the vehicle industry by comparing subsidy policy and fee-based policy, because fee-based policy is about neutral subsidy. Then I will briefly mention the result and focus more on the welfare impacts from the market power issue. So the fee-based program is more environmentally friendly than
I can maybe invest something in your model. So there's the price of events, right? That's determined in the equilibrium. Are these firms, are they bargaining what the prices or how?
So in reality, as you mentioned, there can be the bargaining, right? Because it's in reality a permit credit trading is like bilateral trading between two firms. But instead of modeling the bilateral trade, I just assume there exists a centralized credit market, and there is only one credit price.
So it's kind of or no, is it so it's like or no, and there's usually a quantity of these.
Yeah. So in the credit market, it's like floodplain because it's like homogeneous product. But in the vehicle industry, when they choose the price, there's a mixture of fair-term competition and here the fee-based policy is more environmentally friendly because it taxes certain products and subsidizes greener products. But removing government expenditures reduces vehicle sales, which were initially suboptimally low due to markup. So the decrease in consumer surplus and profits is greater than government expenditure savings. And in the second the exercise, I evaluate the impacts of imperfect competition in the credit market by comparing fee-based and the credit system, because we saw these two policies are very similar, except for that now firms can manipulate the credit price. But finding a simultaneous equilibrium in the output and credit market can be very challenging because equilibrium outcomes in one market can affect equilibrium outcomes in the other market. So in my setup, the firms can anticipate how their decisions in the vehicle market affect equilibrium price, credit price. And these anticipations should be incorporated in the simulation process for any possible combination of vehicle portfolios and product prices, and which is very computationally prohibitive. But I invented an algorithm that quickly locates equilibrium credit price as a fixed point of the credit market clearing condition, allowing me to simulate the equilibrium in this case. First, these figures show the best response curves of the biggest gasoline vehicle makers in my sample. So what I did is I changed EV firms' prices and the recorded optimal pricing reactions of the gasoline vehicle firms, including SAIC. And here the solid line shows the best response curves under the credit trading system, and the dashed lines are the best responses under the feedback. Due to the feedback effect, we can see the best response curves become steeper with the credit trading under credit trading system. And the size is the gasoline vehicle company, so you want to reduce the credit price by raising gasoline vehicle prices and by dropping its electric vehicle. But if we see the simulated best response curves of the biggest EV manufacturer in these samples, then the curves move the opposite direction. So now we have new the best responses of the firms, and we can find that the equilibrium outcomes given these new best responses. These two charts shows how firms' decisions change in the equilibrium under credit trading system compared to the fee-based product. There are 4 types of products: gasoline vehicle farms, gasoline vehicles, and battery EVs, and EV farms, gasoline vehicles, and electric vehicles. So outside 2 bars are the primary fuel type vehicle models, and inside 2 bars are minor fuel type vehicle. And due to the credit price manipulation incentive, so this one shows the percentage change in profit margin, so it's similar to changes in prices. So firms raise their primary fuel type vehicle prices under credit trading and reduces the minor fuel type vehicle prices. At the same time, firms drop some of their primary fuel type models and introduce more minor fuel type vehicles. So for example, under credit trading system, gasoline vehicle firms introduce more battery EV models because it will promote credit supply and it will reduce the credit price, which is good for gasoline vehicles.
In the model, there's an equilibrium credit price.
Yeah.
In the data, is there a single credit price or do you?
No, there are multiple credit prices.
Why are they multiple?
Because it's like bilateral trade, and there can be like a transaction, right? Search cost and transaction. But in my paper, I do not model like a transaction cost and search cost. Then in that case, it's hard to rationalize multiple prices.
Yeah, that's why I'm asking why there are.
Yeah, yeah, that's
I
because
think
they
they have a theory that mostly.
yeah, and I think it's mostly transaction. So due to those firms change, the decision changes, now the consumer surplus from the primary fuel type vehicles decreases, and these decreases dominates consumer surplus increase from the minor fuel type vehicles. But if you see the firms' profits, both gasoline vehicle firms and electric vehicle firms enjoy profit increase. So if I summarize all the welfare changes into a table, then we have this. So imperfect competition in the credit trading system allows firms to extract more consumer surplus in the open market, and consumer surplus decrease dominates other welfare changes, leading to total welfare loss. The last question is then what factors determine such welfare impacts from the imperfect competition? There are 2 factors. First, in my paper, firms leverage their market power in the open market to manipulate the credit price. So if I provide more market power by merging them, the welfare impacts from the imperfect competition in the credit market becomes more severe. And second component is a firm's product portfolio composition. So here panel A shows the BEV sales ratio of different firms, and these dashed lines target EV sales ratio. And those with the bars above the government target, they are the net sellers of credits, so they are EV companies. And those below the target lines, they are net buyers of credits, so they become gasoline vehicle firms. In case 1, I switched electric vehicle firms, gasoline vehicle models, and gasoline vehicle firms, electric vehicle models. So all the EVs were produced by EV companies, and all the gasoline vehicles are produced by gasoline vehicle companies. Then, in that case, now if gasoline vehicle firms are more gasoline vehicle specific and EVs are more EV specific, then they have much stronger incentive to manipulate the credit price, because they do not need to worry how their decisions affect the profits from the minor fuel type model. So these 2 findings gives us very important policy implications. So my paper argues it is better to introduce credit trading system when EV markets have matured, for 2 reasons. First, in the early stage of the EV industry, there will not be many EV makers, so a few firms can exert a lot of market power in the vehicle industry and in the credit market. And in this, and also in the early stage of EV industry, EV makers like a Tesla and then gasoline vehicle makers like Volkswagen can be completely divided. In that case, if we introduce the quantity-based instrument, then it can harm the consumer surplus substantially. But what USA did is the opposite, right? California first introduced the credit trading system, and then later the federal government introduced the subsidy. So to conclude, the welfare impacts from the policy switch can have two welfare impacts. First, it removes the government expenditures in the vehicle industry, and this part has been studied well in the previous literature. But my paper focused more on the welfare implication from the imperfect competition in the credit market. And it shows that the imperfect competition in the credit market can exacerbate the market power issue in the vehicle market. However, there is also positive parts of the credit trading system. It encourages conventional automakers to introduce more BEV models, and it can make the future EV market more competitive. But my paper considers just the short-run static responses of the firms. And these welfare the impacts can change depending on the market structure and firms' portfolio compositions. And based on these findings, my paper argues that it's better. There is some optimal timing of introducing credit system, which should be like after EV industry has much choice. Thank you for listening to my presentation. And any comment through my email or welcome, and I'm ready to answer your questions. Yeah, that's a clever point. But in my paper, there is a one limitation. My paper only look at this static reactions and the short run impact. But if we there can be many other aspects of the good things of credit trading. First, it's very easy to implement, right? Government does not need to know about the private information of the different firms. That is one thing, and also in the long run, as I mentioned, the credit trading system promote the transition, the faster transition to the EV industry. But what my paper says is in the short run, there can be some negative impact from the losses of the consumer service.
Thank you for including our paper on the agenda. So this is a paper about the effectiveness of trade policy at mitigating climate change, and it's with my extremely great co-author Farid Farooqi at Purdue, who was cited earlier for his deforestation paper. He's doing a lot of great stuff on environment. This is my only venture into climate policy, and I hope that this is not the last. So the idea behind this paper is that if you read the news, there is this general understanding that existing climate agreements like the Kyoto Protocol, the Paris Climate Accord, they have not delivered the desired outcomes. And when you ask economists, now political scientists may disagree with this, but economists claim that the issue that prevents climate agreements from succeeding is the free riding problem. In the words of William Nordhaus, the free riding problem occurs because governments who are acting in their self-interest have an incentive to free ride on other countries' abatement efforts without taking proportionate measures themselves. Now, this is a trade or open economy issue, right? Because you're imposing an externality on other countries. So the solutions to this problem, to the free riding problem, inevitably will have an element of trade to them. So the way we think about it is that we think about two proposals that are kind of the extreme polar opposites of each other. And I'll spend some time explaining these because these two proposals are going to be coming up throughout the talk. So it's important to fix ideas very early on. So proposal one is all about unilateralism, is that if other countries are not cooperating on climate issues, you take matters in your own hand. And the way you do it is that you use border taxation as a second best policy to curb transboundary emissions. So essentially what you're doing is that you're using these border taxes to mimic the first best carbon tax that some countries are not imposing. Now, the other proposal is not to use border taxes as a way to cut or curb emissions in the rest of the world, but as a device to incentivize cooperation, to deter free riding. And that's what we call the Climate Club after Nordhaus. And the idea there is that climate conscious governments, what they do is that they forge a club and they use collective and contingent penalties to incentivize climate cooperation and deter free riding. And the nice thing about the Climate Club model is that it has the potential to achieve first best carbon pricing if everybody cooperates. And also it has the potential of doing that under free trade, meaning that these penalties that are contingent may never materialize. They're just a threat. Now, the reason I wanted to clarify that these are two polar cases of a spectrum is that a lot of people, yes. So that will not really be a club, but you can form a coalition that is unsuccessful. Now, why you want a bigger club is that the effectiveness of trade penalties will grow as the club grows. But essentially what happens, and you'll see this later, is that under some circumstances, like the EU may start a climate club that nobody wants to join because the cost of joining exceeds the benefits. Now, what I want to mention here is about this, the relationship between this and say the EU CBAM. So the EU CBAM is not proposal one necessarily because some of their border measures are contingent. Like they're contingent in the sense that if you revise your carbon price, you become exempt. So it's important to understand that this, if we talk about proposal one, we're not saying that any type of border adjustment is unsuccessful, but this is a second tax that tries to mimic the first best tax, and it's relevant when you think cooperation is not going to materialize.
These are very close to me, because the threat of the carbon border tax tends to incentivize other countries to sign up.
Exactly. So in fact, the threat will a lot of times look like the second best plus something else. Exactly. Exactly. Yes.
And there's also another way of thinking about how the border here. Like the countries trying to do that, they're not helping farmers to gain that they need to, the first base global cooperation outcome. They are just realize that we live in a world where cooperation is hard, so they decide for, maybe domestic politics that they want to have some green policy. They understand this will hurt their domestic industry, and they want to protect them, right? So it's more of a, preventing competitiveness issue.
Yes.
Right. So the issue like it's. Especially in the CBAM when we see it, right? It's protecting domestic farms. So it's not necessarily a remedy. It's not trying to tackle the writing problem.
So yes, that's absolutely right. So we're not saying that what every border tax that is applied is actually there because of it's a remedy right now. It's meant to be a remedy for the free riding problem. But to go back to your point, I think this is actually an important point in the sense that it turns out that the second best carbon border tax is in fact exactly like a border adjustment that is discriminatory by country of origin. So they become exactly the same. Is that when you try to mimic the Pigouvian tax, you end up applying a border adjustment that also levels the playing field for firms in your country. So it takes care of that as well. Now, the way the literature has dealt with this is that there has been a lot of work on these issues. Now, our understanding, we think, is still limited for the following reason, is that determining the maximal efficacy of these proposals is difficult without analytic solutions to optimal policy. And whenever I say optimal policy in this talk, I'm not trying to explain government behavior. Instead, we're trying to figure out what's the best a policy can achieve. Now, it doesn't necessarily mean that governments will be able to implement the policy in a way that achieves the optimal outcome, but it's more so figuring out even if the best possible outcome achievable under a policy is good, and how does it compare to an alternative? And the existing theories that can potentially guide quantitative work on this issue are limited. So this is one place we contribute. And the other thing is that existing quantitative analyses, due to a lack of theory, especially for the Climate Club, because the Climate Club model is difficult to take the data. When we wrote this paper, one of the first people who reached out to us was Nordhaus. He was very excited about having a Climate Club model where everyone retaliates and then figuring out what happens. So previous work has mostly relied on easy to implement policy scenarios that are not necessarily optimal in the sense that they don't uncover the maximal potential of these two proposals. And the way we go about it is the following. What we do is that we first take a very general model in the sense that we have GE effects, we have many industries, many countries, and then we have global climate externalities and a global energy market. And then as a result of the global energy market, we have these carbon supply chains. And what we do in this framework is we derive analytic formulas for optimal carbon border taxes and optimal Climate Club penalties that take into consideration rich GE effects. And then we fit the model in these formulas to data. And with the aid of the formulas in this micro to macro approach in trade, which allows you to do everything using sufficient statistics, we are able to measure the maximal efficacy of these two canonical proposals, which are carbon border taxes and the Climate Club. So the first part of the talk, I'm going to give you a very, very brief overview of the model, and then I'll talk a little bit about the issue of free riding and optimal policy, and then I'll spend most of the talk on the results. So the theoretical framework is basically a trade model with carbon externalities and energy markets. Now we have many countries, and we index countries by I, N, and occasionally J. Each country is a endowments of labor and energy reserves. There are many industries. The energy industry is always indexed by K is equal to 0, and there are final good industries that use energy in production, and they're indexed by 1 all the way to K. And all industries are tradable in this setting, subject to trade costs, and they're all perfectly competitive. CO2 emissions here are determined by energy use. So if you use a lot of energy, you emit a lot of CO2. And the consumption side of the economy, in theory, we can do everything non-parametrically. So and when we go to the data, we have to take a parametric stance. So we do everything CES, but just to present things non-parametrically, you buy all these varieties of goods from different industries and different locations, and then you aggregate them using this utility aggregator, and the price of all these varieties and your total expenditure is going to give you this indirect utility from consumption. So this is how much you basically benefit from all these different varieties of consumption. But one thing to keep in mind here is that the consumer does not internalize these carbon emissions in their consumption decisions because they take them as given. So this is just the indirect utility from consumption. Later, I'm going to show you how you should amend this for carbon emissions to get the social welfare function. On the production side, you have energy being extracted using labor and reserves. And then there's this energy distributor who takes all these varieties of energy sourced from all of these different suppliers of energy in different countries, and aggregates them, sends them to downstream industries for production. Downstream industries use energy and labor, and they give you the output that enters the utility function of the representative consumer. So there's this tiered system where you have energy extraction using labor, energy distribution, and then final production. So whenever I talk about carbon taxation, it happens in this stage, where the energy distributor basically builds this bundle of energy that has a given amount of carbon attached to it, and then the policymaker can potentially apply a carbon tax to this bundle before it is used by the producer in combination with labor. So what is the welfare function in this setting? Now, we had this indirect utility from consumption, but energy is used for production globally, and every unit of CO2 exerts a climate externality on the residents of country I. So the overall welfare is your consumption utility minus this utility from carbon emissions. And this delta parameter is the weight you attach to carbon emissions. If you are a country like Maldives, who is more exposed to climate change because you may vanish due to rising sea levels, your delta is very high. If you're a country in a very cold climate that maybe cares less about rising temperatures and only cares about volatile temperatures, your delta is going to be relatively low. So what is also important here, that remember, you are imposing a negative carbon externality on all the consumers all over the world. And this is why the market or decentralized equilibrium is inefficient. There are two reasons that this equilibrium is inefficient and you want policy intervention. So take the perspective of countryized governments, and what are the two reasons you may want to intervene and change the prices? One is that firms do not internalize their CO2 externality in their production choices, and consumers also take CO2 levels as given. So there is too much CO2 production. Now, the reason you care about your own residents here is that if you only maximize welfare of your own country, you only care about the CO2 externality on your own residents. The other thing is that firms do not internalize their collective market power when pricing their goods. So as a country, you realize that you have unexploited market power, and you can manipulate the terms of trade in your favor. And that means that you can actually use this market power also to impose trade penalties. Now, these trade penalties do not necessarily need to be designed to make your partners worse, but in the climate club model that I talked earlier, they could be designed to nudge your partner to behave in a certain way. So there are two things that happen here. Now, what is the unilaterally optimal policy? This is a descriptive, description of the policy. It's a carbon tax. This is a wedge between the price the distributor is offering and the price the producer is paying. It's just the Pigouvian tax, right? It's deltas adjusted for the price index. And you also have border taxes. Now, border taxes, if you're unilaterally optimizing, they're manipulating the terms of trade in your favor. That's just transferring surplus from the rest of the world to your residents. And they are taxing foreign CO2 emissions. Why? Because if I'm a US regulator, a firm in East Asia, for example, is not being taxed on its carbon content. So when the goods are entering my country, I'm going to tax them at the border based on the externality they exert on my consumers. So what is the efficient policy from a global standpoint? And the efficient policy is one that maximizes a weighted average of global welfare. Well, you'd have to tax carbon at a much higher rate. You have to tax the carbon externality of your producers on all the residents of the world, which means you have to add all the deltas, not from just your country, but all the other countries. So the globally optimal carbon tax is much higher. I'll come back to that, and that's why we have free riding. Border taxes are inefficient, of course, from a global standpoint. And if you have losers potentially from this carbon tax schedule, you want to use lump sum international transfers to rebate the losers. Now, what is the theorem that allows us to characterize optimal policy in this RICH-E framework? And this is just a brief overview of this theorem, and we use this to get simple formulas for optimal policy. Is that when you think about a GE model, what makes a GE model difficult to characterize insofar as optimal policy is concerned is that you have all these GE elasticities. When you change one price in this economy, everything is interconnected. Wages change, quantities of demand for all the goods change, emission levels for all the goods change. In calculating these GE elasticities, the elasticity of these different GE outcomes with respect to policy is very cumbersome. And that is why a lot of the previous policy analyses are limited to partial equilibrium models. So what we find is that at the optimum, and this is an envelope result essentially, these GE elasticities are redundant. So you could actually characterize optimal policy as if this were a partial equilibrium model. As if income was quasi-linear, wages were constant, you still arrive at the optimal policy. And with that result, that's how we characterize optimal policy. But let me but instead of before I go and talk about optimal policy, let me explain the free riding problem also using the stuff I showed you on the previous slide. The reason we have a free riding problem in this setting is that there's a disconnect between the unilaterally optimal carbon tax and the globally optimal carbon tax. If you are acting in your own interest as a country, you don't think about the externality of carbon on the residents of, say, Maldives, how that if you emit a lot of carbon, they may disappear as a country. So you don't price that into your policy. And how do we fight this issue of free riding? So as I mentioned earlier, there are two potential ways to do it. Use border taxes as a second best policy to mimic this globally optimum tax rate, which is much higher than the unilaterally optimal, or forge a club and use collective penalties to deter free riding. And what we use is that we use our analytic formulas for optimal carbon border taxes and climate club penalties to determine the maximal efficacy of these two proposals. So by knowing the optimal carbon border tax, we can tell you what's the best carbon border taxes can achieve. By knowing the optimal climate club penalties, we can tell you what's the biggest club with the most ambitious target you can achieve. And then we can compare the two, and that will give, to some extent, could help kind of organize one's thinking about what's the best way to move forward. So in the interest of time, I'm not going to spend much time on the optimal policy results. I'm going to tell you how we map theory to data. So equilibrium allocation depends on optimal policy, and optimal policy depends on equilibrium allocation. So what we have is we have some formulas that tell you this is the optimal policy given this equilibrium allocation. We have some equilibrium conditions that specify equilibrium outcomes in terms of policy. So you jointly solve this system and you can simulate a counterfactual with the optimal policy in place. And what you need is only a set of sufficient statistics, and that's where we borrow heavily from the micro to macro approach that has become very popular in trade. And those sufficient statistics are just data on trade production CO2 emissions and some parameters that you can estimate using standard methods. So what we do with this data, and the data, I just wanted to give you a sense of how this data looks like. Oops. I think this is not working, but it covers like 19 countries and multiple industries, and it's from the GTAP, and this is the results we get. So I don't think I'll have a lot of time to go into the data, and I think the results are more interesting, so let me spend more time on the results. Remember proposal one? I'm going to show you how effective proposal one is by simulating this counterfactual equilibrium with carbon border taxes. So the way it works here, and this is how we do it, is that suppose governments incorporate carbon border taxes in their trade policy. And what's going to happen is you have this counterfactual where governments start raising their trade taxes. And we want to see what happens to global carbon emissions. We also allow for governments to raise their carbon tax to the unilaterally optimal level, which I think speaks to what you said earlier, because once they have the border tax in place, the disadvantage that domestic firms face is kind of being mitigated by these border taxes. And what we do is that we have a bunch of taxes, we simulate this counterfactual, and we calculate what happens to global emissions and global welfare. And the one thing you may want to keep in mind here is that governments with little care for climate, very low deltas, are not going to do anything pretty much. Like if you don't care, you're not going to tax carbon at the border, you're not going to tax carbon domestically, but you can retaliate with your trade penalties against partners. Yes. You will assign basically the way it will work is that you will apply the delta times the carbon per unit value of these goods that are entering your country.
It is my own delta.
My own delta. So what you care about is your own delta, exactly. So these are the results for select countries. So on the left panel, we have the non-cooperative outcome, and then we just benchmark that by against global cooperation where there are no inefficient trade taxes and everybody is applying their globally optimal carbon tax. So one thing you notice is that there's a lot of heterogeneity across countries in terms of carbon reduction because of general equilibrium leakage effects, but the carbon reduction is 6.4% relative to 41% under the global cooperation scenario. Now, again, this non-cooperative outcome is a combination of domestic carbon taxation and border taxation. So we also want to know what's the unilateral carbon pricing contribution and unilaterally optimal carbon pricing contribution. So let me summarize all of this in one line. So on average, globally, not on average, globally, if you have this non-cooperative equilibrium in place, a 5.4% increase in domestic and reduction in carbon taxes, because these are all negative. So I'm just dropping the negative in the interest of readability. So 6.4% is total reduction. 1% is due to border taxes. The remaining 5.4 is due to these domestic carbon taxes that you're applying based on your own delta, but not the delta of the world. Now, what about global cooperation? If you went from the unilaterally optimal carbon tax to the globally optimal, you will get an additional 35.6%, and you will get a total of 41. So what we're finding is that only 2.8% of this possible 35% is replicated by carbon border taxes. And that's not a big number. And the reason for that, we believe, there are three reasons, two more important. One is that border taxes cannot target non-traded carbon emissions. That's a big deal because a lot of these non-traded sectors emit a significant amount of carbon, and they will never cross international borders to be even targeted with a carbon tax. The other reason is that carbon taxes, the way we assign them at a national level tax, are not just sufficiently granular to target individual firms with high carbon intensity. Now, this is an issue of design. You can, in principle, apply carbon taxes that discriminate across firms from the same country, but that's very difficult in terms of implementation. Like even the EU CBAM has a baseline rate, and then you have to file an application to get an exemption and all of that. So the granularity is not good enough. And then there's GE carbon leakage, of course. So when you change the carbon tax rate, the price of inputs, energy everywhere changes, and that leads to GE leakage effects.
So the second point is that the data
it's a country industry. It's more aggregate than that. So we divide the economy into a total of 19 industries.
So my point is, I guess the EU
that would be much more granular, exactly. Yeah, so in fact, that's a very good point. So if you don't want to discriminate by firms, you can make it more granular in terms of the product level, and that could take care. So we don't have the data, like the international data, to do it at a more granular level, but we expect if somebody had more granular data, this number that we have, 2.8, is going to become larger because granularity is, yeah, exactly.
It may not be very big, but
that's exactly, yeah. Oh, that's a great point. Yeah.
Just one clarification, wasn't clear for me in the model. So is the emissions intensity at firm level staying the same? So there's a carbon tax, but I can't do anything to lower my emissions.
So firms respond with on the input side. So there is an input demand for energy that is sensitive to the price of energy. As soon as you raise the carbon tax, firms, the share of energy inputs or carbon inputs in their production decreases. So there is an endogenous response to that. So now the Climate Club, which basically is proposal 2. What is the Climate Club? Some core members forge a club, and they commit to the rules of membership. They're non-strategic, essentially, in this framework. Everyone else is strategic and joins the club if it benefits them from a welfare standpoint, stays out if it doesn't. What are the carbon pricing requirements? Core members commit to the globally optimal carbon tax rate, but they set a target for non-core members. And that price target is lower or equal to the globally optimal. And accession to the club is incentivized with penalties. So within the club, trade is free. Outside of the club, you're subjected to collective penalties by club members. And then non-members can retaliate. So they can raise their own tariffs on club members. So we ideally want a target for the club that leads to max universal participation, because otherwise you will have decoupling between club and non-club members in terms of trade, because they will retaliate and trade will not be free globally. So to have global free trade, you want to set the right target. And the maximal target you can set is, of course, a function of how many core members you have, because a larger block means more effective penalties and more participation to escape these penalties. So we examine with several alternatives. So one is EU-US. So EU-US as core members is going to be able to have a maximal target of $39 per ton of carbon relative to the social cost of carbon, which is 99 in our analysis. And this universal club of all nations is going to be formed over 4 rounds. So initially, some countries join, as some more countries join. Like at the end of the rounds, China finds it optimal to join, because at this point in round 3, the penalties are so large that it doesn't make sense to stay out. And the reduction we get in carbon emissions is 21%, relative to 6.4 under non-cooperative and 41 under the first best. But change the makeup. So this is what I showed you. If it's only the EU, the target is much lower, and the reduction is 14.6%. But if you add China, if you can convince China to be a core member, you get a 35% reduction in carbon emissions, which is virtually equal to the global first best. Which brings me to the summary of findings, which is carbon border taxes are not effective because of these issues that I talked about in terms of lack of granularity, not being able to target non-traded goods. But the Climate Club is highly effective with 2 big caveats. One, the efficacy depends critically on the makeup of the core members, and selecting the right target is essential, because you don't want a decoupling, you don't want a trade war. And China is a crucial player here. If you get China on board, you basically can get even to the first best. But if China's not on board with a very bad target, you can end up with east-west decoupling of trade, because your penalties are going to materialize and some countries won't join, and that's not a good thing. So the Climate Club with the right design could be effective. The carbon border taxes, however, at least when they are used not to incentivize, but to curb emissions outside of your country, are not super effective. So thank you, and I think I'm out of time.
Thank you very much for the organizer having the paper in the program, and everyone to sticking around up to the very last. This is a joint project with Andrea Chiavari at UPF, Sanpreet Gorai at Stockholm School of Economics, and Carolina Villegas Sanchez at ESADE. So let me briefly give you an introduction why we started this project. So, I mean, it's well known, particularly by you, that climate change refers to the long run rise in temperatures and in weather patterns. And it's sort of understood that firms that are subject to extreme temperature events are going to be facing substantial costs. But then if we think that, as climate scientists seem to suggest, that climate change within a country will impact different areas differently, we can think that firm frictions that prevent the reallocation of inputs towards least affected areas may actually exacerbate the overall cost for the economy of climate change. And so effectively, we're after this micro level cost. So what we try to understand is how to measure the micro losses of temperature fluctuations in demand, supply, input productivities, and then how to bring these micro level elasticities into aggregate level counterfactual. So what is the aggregate general equilibrium productivity loss for an economy which is subject to a rise in temperature? So let me give you a preview of what we find. So this is the last slide you need to follow, and then you can take a nap for the rest of it. So the structural framework So we present a structural framework that is very stylized, but it's going to allow us to differentiate among different channels through which firms may be affected by rising temperatures. And then the structural framework will give us a closed form link between these micro-level temperature elasticities and aggregate productivity losses in general equilibrium. So if you want, for those of you familiar with the literature, it will give us a way to zoom in within the aggregate damage functions that integrated assessment models have been using. So then the next step of the paper is to go to the data and to estimate reduced form temperature elasticities at the firm level, and we will do so for Italy. And what we will find is an inverted U-shaped pattern for firm outcomes. So perhaps unsurprisingly, firm's outcome will be suffered the most out of extreme temperature, whether they are extremely high temperature or extremely cold temperatures. And in particular, we will find that temperature will affect the most firm supply, so firm Higgs neutral productivity, and the productivity of capital. And then we inform our structural framework with these micro-level temperature elasticities of firm-level losses, and we will find that aggregate productivity losses out of climate change. And I will be very clear through the presentation, we will refer to climate change improperly only as the rise in temperatures, okay? So when we will go to the data, we will make sure that we net out all the other phenomena that could be correlated with temperatures. So we find that this is substantial and is highly nonlinear and convex. So it rises more than proportionally with the rise in temperature. And we find that input productivity, so imperfect reallocation of inputs towards least affected areas, account to up to 40% of total aggregate losses. And in particular, for the benchmark warming scenario that we are gonna consider, a 2-degree rise in the average daily temperature within Italy, we find that aggregate productivity losses can be as high as 1.8%. And then we zoom in within the impact of climate change across regions in Italy, and we find that this the effect is highly unequal across regions. So climate change can be very different depending on where it's happening, and we will show that for the case of Italy, we will actually exacerbate existing inequalities across the different regions.
The 6.4% loss is very high compared to 4 degrees centigrade rise.
I mean that was my first reaction is higher than the loss functions used by the integrated assessment model. So, and that's just productivity. So you shouldn't equate this to GDP loss. Okay, so this will be, I mean, we will be clear, but this will be a framework where capital and labor stay what they are, and we look only at, so.
Okay. So you're fixing capital.
Yes, this is a statement not on the aggregate loss of climate change. This is a statement on the aggregate productivity loss. It's not a GDP loss. The GDP loss effectively, this is a low, I mean, capital and labor contracts. Okay, yes. No, it is, so the model is going to be static, so it doesn't really matter. But in the data so far, this is actually a very preliminary paper. We don't have it dropped out, so I have commented more than welcome. We are thinking whether we should also go and see how different are the long run elasticity. But so far, what I want to present are short run elasticity. So why did we expect capital? Perhaps I'll say something when I show the models. Okay, so the model. So the demand side of the model is very, very simple. So gross output is going to be the CS is going to be defined by Y, and this is the CS aggregate of n firms in the economy. With the firm's output is denoted by YI and is differentiated by the elasticity of substitution sigma. And we are allowing the idiosyncratic demand of firms, DI, to be elastic to temperature. So these are going to be one of the objects that we are going to be measuring in the data. But just to say, we are not taking a stand on why idiosyncratic demand differ across firms, and we are not imposing that is elastic to firms. So this is going to be the empirical question, the empirical part of the paper. And just caveat on the notation. So G will be the smallest geographical area for which we have temperature data in our data set. So you can think that this is London, this is East London, or this is Covent Garden. I'll show you the data results. So the supply is also very simple. So it's a Cobb-Douglas production function. Firms produce using capital, labor, and material. Production is constant, returns to scale. And again, we allow firms to differ due to idiosyncratic productivity differences. We don't take a stand on why one firm is more productive than another, but we are allowing the model to have productivities at the firm level that are elastic to that. And just for the sake of notation, I will talk often during the presentation about demand-adjusted productivity, which is nothing more than the product of the demand and the productivity wedges. Okay. So this is the supply. We saw the demand. So this is the firm problem. And it's, again, rather standard. So firms maximizing sales net of the cost that depends on the scale of the operation. They do so subject to the demand function that comes from the constant elasticity of substitution assumption. And they do so minimizing their cost function. So the cost function is nothing but the sum of each input xi times the price of each input, conditional on the production function. Is that the question? No, sorry. So the main part, and there is where we allow input-specific productivities to vary, is that we introduce wedges in the fashion of the misallocation literature. So you can think that these are wedges that create dispersion in marginal products across firms, and these wedges may be elastic to temperatures. So I will refer to this as input productivity. I think it's a bit improper. We are trying to understand how to label them. What I don't want you to think of this as necessarily policy relevant wedges. Okay, that could be a capital adjustment cost. We are not going to be measuring which type of underlying micro foundation is the correct one for those. So we'll be agnostic on that. Yes. 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 I agree completely with you. So this is completely ruled out by assumption, although these things have a flavor of that if you want, then it depends on the interpretation. But we thought that having that wedge elastic to temperature was the most natural. In principle, the model would allow for the elasticities to depend on temperature. Then how we identify that in the data, it would be a different matter, and it would be definitely more challenging. Okay, but so why this model is useful, or we think is useful, is because it allows us to characterize aggregates in terms of firm level elasticities, and particularly temperature elasticity. So we can write down the solar residual as being actually the percentage change in the solar residual due to changes in temperature as proportional to the percentage change in TFP. Okay, so this is total factor productivity out of capital, labor, and material, but we are usually, when we think about productivity in the solar way, we think productivity out of capital and labor. So this is just an adjustment. But what is important, or at least what is useful of the model, that we can characterize the percentage change in total factor, in aggregate total factor productivity as a X neutral and an input productivity part, okay? And I will make clear what these are now. But to say again, the terminology is a bit weird because we didn't want to say that this is misallocation and this is the efficient part. But for those of you familiar with the misallocation literature, these are actually the same terms. So what are these terms? Well, the X neutral is just the percentage change in TFP due to changes in temperature, which is linked to the demand-adjusted productivity wedge. Okay, so effectively, this is the change in aggregate TFP due to changes in productivities or in demand. Whereas the difference between the two then depends also on the elasticities of input-specific wedges. And this, in a sense, is the same insight that we get from the misallocation literature. In this model, aggregate productivity depends on the covariance between productivity and marginal product. So if you are a firm that have a very high productivity, but have very little capital, below optimal, in principle, you can either improve the allocation of resources, not the overall productivity, either by increasing the capital of that firm or reducing its productivity. It's closer to its optimal. Now, normally you don't think about changing the productivity of a firm because misallocation literature deals with policies. But since here we are thinking about natural phenomena that can actually hit productivities, this covariance can vary because of these two margins, okay? And so effectively, you can see the game of the paper. The changes in temperature will be our counterfactor, so this is what we will play with. We need to calibrate an elasticity of substitution and the input shares in production, or the elasticities in production that we take orthogonal to temperature. And then we need to go to the data and measure these elasticities, temperature elasticity at the firm level.
Do you have a story about when you're thinking about how temperature affects the change in their wages?
Yeah. So what we thought at the time is, and that's what actually we find in the data, is that it actually matters only for capital. And it's because you have structures. So if Oxford become much hotter than London, you would like to move. So both London and Oxford become less productive, but Oxford more so. You would like to move inputs from Oxford to London. Whether you can do this or not, it's an empirical matter. And then what we find is capital. So we think, and that's actually where we're trying to go, that adjustment costs to structures slow down the relocation of capital. These are short-run elasticities.
Why does it tend to make it harder to start building?
Moving a building is more complicated than moving a machinery. These are short-run elasticities, right? I'm not talking a long difference over 100 years.
That's a capital friction.
Yes.
Equals a wedge.
Yes.
I thought you were saying that the temperature interacts with that capital to make the wedge bigger.
No, the wedge becomes bigger because of the productivity effect. Now you are less productive, but you cannot get rid of your capital. So your marginal product is sort of changed. So normally with the misallocation literature, we're used to thinking the other way. So given a productivity level, changes in capital changes my position in the marginal product, right? Now it's the opposite. Capital stays there where it is, but now Oxford has become much less productive. So it has too much capital relative to the optimal frictionless one.
So it's
yeah.
That's kind of the same temperature of the fact that the desired.
Yes, that's what I think we are after with this value. It's the inverted logic, because normally we don't think we play around with productivity distributions.
Well, you're just doing shock.
Yeah.
Temperature is a shock, which requires some redistribution.
Yes.
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 So friction is stopping doing
That's what we are after.
There could be any shock.
Any shock that changes the distribution of productivities, yes. Yes. Yes.
This sort of makes it quite crucial. It's a big electrical temperature.
Yes.
Labor is highly. The temperature shock acts through the output elasticity of labor. There's no misallocation problem because labor will become less productive in Oxford and by making it TFP, you basically introduce this uncertainty to life. I mean, then capital becomes equally important because there's a TFP shock. I guess this is not completely neutral in terms of your final conclusion of misallocation. It depends very much on whether the shock is to TFP or the shock is not.
Yes. As I said, I don't want to talk about misallocation. I want to just talk about this. There is a second effect that comes from this. I don't think that you should think about these things as policy relevant. I'm not gonna tell you that anything about policy, and I actually don't want to encourage you too much to think about policy. Okay, so how we can use the model to design an identification strategy? Well, we can see that the log of the sales, so small variables are in log, small letters are in log. Well, sales in the model is going to be elastic to temperature, and it will depend on a bunch of other variables. So this is just the policy function of sales. What I want to take home is just this elasticity. So this elasticity in the model, it's going to have a closed form, a characterization, which is effectively due to the demand-adjusted productivity wedge and the input-specific productivity wedges, or the improper misallocation wedges that I was telling you. So this is a regression you can run in the data, and actually many empirical applied micro papers have run similar regressions. So if I can tell you that I can find a strategy to find these input-specific wedge elasticities, then through the structure of the model, I can get the demand-adjusted productivity wedges. And actually, to get this through the lens of the model, so if you buy the structure of the model, it's quite trivial, because it's clear that, well, marginal product of inputs will only be elastic to temperature if and only if the temperature, the input-specific wedges will be elastic to temperature. So effectively, we can show that the marginal product of input will be elastic to temperature only through the input-specific wedge, and we can run this regression in the data. And once we run this regression in the data for each of the input, we can use this formula to back out the demand-adjusted productivity wedges. Yes.
Those firms are truly above those production function and have arbitrary adjustment costs. Is the claim that what you're calling the input wedge would be the shadow of would always be the right sort of shadow price of the adjustment costs? So
it could be adjustment. We are not taking. It could be adjustment costs, and that could be my preferred interpretation. You like financial friction, it's financial friction. You like input market power, it's input market. It's whatever wedge or whatever friction.
Just picking up on what John clarifying John's point. Suppose I don't know what adjustment cost functions are.
Yes.
No one knows.
Yeah.
But let's say it is definitely comes out of those production.
Yes.
Then is this exactly the right way to measure the effect on aggregate productivity in that environment? Like,
yes,
kind of an
so that would recover the elasticity of the shock.
Right, the effect of the shock on aggregate productivity, but aggregate this by all.
Yeah. So this is the identification effectively. So, well, now it's getting the data, the game. So the data, we use Orbis data between 1999 and 2013. And we couple, so this is a data set that is relatively well known, so I'll not spend time on that. And we couple it with climate data from Copernicus. So this is something that the European Union produced. And it's a gridded data by 0.1 degree by 0.1 degree of meteorological measurements of daily temperature, rainfall, humidity, wind speed, pressure, and a lot of stuff. So for those of you that doesn't know, and they don't know, I mean, I didn't know 0.1 by 0.1 degrees, it means 11 by 11 kilometers. So it's very granular. And then what we do is we merge the firm's postcode with these grid cells. I mean, so this sort of allows us to populate this grid cell with the firms. I won't have time to go into the detail of this, but of course there are concerns of multi-plants firm or these things. We cannot get the address of firms with multi-plants, but we can identify which plants are multi-plant and get rid of them and make sure that our elasticities are not driven by having misplaced firm on the geography of Italy.
But that exercise drops, you know, all the firms in the economy. So
it drops the 2-3% of the largest one. It's a robustness. It's just
40%.
I don't know this number for Italy.
But
Okay.
I mean, one thing you could try is having a social data to match the things that.
But would you know the address of those firms?
I mean,
Okay. Okay. Well, that's a great point. Thank you. But okay, so far keep in mind this caveat. So these are the data in one slide. So here is the evolution of the average daily temperature in Italy between 1950 and 2020. We will use only this sample period for which we have firm level data, but as you can see, the average temperature increased quite a lot. But that's what I care the most, because this is where our variation in temperature will come from. So this is the average temperature in a grid cell in Italy. So we will use much finer variation. So we will use the entire distribution of day temperatures within these grid cells. But you can see Italy is having a lot of mountain chains, has huge variations in temperature, even in very narrow areas. So here we are zooming around Tuscany, and you can see that some provinces go from being relatively cold to relatively hot. Okay, so these are the data. And as I said, we populate these grid cells with so the empirical analysis. So this is our main regression. For those of you familiar with the recent JP paper, this is actually a regression that has been run already on sales in India. What the model gives you is a structural interpretation of those elasticities there, okay? And again, the grid cell are those grid cells. We have sector time fixed effect. We allow for firm level fixed effect. We have region time trends. We control for rainfalls. We have global financial crisis and sovereign default crisis, region times dummies, non-time dummies, just region dummies to control for the exposure of these regions to this major recession over this period. And then we cluster our standard error at the grid level. So this is our main regressor, and we take this from Somanathan et al. In JP recently. So we have a distribution of daily temperature in each grid cell. So we summarize it as a day count for each of these partition of the temperature space. So effectively, you can think this is London. We have 10 days in the year that is below 0, 20 days that is between 0 and 15, and so on, until you have a non-overlapping sum of days that sum up to 300.
On what year? I think the exercise that you might model was that like Rome gets hot, and so we want to move things to them in sort of like a dominant equilibrium. And here we'll think about what year in Rome we wouldn't really expect them to move over to Venice and then move back the following year, cold again, move back to Venice, cold again, back to cold again. Like give out some parts of the case around.
I mean that's definitely what you're saying. I mean, this is a static model, so it doesn't put that much structure. In a frictionless world, it would relocate things immediately. Yes, you go from Rome to Venice all the time after you have a marginal stuff. That's definitely true.
So you would like us to think of the implications as equilibrium is here?
No, I mean, I'll say something about interpretation. But so far, think about this. These are short run regressions. And then you can either think, I think in so far, you can have two interpretations. So one is that these are the cost of short-run fluctuations in temperature. I think the model allows for this way of thinking until we don't have longer run regressions. Or this is sort of an extreme scenario where you take these short-run elasticity and you think they are structural and they will remain the same for the next 100 years. And so this is sort of a doom scenario where you don't have any form of adaptation or things like that. I think the first interpretation is more correct in terms.
Then thinking about that, the underlying data generating process, like why in response to what you would buy a durable permanent investment to buying a machine like they can't.
No, they don't.
Our
data will get that that's what I started to do, right? And otherwise they would respond. I have 5 minutes, so okay. I'll be shorter than. So this is the first regression. So here you have sales, material, labor, and capital. And as you can see, one extra day above 40 reduces the sales of a firm by 0.8%. Whereas one extra day below 0 reduces sales by 0.15%. And as you can see, materials and labor contract by a similar fashion, whereas capital doesn't move at all, okay? So the second regression we run, so this is for sales, and so this is like sales and inputs, is for marginal products. So I guess the second step of the identification. And that's a mirror image of the input behavior of the previous regression. Marginal products of material, marginal revenue products of material and labor, they do not move as this input can contract sort of freely, at least that's what the data suggests, while the marginal revenue product of capital contracts, right? because I mean, it's unlikely that you will do big investment or big investment out of this kind of things. And you can see that it does so substantially and statistically. Through this, we can back out the demand adjusted productivity temperature elasticities. And we have in the paper, we try also to separate demand versus productivity, and we find that comes mostly from productivity. But I want to take my last minutes to summarize the aggregate results. So we can go for the break. So these are the formula of before. I sort of gave you a strategy to get these elasticities, these firm level elasticities. And now we're just gonna perform counterfactual, where we add to each day of the year in Italy, in each of the grid cells, so all over Italy, 1 extra degree Celsius, 2 extra degrees Celsius, 4 extra degrees Celsius. I mean, and we can go on and on. And so this is the main finding, this table. So the main decline is by 1.8, and the X neutral is 1, and 0.8% is the one due to these marginal products. I don't know if this will work, but yes. So this is just to give a sense of the magnitude. This is just a very rough comparison, so take it with salt of grain, but these are our estimated production losses, productivity losses. And this is what Barrage and Nordhaus recently used as a loss function. And this is the Cruz-Smith 2022. So this is just to give a sense, because the first time we saw this number, we thought that they were incredibly small. But when you look at the aggregate loss function that the literature used, we are not far off. And actually, we have some extra amplification. So I conclude on this figure, so we can perform this counterfactual of this model in every province of Italy. And as you can see, I don't know how much you can see, but this bar is wide. So this is a 2 degree Celsius scenario. And you can see that in the north, it can go almost up. And this is just because you're moving on the increasing part of the temperature elasticities at the micro level. So you're going to very cold, a bit better. Whereas most of the country, and particularly the center and the south, will be moving downward much more than the average. So this can go as low as minus 3.12%, the loss. So the aggregate one is 1.8. And so in a sense, for Italy, where the poorest part of the country coincides also with the hottest one, we can see that climate change, at least through the lens of the structural model, may exacerbate existing inequality. And I conclude here. Thank you very much for your time and your questions.
I was just going to thank, this is the end of all the academic presentations, just to thank everybody who's made it all the way to the end for a fantastic environment week, the very stimulating set of papers and also discussions. So thanks very much for being here. This is our second environment week, and we hope most of you will attend the third one, which we'll intend to have next year. We have a final event in an hour or so, 6:30, on green industrial policy. So you should all, if you come and attend that, will be a very exciting last finale to the week.